Hey there Python enthusiasts! If you are ready to level up your coding game in 2024, you have come to the right place. In today's video, we are diving deep into the top Python libraries to learn in 2024. Whether you are working with data science, machine learning, visualization, or building GUIs, I have got you covered. First, we will explore the power of NumPy by mastering arrays, operations, and matrix manipulations for faster computations. Then, we will jump into Pandas, the Swiss Army knife for data handling, with in-depth demos on data frames and indexing operations. Of course, visualization is key, so I'll introduce you to Matplotlib and Seaborn for stunning plots and Plotly for interactive visualizations. Imagine scatter plots, histograms, and even 3D graphs, all at your fingertips. Next, it's time to sharpen those machine learning skills with Scikit Learn and boost your statistical analysis with SciPy. We will even dive into PyTest for better testing practices and wrap up with Tkinter, the go-to library for creating sleek Python GUIs. So stick around till the end because we have got practical demos and hands-on examples throughout, and we will end things by designing a Python game on Tic Tac Toe. Let's jump right in.
Now we'll start off with this library called as NumPy, which stands for Numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, NumPy should be your go-to language. And this library called as NumPy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first NumPy array. So you can have a single dimensional NumPy array or a multi-dimensional NumPy array. Now we'd have to start off by importing this library. So to import NumPy, we'll type in import NumPy as NP. So this NP which you see over here is known as the alias. So we are importing the library NumPy with this alias NP. Now this NumPy library has a lot of methods, and one method is called the array method. And with the help of this, we will be able to create the NumPy array. All we have to do is type in np.array, and inside this I am passing in the list of values starting from 10 going on till 40, and I'll store it in this object called as n1. And when I print it out, I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here, and inside this we have two more lists. The first list comprises of the elements 10, 20, 30 and 40, and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as NumPy. Now I'd have to import the NumPy library. So I'll have import NumPy as NP, and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the NumPy array. So for this, I'll have to use np.array, and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40, and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this NumPy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this NumPy array. So I'll have type. Inside this, I'll pass in n1, and as you guys see, we get the result numpy.nd array. So nd array stands for n dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4, and the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out N2 over here. And I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1 cross 2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1 cross 2 NumPy array where the values are only zeros. Similarly, over here, I am creating a 5 cross 5 NumPy array where all of the values are zeros. So I'll just use np.zeros and inside this I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this NumPy array. Now if I want maybe a NumPy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 NumPy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3 cross 3 NumPy array which comprises of only zeros. Now if I want to initialize a NumPy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in two parameters. The first parameter is the dimension of the NumPy array. The second parameter is the value which we'd want to insert into this NumPy array. So here we are creating a 2 cross 2 NumPy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 NumPy array where we only have 10s. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in two parameters. Let's say I'd want a 4 cross 8 NumPy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 NumPy array where the value is only 5. Now similarly, if I want to initialize a NumPy array within a particular range, then I can go ahead and use the arange method. So here, as you guys see, I am using np.arange, and this again takes in two parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement arange method over here. np.arange, and I'll store this in n4. Now I'd have to use np.arange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200 and I'll print out an 4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this NumPy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a NumPy array with random numbers. And to initialize NumPy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22 and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers, and this will take in 3 parameters. Let's say I would need values between 50 and 100, and I would need 10 random values over here. And let me store this in n5. Let me go ahead and print out n5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list we have 1, 2 and 3. In the second list we have 4, 5 and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns, and this is what the n1.shape gives us. Now if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list I'll have values 10, 20 and 30, and in the second list I'll have values 40, 50 and 60, and I'm storing this in n6. Now once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape, and we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape, and over here I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, head stack, and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20, and 30. Then we are creating the NumPy array n2 where we have the values 40, 50, and 60. Now when we use vstack over here, this again takes in two parameters where we'll just pass in two NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1 comma n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack two NumPy arrays. So n1 and n2, we've got the same NumPy arrays over here. And instead of using vstack, I'm using the head stack method. I'm passing in n1 and n2. And as you guys see, 40, 50, and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these NumPy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these two NumPy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what would be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the head stack method. So here I'll type in np.hstack, and inside this again I'll pass in n1 comma n2. And as you guys see, I have stacked n2 at the back end of n1. Now, if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack, I'll give in n2 comma n1. And I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in n1 comma n2. And as you guys see, I have n1 in the first column, n2 in the second column. Similarly, if I give in n2 comma n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the NumPy arrays. Now we'll also work with intersection and difference methods. So here again we have two NumPy arrays. So in the first NumPy array we have the values from 10 to 60, and in the second NumPy array we have the values from 50 to 90. And if I want the common elements between these two NumPy arrays, then I can use the intersect1d method. So here in the intersect1d method, I would just have to pass in these two NumPy arrays. And as you see in the result, we get a new NumPy array comprising of the common elements in these two NumPy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1d method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1d, and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the NumPy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the NumPy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect 1D and setDiff 1D. I'll just add a comment over here, intersect 1D, and I would have to create two new NumPy arrays. I'll have n1 over here, so I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6, and I'll have n2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect 1D. So I'll have np.intersect 1D, and inside this I'm passing in n1, n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now if I want only the elements which are common to n1, then I can use the setDiff 1D method. So here I'll have np.setDiff 1D, and inside this again I'll be passing in n1, n2, and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np.setDiff 1D, and I'll just change the sequence over here. Instead of passing n1, n2, I'll have n2, n1, and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1, n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays. And let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array, and over here I'll have 30 and 40. I'd have to pass this on as a list of values. So I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1, n2, and actually I'd have to pass this as a list. So I'll have n1, n2 over here, and as you guys see, the resultant comes out to be 100. Now if I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1, n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60 because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows. So here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40 and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19 and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10 and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array, and inside this I'll have 10, 20, 30 and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35 and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25 and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3 and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if you want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. Till now we've worked with some basic NumPy arrays. Now let's go ahead and work with the NumPy metrics. So here we are creating a 3 cross 3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6 and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1 and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1 and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this NumPy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here. And since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2 and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in NumPy matrix over here. Now that this is set, I'll have np.array and over here I'll have a list of lists. So in the first list, I will have 10, 20 and 30. In the second list, I will have 40, 50 and 60. In the third list, I will have 70, 80 and 90. And I will go ahead and store this in N1 again. Now I'll go ahead and print out N1 and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in N1. And inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write N1. And over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows and all of these rows need to be from the third column and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows would be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row which became the third column over here. Now we'll see how to perform two matrices. So over here we have N1 where we have the elements starting from 1 going on till 9. Then we have N2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50, and 40. After this, I'll have 30, 20, and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load, and over here I'd have to give the name of the NumPy array. So it will be save_n1.npy. Let me actually remove this over here, and I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result.
Now today we will work on two important packages, and we will do a case study also, complete end-to-end case study of how to, when a data set is given, what are you going to do as well. Okay. So with that, so we will discuss one package called Pandas. Pandas was again built on top of NumPy itself. Okay. So what is this Pandas? How different it is? What is the speciality of this particular package for us is, it will help because data is not always in the form of an array. Correct? Data will have, obviously data is in the form of array only, multi-dimensional array only. You know what is a table? A two-dimensional array, right, with lot of different values. But if you want to work on that particular thing, what are all things that we are more got used to, a concept called table. Right? What is a table? It's a two-dimensional, right? Stuff data with different data types stored in it. And most importantly, table for me looks like a column. A column will have a name. Now, have you ever seen a table with a row name? That's exactly data frame is, in simple lines to understand. So what is data frame now? What is the advantage of having a row name? Normally rows will have a row number, correct? This is 1, 2, 3 like that. Let's say similar to index. Indexes, we know always indexes are difficult to understand. So we know this row belongs to a particular student. This row belongs to a particular customer. This row belongs to a particular stock. This row belongs to a particular company, whatever, right? I know column, this column is mark, this column is stock price, this column is sales revenue, whatever. Similarly, can I have a name to the rows also? If I have row name, what is the advantage? So you know what exactly you are doing with it. Otherwise, the operation is same. Right? So that's what exactly is our data frame is all about. So data frame, this is a nomenclature that if you can understand, this is what we'll use consistently so that you will understand it. You already, most of the things you know already. What is this? Column names you know already in this data frame. Okay. And index label. This is an index. Every row has an index. By default, the index is 0, 1, 2, 3 like this. We know that. If we want a specific name to be given to that, we can give a index label, a different index also. Okay. So, and index access is equal to 0 means row. Access is equal to 1 means similar to what we have seen in NumPy. And whatever that is there in between is called data. And if the data is not available, it is considered as NaN. Not available kind of a thing. Okay. So these are called missing values. That's it. If you understood this, we can now do a deep dive. If you have this, let's apply some. See, always learning should be starting from known to unknown. What exactly we know with if a data set was given to you, you are not a data analyst. You are not trained on this particular ML or whatever this algorithm or courses. What normally you do with a data set? If you look at this thing, what do you do? What sort of operations you do? You look at the data first. You'll see all the data. If the data has 10,000, 100,000 records, what do? You try to see first few records, is it? You'll not go to the entire thing. Correct? So you try to see the first few records. Hey, show me what is this data is. First of all, you'll ask what is this column? And you try to understand what is this column type. What is column type? What it will help us? It's a numeric data type. What are the data types you know? Number, string, or a boolean. In our data science terminology, we call as categorical variables, numerical variables. Okay. So what is numeric variable? A number. What is a categorical variable? This is a category. In data science, you will never ever work with unique values. For example, customer name. Do you analyze customer name? You will not do that. Because customer names are always supposed to be unique kind of a thing. Right? Even if it is not unique, we'll have a unique value for that customer ID or something. So we will never analyze a customer name. What we will analyze? We may analyze his date of birth. We may analyze his years of experience. Or we may analyze his number of products he sold. That is what our data is. Correct? For example, if a customer has bought a product. So product is a data point to me. But it's not just a string. It is a category. Correct? It's a repetition is possible. So these are all called categorical variables. So in the again categorical, you have ordinal, non-ordinal. You learn all these things when you are learning statistics and basic things. So there are different types of data that you analyze in a statistical way, right? That particular thing you will do anyhow. It is not numeric, non-numeric first of all. Categorical is non-numeric, right? For example, customer product, what a product he bought. So this is a categorical variable, data. There's a category, which product he bought, correct? And else, what else? His gender, male, female. It's a categorical variable, right? What is the order type or the shipment type, where he is trying to ship the product, right? Shipment type is home delivery, office, whatever, right? Or through what means of delivery it is. Shipped through air or through road. Shipment type. What is it? Again, it's a category. It's not a number. Correct? So when you have this data, then you look at the data types, then you look at the initial values, and then what else you look at? What else you do? That's exactly what we are going to learn today. How to do it through Python. That's it. Otherwise, whatever I am going to show you today, which you already know. We are only trying to learn how to do it through. If the data was given to you in Excel sheet, what do you do with the data? You try to understand each and every variable one by one. So in each and variable, if you are numeric data type, the way you look at the data is different. If you look at a categorical data, the way you look at it is different. For example, if it is a numeric field called sales revenue, how do you look at the data? What are all things that you try to understand from the data? You try to understand what is the minimum sale, what is my maximum sale. This is called range. What is the minimum, maximum, range? What is the average sale? That is another value, right? So what is average is nothing but mean, correct? But averages are always dangerous. Why? There is a word called outlier. Everyone understand what is outlier? There's no need to worry. Outlier means the biggest value for now, or the smallest value. If all the, for example, let's say all the average of age in this room, right? Most of us are in the same range, let's assume. And if you have an outlier, so what happens? The average increases, right? And if I have a 5-year-old boy sitting in this room, then that means average might not give the actual, trying to get the proper understanding of the data. Because it will get pulled towards usually the extreme values. Let's not call it the outlier, right? We call outlier for the different concept. The extreme bigger values or smaller values, extreme values, we call extreme values. Right? So these extreme values will be pulled by the mean. So that's why there's another concept called median, which is nothing but 50th percentile. Have you heard a word called percentile? 10th percentile, 20th percentile. Right? So percentile. So what is 50th percentile? That means exactly among, if we put all our ages in an ascending order, I'll take the middle one. That will also tell me what is the average age of this kind of, it is better than the average. So median is also an average concept only, right? And then what is the common age factor that is there? That's called mode. Most of us are 32, let's assume that the 32 is the mode, correct? That is a common thing, right? And else what is the variance? How much of spread it is there? What is called variance? Variance means variation of the data. You are 32, I am 39, somebody is 47, somebody is 36. There is a difference between the mean and your values, right? So what we try to, with the help of a mean as a value, as a base, we try to see how much of variance in the data. Example, if the variance is very high, that means there is lot of spread in the data. It is not actually closer. If the variance is less, that means more or less, everyone is of the same group. Right? By how means? That is exactly called standard deviation. Variance is usually not in the same metric, what that particular parameter. For example, age is in numbers, right? The metric variance might be in some other metric. Because you do a square of it. So now I'll not get into the formula of it. The simple formula is your value minus mean. Simple for now. Just understand this. So then we'll sum it up and then divided by number of data points that I am trying to get it. And I'll get a variance. So if then some value, for example, the mean is 30 in this room. Let's say the average mean is 30 in this room. His guy is 32. Let's say I am 27. What happens now? Plus 2, minus 3, minus 1. So something will be plus, something might be minus. To dissipate these pluses and minus, what you do is you square it. You want to find the average, right? So there are some pluses and there are some minuses. Now what is the total variance that you want to calculate? And then you average it. That's called exactly the variances. So in this process, if there are some positives and there are negatives, I don't want that negatives to take away those positives. So what I'll do is, I'll square it. 2 square and 3 square. I'll say the square of it. So 2 square is 4, 3 square is 9. 9 plus 4, 13. 13 divided by 2. Then you'll get the variance. This is in roots. This is in square because the average is also now the variance is also in square. Then I'll take a square root of it because I did a square. I'll do a square root of it to bring it back to the normal scale. Then I'll get an exact variance. That is called standard deviation. So we talked about standard deviation, and then we discussed about now categorical variable, right? For example, now categorical variable like what is your education qualification? Degree or a PG or a PhD, whatever, something. So if I want to count how many degrees are, then we will not do median and mode here, right? Median or mean we will not do. What we can do? We can do mode. How many? What is the average? What is the most common qualification in this room? Is it degree or post graduation or a PhD? We can say that, right? That is exactly is called mode. Okay, but will there be mean or median for this? No. So usually what you do, you will count. How many means are there? How many degrees are there? How many postgraduates are there? How many PhDs are there? We can do even count. Correct? This is all called univariate analysis. That means I am only analyzing only one variable at a time. Now if I combine two variables, that is called bivariate analysis. What is bivariate? It means more than two here. Or multivariate analysis. So I can combine degree with my salary and try to understand what is the salary for each particular kind of a category. What is so degree have different salaries. Postgraduate have different salaries. Doctorate have different salary figures. From this, looking at this number, I can understand certain things. What is the average of degree salary? What is the average of postgraduate salary? Will it help me to understand the data better now? What are all these things called? Analysis. Just we are trying to analyze, understand the data. And not even analysis. We call it simply as understanding the data or summarizing the data. Correct? What are you doing? We are summarizing the data. Correct? So, this particular thing we do it every day almost. If you go to cricket, right? We all play cricket. We will say, what is Shikhar Dhawan's average overseas? What is Shikhar Dhawan's average in a particular country, against a particular country? What is Shikhar Dhawan's average against right-hand bowling, right-hand fast? What are all these things we are analyzing? We are analyzing two variables now. Correct? The batting and the batting scores, the runs scored with the type of the group. What is the group here? It might be overseas and India. It might be type of the bowler. It might be. So what is the type of the bowler? Is it a categorical variable or a numerical variable? Fast bowler, medium, spin, left arm spin, right arm fast, left arm fast. All these things are categorical variables. So you can analyze data in multiple ways, isn't it? What else you do? You do this grouping also, no? So this is nothing but grouping. Now we are grouping by something and then doing an average. So grouping we do. Filtering we do. We'll take only overseas data. We'll not take, India data. That is what are we doing now? We are taking overseas. And we are going to analyze only with fast bowler. Then we are cutting the column wise. Row wise, column wise, slicing, dicing. Again we'll also do data frames. Filtering, that's what we do. What else you do? If there are missing values, we have to work on those missing values. And the data is in two different data tables. And you got from Excel sheet, other from data tables. Usually in Excel sheets and all, what you do? You do create a cross tab. You create a pivot table for this analysis. That's exactly we do. So now let's learn all those things, how to do with. And in this process, certain things, normal aggregation numbers itself is fine. Sometimes we want to visualize that also. Not just the number way, we want to visualize that also. First thing is python.org. See, another interesting thing for people who are now doing coding or first now starting coding kind of a thing or restarting coding, whatever, right? Most of the times these codes are already written, but for a specific purpose. For example, you want to know how to define a function, how to create a function for doing certain activity, right? So what you do now? You want to get the syntax. The syntax you will get it directly from the reference document itself. But you don't write the logic. Where do you struggle normally? Logic or the syntax? In writing the logic. So logic, how to get it? That's what there you need to understand what are all tools available to me. Okay. I'll show you one thing. See, normally who does is this particular thing, different people will write different blocks. there is an analytical computation platform called Kaggle. Have you heard about a platform called Kaggle? Kaggle. So what Kaggle is? It's a platform where companies come and run their given opportunity for all the data scientists. It's an open source platform where they'll give a data set, they'll give a problem statement to you. And they'll ask you, come on, this is the metric I'm looking for to improve. For example, Netflix, they already have movie recommendation stuff. You know, Netflix company, right? They have a movie recommendation engine they have already built. Currently, their metric accuracy is around, let's assume 84%. With the data that they have built, with the algorithm they have used, 84% they are able to achieve. Now, they'll keep that particular thing in Kaggle and say, boss, this is my 84%. Can you help me improve it? Whoever does the best improvement will get a prize. Right? So that's how they put it. Usually commercial things won't come to Kaggle. Non-commercial stuff will come to Kaggle. Example, they want to find a rare species in a forest. They have collected a lot of sounds of different animals. And they want to find whether that animal exists in that particular thing or not. And you want to classify all the sounds. Correct? So whoever correctly able to classify that will get a prize. So these people who are winning the competitions, what they do is write a blog. If you look at the entire Python stuff now, right? So it is the Python, what you are going to do now from after this class onwards is not about Python program as such. It is all about, that's why today we'll case study will help you understand the process better, and then how to find for that particular things also better. Absolute basics, right? You get the basics correct so that you, whenever when somebody writing a program, now you're able to understand and read it correctly. And then you can start writing as well. Because now you know what exactly things to be done. Okay, before you get into data frames, you have to understand two important things called series and data frame. Right? So data frame is a multi-dimensional thing, correct? A series is a single dimensional stuff. That's how you understand. Series is also similar, very, very similar to data frame, but data frame is a multi-dimensional, but series is a one-dimensional. Series also will have an index label and a column name. Correct? That's what you can simply understand. For example, I created a series, pd.series 1, 3, that means what internally I have given, a list only I have given. And in this there are null values also. Whenever you have a null value, how do you pass it? np.nan. Okay. So like this you have passed. Now what is this? Now this is the row label, correct? This is the row index. And this is the column for it. What is the data type of it? It's a float. Now if let's create a data frame also. How do you create a data frame? Say I did pd.date range some date I have given, and periods is equal to 6. Since I didn't give any frequency, by default it takes date as a frequency. So what this particular function will do is it will create a series. It will just simply create a series of ranges of 6 numbers. For example, look at the print the dates. Now you see 1, 2, 3, 4, 5, 6. Frequency is equal to D and everything. It's created some range, some dates. Now I want to create a data frame now. I'm creating a pd dot similar to pd dot series or right. We have created a np dot array kind of a thing. Now we are creating pd dot data frame. What is the first value? Is the values. What all values that should go into data frame? I'm using NumPy only here. np dot random dot rand 6, 4. What it will do? Tell me. That means rand n means it's a normalized data. So it will create some random numbers, floats only. Okay, and then it will create it. For this particular thing will only create this thing, right? Now I am giving some names to it and some row names also to it. That's what the difference between a normal array and data frame we discussed now, right? So otherwise it's a multi-dimensional array only. index is equal to, that means index, that means the column index. That's the name we discussed now. Index is equal to dates. That means these are the indexes. So ABCD is converted into now A, B, C and D. It's a simple thing only. Okay. So now we understand what is this data frame looks like. What is the column? What is the row index? Okay. How do you understand this example is, don't go by this range and all. You try to understand how a data frame is created. Data frame is created, first one with values. Second one is index label or the row label. Third one is the column label or column index. So now if you look at this data frame, if I want first row from this data frame, so what I can do? df square bracket 0. What it will do now? Sorry, first row will get it. But row has a name now. Instead of row number based, I can say df of the index name also I can give. Df dot column name also I can give here. Dot, this is a dot operator. Df dot A, df dot B, df dot C. I want second and third columns. Now df of, you can give the list of the names. We'll see all that thing, how to do it. Let's learn Jupyter a bit more now. Help and keyboard shortcuts. What is the new thing? Shift enter or control enter. What is the difference between shift enter and control enter? Shift enter will move your cursor to the next command, whereas control enter will stay there itself. Will execute the command and then will stay there itself. Okay. Similarly, if you want to insert a row, example, I am here. I want to insert a cell now. How can I insert a cell? Here you can say insert cell above, cell below. Example, cell below means, so cell above size, it says inserted a cell. Where am I now? Here, right? So if I want to insert one more cell, insert cell below. So it is inserting one more cell. This is how. And there is a keyboard shortcut also for it. What is the keyboard shortcut? If you look at, there are two types of command modes. One is the escape mode, which is a command mode, and the other one is the edit mode. Two types of keyboard shortcuts for you. One is for editing the value and the other one is the command related activity. So in that, there is a command called A and B. A means insert cell above, B means insert cell below. So one way of inserting a cell below, if I am here, right, I want to insert one cell below now. So what I can do is go to menu, insert. The other one is escape and B. Escape A. Are you getting the thing? These things slowly you learn one by one. Without using mouse, you should be able to. Is it a rule that you should not use mouse? To improve your productivity, that's it. Right? Rather than going to say insert, cell and all, which is easy now. Escape A, escape B is better, right? So this command, the shortcuts are only for improving, nothing to do with your capability. Okay? That's good. Okay. Now let's see this. Now importing a package. What is happening here now? I'm creating labels. What is labels here? A list. I can create list also other way. List is equal to something. Instead of list, I can say ABCD is equal to something. All the same, correct? I can create whatever, some AB is equal to something. An array, here what is this array? Can I give array, this name also, array name? Don't get confused with this name. So dictionary. So what is the difference between dictionary, array and list now? Now if you look at, create all these things, right? Now if you try to print labels, what is the difference here? What is the difference? Both are same only, no? Only array has came forward. What is the advantage now of this? Now because of this, array dot, I can say mean. I get a mean. Can I get a mean like this? Why? Because this array was created using NumPy array. This is not a simple array. It's an NumPy array. What is the advantage of, if array also list only, list of lists only, what is the advantage we have? Because NumPy has built-in functions for us, where we can use to manipulate, slice, dice, and all those things we can do. Append, all those things we can do easily, correct? Okay. Now I am creating a series. What's the error I got? Tell me how to fix this error. It is telling boss data type is equal to list. What I said, data is equal to list. It's telling boss nothing. So here, what is the name I have given? AB, correct? I should give AB. Now I got a. Why I am doing all these things is to make sure that you also do. You will also do this kind of thing. You create with some name and you try to do something with something else. Computer can't understand all these things, right? You assumed it is there, but if it is not there, you'll get an error. So what did I create now? I created a simple series. So for creating series, what did I say? PD dot series. What is series? One dimensional data frame. Simple in one way, correct? So for this series, what is the index actually? 0, 1, 2 like this. But if I want to create a series, the same AB only, but with labels. What are my labels I created? WX something I created, no? What will happen now? Now instead of 0, 1, 2, 3, what I am getting now? Something you understood now? From a data set, randomly you want to generate some training data set and testing data set. So in a data science project, what we do is, this testing is not a regular testing of software application testing. Correct? For example, you are building a model to predict the score of India or how much runs India is going to score. Or you are going to predict a model whether we should sell it to the customer. He is going to be a good customer or a bad customer. Let's assume. Make you clearly understand. He is a good customer or a bad customer. How do you know who is going to be a good customer or a bad customer? That's what the goal is. So that you give only loans to good customers. You will not give loans to bad customer. Okay? So what you do now? You see the patterns of historical data. Who was your good customer and who was your bad customer? So based on certain parameters. So what are the features or parameters on which I am going to build the model now? Past historical customer data. How much loan he has taken. When somebody is taking loan of this much, he might be turning to be a bad customer. That means the loan amount. Type of loan he is taking. Home loan, vehicle loan, right? Personal loan, whatever. Type of loan. Some details about that customer. What type of customer he is? Does he having savings account with us? Yes. What is the average balance that he maintains in that savings account? Right? What is his age? How many dependents are there for him? What sort of company he works for? Right? What is his education qualification? Blah, blah, blah. Can I create some features now? So based on these features, what I am going to do now? I am going to build a model. I am trying to find some pattern. Again, whenever you say model, you must simply understand what I am trying to find a pattern. The pattern is like this. Let's assume whoever is educated and taking loan more than 100,000, right? And no dependencies. And the savings account balance average is only less than 5,000 rupees. They are all bad customers. That's for model telling. This is not my intuition or this is not my gut feeling. This is what data telling. Right? So what will happen now? What I will do now? If tomorrow a new customer comes in, I will see whether he satisfies this rule or not. If he is satisfying this rule, I will not give loan to him. If he is not satisfying the rule, I am going to give it to him. So what is my advantage? My number of defaulters will come down. My bank profit will increase. Who will write this requirement to you? See, this is what a big picture of the analytics industry. Bank job is to increase the profit. Any business job is to increase the profit or reduce the losses. They will keep the bank strategy team. The board will decide, boss, last year I had my profit is 18%. This time goal to the executive team is increase this 18% to 24%. Profit increase to 18 to 24%. Or last year my revenue or my profit is $4 billion. Now make it $4.5 billion. That's how the goals will be set. How do they set the goal also? Year-on-year growth. Based on year-on-year growth. It's a simple arithmetic progression that they do. Correct? Or a quadratic progression also they'll say. That's how usually they see all these people who have set the goals, right? They're not statisticians. That's why statistics will help everywhere. Okay? And there is no random number in the world. Please remember. If you are, that is one skill that you have to come out of that. There is no random number in the world. What is random number? If I ask you, how many red color Maruti cars are there in Pune? Tell me. Now you should systematically get to that answer. There should be a process for you to reach that particular answer. Whether 1,000, might be 1 lakh. Both are correct, might be. Or one of you correct. Right? How do you systematically come? Just think of now. How do you go? How do you find? What is the population of Pune? Around 40 lakhs people? 40, 50 lakhs? Now I am assuming there are 50 lakhs people. If I want, I can get the Google something, right? Some 40 lakhs or 50 lakhs people. That's the density of the population of Pune. Okay, out of 50 lakhs people. Now I'll have one more assumption. I'm not guessing. This is an assumption. Assumption is different. Random number is different. I'm assuming there are 50 lakhs people. I'll make one more assumption. Out of these 50 lakh people, what is the average family size? 4 people. Right? So that means 50 lakhs divided by 4. How much now? 12.5 lakhs. That means 12.5 lakh families are there in Pune. In this 12.5 lakh families, right? So if you want to own a car, your average income should be more than something, right? At least you should have a 10 lakh income. Again an assumption. Okay? I am assuming at least 10 lakh should be there, minimal, to own a car. Okay? So that means what is 10% of, how many people will have a 10 lakh salary in this thing? Let's assume the average income of Pune. So based on that, I am assuming 10% will have more than 10 lakh salary. Right? So what is 10% of 12.5 lakhs now? 1.2 lakhs. 25 lakhs, whatever. 1.25 lakhs. That means 1.25 lakhs have a salary of average. So I am assuming all these people will be owning a car. More than 10 lakhs, living in Pune city, big city, want to go, but they want to own a car, let's say. Again an assumption, all these people are owning a car. Not necessarily everyone will be owning a car. I can make another assumption, only 80% of the people will be owning a car. Then my 12.5 becomes, let's assume 10 lakhs. Sorry, 1 lakh. So 1 lakh, now this 1 lakh, among the cars, what is the Maruti share? Around 40% of the share is Maruti only. Let's say 50%. That means if these 1 lakh people are owning a car, how many of them will be owning a Maruti car? 50,000 people might be owning a Maruti car. Okay? And what is the prominence of red color Marutis usually? What color normally you find outside? White color or a grey. So I am assuming a percentage of 5%. Or 10%, whatever. I can assume again another percent. Right? So everywhere I am making some assumption and I am documenting that assumption. What is the red color percentage? If there are 100 cars, 100 Maruti cars, I am assuming 10% will be or 20% will be red color. Let's assume 20%. Then out of the 50,000 cars which are owned by Maruti, what is the percentage now? 10,000. Now I came to conclusion how many red color Maruti cars are there in Pune city? There might be 10,000. What can go wrong? My assumption can go wrong. Was Maruti share might be in overall India is 50%, but in Pune people like Hyundai. And Maruti share is only 20% here. Then what the number I will change in my calculation? That 20%. Hey, Pune population is not 40% here, 40 lakhs here, it is 70 lakhs. I will change that. Right? Average income of Pune more than 10% lakhs is not 10% here, it is 20%. Pune is always a rich city. I will go and change it. My number automatically will. Now have you seen how systematically I am able to solve a problem? This is called analytical thinking. This is not random thinking. This is clearly an analytical thinking. This is one skill which people will interview, will look for when you are being interviewed in an analyst role, as a data scientist role. Because not data is readily available to you all the time. You have to make some assumptions and then fill that data. If you are filling the data randomly, what will happen? Your model also will be random only. So if you want your model to be more relevant or accurate or close to reality, because you have to fill your data also. Why I told you all this entire story is how to analytically start thinking when you are creating your data also. You may have to create your own data set. And there's a good thing on this particular thing. You can start thinking like this. Anything that people ask randomly, even you don't know the answer, direct straight answer, but you can systematically come to an answer. What is the weight of an Boeing 333 aircraft? You said randomly some 7,000 kgs or 100,000 kgs. Just systematically, can you think now? What is a Boeing airplane is? What it is made of? How many people usually it will carry? What sort of weight of the luggage? How much of fuel it will carry? What will the volume of a 1 liter? Convert it into kgs. And how many seats will be there? What is how much of food that will carry? Blah blah blah. Right? All these things. If you do a systematic assumption, what again you can easily calculate the weight of the Boeing. Any random number for that, any random question for that matter. This is one skill people will continuously will check. That what is your analytical thinking capability. Now this is one skill that you can easily pick up. Right? Particularly when you are working in research, these things are very, very important. Because research you will not have enough data. You have to generate some data. Now you understand this we're discussing about that training testing thing, right? So, you have built your model on historical data only. How do you know that your model will work? From historical data, you have tested it. You have found some pattern. Is a real pattern is working or not? How do you check that? Because you go and start applying that model now. After 3 months, once you know who are the defaulter, who are good customers, then I will tell you. Then already you lost the data now. So, what you will do now is, from that last historical data, you will hide some data. You will hide some data. You will not use that model data to build a model. Right? You keep that data aside and you build a model on some data set. And after you found the pattern, you apply the pattern and start predicting on this hidden data set now. This hidden data set actual value also. Now you will compare your actual value versus your predicted value. So now you know how much accuracy, how many correctly you are able to predict. Correct? So this particular thing is called training and testing data sets. This data set is called testing data set. So what happens is, every data scientist, whenever working on any model, whatever data that was given, will break that into 70-30 or 80-20 ratio. And we'll randomly generate the data. If you're randomly generating the data, you run today one time, you get randomly some other record. Tomorrow you run, you get another randomness. You want only one, but this particular testing data should be fixed. Randomly only generated, but then that randomness should be fixed now. That's where you use seed. Understand where exactly you use seed and all. So whenever you want to do something random only, but that particular randomness you want to generate only once, and that randomness has to be locked. Then you can use a seed. Seed need not be 1 or 100 or something. Whatever number you want, you can give. 10,000 also, 5,797 also. What is seed? That's because randomness is also not a random number actually. Computer generated random number is not a random number. It's an algorithm. Random generation itself is an algorithm. For that algorithm, it needs a seed. For example, you are listening to the songs, correct? Shuffle mode, if you are listening. Have you noticed the same songs will come in the same shuffle way? If you shuffle and listen, and if you're repeating it, and shuffle is in repeat mode, it will shuffle in the same order. There's a random number for that also. There's a seed for that also, as well. For now, seed doesn't help you now, but in future it will help you. So if I have a dictionary here, see already what is the advantage of a dictionary? You already have a key and name. Can I convert this dictionary into a series? And automatically it is intelligent enough to understand keys are nothing but my indexes. So simply if I create a series based on a dictionary, right? It automatically created. So if you already have a dictionary, it is easy to convert that into a. And have you seen this again? In the dictionary, all the values need to be of the same size. Correct? Here I can have like this? What does this dictionary have now? First value is 10, second is a list, third one is a single value, fourth one can be a list of some characters or strings here. Can I have like this? Now if I create a series from this, what will happen? Same thing. Because series will have only one single column. But this is not my single column. This is a different value. Right? So how should I do now? I should create a data frame now. Okay. Now let's assume I have a series of sports 1. So another interesting thing, just what I am doing is, my previous output is here, right? Whatever I have executed previously, it is here. So what I did is, I have cleaned that entire thing and I have cleared all my output. So that the previous output will not appear now. So what did I do now? I created a series of values 1, 2, 3, 4. What is the index I have given to it? Cricket, football, something I have given to it. So what is this sports 1 will have now? This is nothing but a row name, correct? And I create one more series, sports 2. This is another data. This is I have 2 datas. Right? So the advantage of indexing is, instead of you remembering the number, you directly remember the name itself. For example, in that I want to know cricket ka data. So I can say simply sports 1 of cricket. I can even do addition operations now. Sports 1 plus sports 2. What is the expectation now? This have a different index, this has a different index, right? If index are zeros and 1, it will do 0 plus 0. 1 plus 1. Now I have index. What it will does is, right, if you look at this one, not necessarily everything should be in the same order, no? But it can even do the index based addition. So cricket in this index will be added to the cricket in another index. Shall I do this? Sports 1 plus sports 2. Why did for baseball I get an NaN? Because baseball is there only in second one. First one it didn't have it. So what it did do? It's not able to. It only matches the value. If it didn't find that value, it will not able to. Even it's not 5 plus 0. 5 plus nothing. 5 plus nothing is not 5. 5 plus 0 is 5. But 5 plus nothing is, I cannot do. You understand the difference? So what exactly it is doing now? It is trying to match index to index, right? So minus, plus, all operations, all the operations what we can do. Okay. So this is another way of importing packages. Now, if we have a particular class in a package and you want to import only that particular thing, you don't want to import the entire package. What will happen if you import the entire package? Your size of your program will increase, isn't it? Because you are getting all the things. So if you want to only restrictively bring only certain things, then you can use from operation, from command. From this numpy.random, you import only rand n. That means don't import the entire numpy package. This is another way of importing only whatever you want to import. You understand, everyone? Okay. Now I am creating a data frame. How am I creating data frame? pd.dataframe rand n 10, 5. See, I am not calling np.randn.rand now. Have you seen this now? Directly I am able to use rand n directly. I can give a rand n as rd also here, so that I can see rd also. Okay. Okay. What rand n will do? It's creating a 10 by 5 matrix. It's a normalized matrix, correct? I want to create a data frame like this, right? I want to give a row name to it, and I want to give a column name to it. What I am going to do now? Boss, create my data frame. These are the values. Okay? And in this values, what is my index? That means what are my row names? How many rows I am going to have? 10 rows. So I am giving 10 index names. Okay. Directly I am using split function here. The other way I can create is simply abcd of list also. List.abcd of. Right? Then I am creating, and these are all my scores. Score 1, score 2, score 3, like this. I am creating this particular thing. What will happen now? The same thing will appear as, if we print this data frame, the same values here, right? Whatever the values here seeing, the values here. But you are seeing a different value here and here. Why? I created here. Hey, here itself values are changing. It's a random number, no? But sometimes these random numbers are difficult for explaining to someone else. If you try to, every time is random, you execute something here and you go to your customer and you show something, it will be different else. So how do you lock this random? You want random only generate, but you want to lock that. So for that, we use a concept called CD. If you use the same seed, you'll get the same randomness. Example, I'll show you here. Okay. So I want to generate a random integer between 1 to 100. Okay. If I don't have this seed, I'm getting 62, 17. Every time I execute, I get a different number. But I want to this random number only generate between 1 to 100, but I want to lock it. Then I put a seed. This seed can be any value, not necessarily 5. If I give 100 as my seed, 9. Every time I execute, I'll get only 9. I created data frame now. Now if I want this data frame to be fixed, what should I do now? This randomly, if it is generating, right? Creating a data frame based on random number only here. So now I create a data frame. Now if I ask it, it will give me a different data frame. I want this data frame to be fixed. What should I do now? Just put a now this is something. Now I got a new data frame. Now I execute again. Remember 1.74 something. It is 1.74 only. It's not changed. You understood the logic now? Yeah. Now, basic things that we will do with Pandas. What all things that we do? I want the score 3 column only. I can say data frame of score 3. Okay. I want score 2 and score 1. See, I have changed the order also in which I want to get it. Can I get it now? So how am I using it? Again, a list I am passing, correct? List of names. What is the return type of a thing? It's a series. Remember, see this? It's a single value, it is a series. If it say type of this one, what it will be type of this one? It's a data frame only. If you are returning a single, that means from a data frame, if you try to extract something, you are getting a data frame or series. If it is a single value, it will be series. If it's more than one value, it will be data frame. Okay. And now, if you want to add a new column now, I already created data frame, I want to add a new column, right? So, which is a combination of score 1 plus score 2. Can I do this? So, how am I doing? I am creating a data frame, score of 6, this is this one. Now, what this data frame will have? Will have a new column called score 6, which is a combination of score 1 plus score 2. And I can drop a column also. How to drop a column? Drop. Now, what has happened now? There is no 6th column now. I have added a column, I can even drop a column. But if you look at carefully, if you go and ask again a data frame, if you just list the data frame, you are getting 6 all things again. That means it dropped and created a new data set for you. It didn't modify the existing data frame. It has created a new data frame here. For example, if I say x is equal to, x will have that 5 column, that 5 column stuff. Escape below. If you say x, you will see only 5 columns. But if you go to data frame, obviously it will have all the 6 columns. You want to modify the existing data frame itself. You don't want to create one more data, because every data frame you are creating, you are increasing your memory utilization. Right? You want to directly modify within the data frame itself. Then there is a parameter called in place is equal to true. By default it is false. You can use in place is equal to true. What it will do now? It will delete the data frame within itself. It will not create a new data frame. You understand? And if you want to delete a row, now we have deleted a column or we have added a column. Similarly, if you want to drop a column, drop a row, then you can do that. But instead of dropping, you should mention axis is equal to 0. Axis is equal to 1 means columns, axis is equal to 0 means rows. Again, what will happen now? A is deleted, but not, it has created a new data frame now. You can use in place is equal to true, so that it will create. If you go to data frame, still A is there. If we want to replace really 0, what I should do? What I should do? In place is equal to true. Now it will delete actually the data frame. No, it is not there. So for selecting rows, one of the option is you can use the square bracket and say the names of the column. For example, I want the B row to be coming out. How should I say? Can I say B like this? If I want score 1, how can I get the first column. I can get like this, but I cannot get the rows like this, right? Even I can get scores in another way also using dot operator called score 1. I can get like this, score 2 or score 5. I can get. But how do you get the rows? Rows, for that you can use location. A method called location. Location LOC of F. Then you get the entire row as a series. This is as a series because the entire row became a series of values. Okay. F. I can say P, B, whatever. I can get a series of things. Okay. Or if you want index based only, you don't need the number is not there. Sorry, name is not there, index value is not there. You can get it location based on index also by second row. I want fifth row by using a method function called iLocation, ILLOC. Okay. If I want more than one column and one row, I want a row, but I want score 1. Do we have A in the data set now? I have dropped it. So we cannot use A. What will happen? Let's see if I use A. It will say, boss, I don't have A here. So let me get B here. Can I get now? What is this now? A single value here. Because exactly I am trying to know, I know this row and this column. I only get that particular thing. Okay. If I want more than one value, I want A and B rows. For that I want to get score 1 and score 2 or C and D. Now this is a data frame again. Are you getting it? So now do you know how to do slicing and dicing now? If you want particular column to be filtered, you only see a particular column. Select. Just like this is like database operation only, no? Select something, right? And you want some rows, you can say rows here. Okay. So location and iLoc can be used for location based stuff, and dot and directly column name can directly for columns. Then the conditional selection. What is conditional selection? You are directly telling this column, this row. I don't want that. I want based on a condition. Just like where condition we'll write now, where salary greater than 100, like that. If I want it, I have in my data frame, I want to know all the values in the entire data frame, which has greater than 0.5. What it will do me? It will make true false Boolean matrix. Boolean value data frame. It means wherever true is there, those true have value greater than this thing. So if I say, what does it mean? I'm getting the row 5, and in that row 5 I am checking whether something is greater than 5 also. But if I say this, if I say within the value, so what is the difference between this and this? This is on the entire data frame. I am saying go and compare every value of it and tell me whether it is true or false. But here I am telling, in this data frame, get me the values like this. Have you seen the difference now? It is trying to compare and get me that exact value. And if it is not able to compare, if it is not true, then I will get an NaN. But what I want is not that. I want to see all the records of the scores. Score 1 may, who is greater than 0.5. Then I will get it. I will get only those records where score is greater than 5. Okay. I want to compare score greater than 5, but I don't want all the columns. I want only to get second column only. Then I can say this. And what is this now? This is the same values, correct? If I say here 5, I'll get exactly these values. That means I am applying row and where condition and also select condition. Are you all comfortable with select queries? Select column name from table where condition. Do you need to have include your where column in the select column? Not necessarily, correct? If you want all, you can get all. But if you want only restricted to certain things, you can apply that filter also. Now look at this data frame. The data frame has, this is the index, correct? B, C like this. B, C are not good, let's assume. I want to rename that to a proper country name. So I can reset the index. If I reset the index, what will happen? The index will be 0, 1, 2, 3. And have you also noticed index become a column now? Earlier index was only a row number, a row name. Now index became a column. Okay. Now I am creating a new index. Now these are all my 10 countries. I am creating a simple list now. Now what is this new index will have? This is a simple list, isn't it? Now I want to give this list to my data frame and ask it to use as the index. Okay. So, but does it already have a countries field? Does it have a countries field? No. So what should I do now? First I should create a new countries field and I am adding this index to it. But does it have countries already? No. So what should I do now? Tell me. Do you remember earlier we have added a column, score 6, adding a new column. How did we create a new column? List. That means I am not supposed to give a list. Example, if I give here score 6 of some values here. How many? 3, 5, 7, 6, 4, 9, 23, 27, 36. How many values are there? 10 should be given, right? 10 should be given to it. How many are given? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should be a series. I can give a series to it. I cannot give a list to it. So how do I convert now this into a list, into a series now? PD dot can I add now? You understood now? Because data frame always works with indexes and column. That means you did not work on regular indexes. The index of list is not sufficient for it. Why it has given NaN now, not a number now? Because there are only 9 here, if you remember here, but I have given now 10. We have removed one thing, no? Still it is the same? No, not. Data type can be, it's other frame can have other data type. That's not the case. Because the index of this particular thing is different from index of this. It's not able to match. I told you in the earlier sports 1 and sports 2 we are trying to see, and for some sports we got a NaN value. Why? Because when you are adding something it will only go by. What is the series? What is this index of this one? 0, 1, 2, 3 like this. Is it any 0 matching here? No. Then no. Will it be able to add? No. So what should I do now? One is reset that so that I can pass it to it. The other one is I can give an index to this one also, no? To this series also, right? How do I give a series to it now? Dot index is equal to, right? What is the index I want? B, C, right? B, C, D, E, F, G, H, I and J. Dot split. Sorry, no need of this bracket closed. Now I should close the bracket here. Now what will happen now? I got it. So when you do a mistake also, you should know what is happening there. Otherwise, you will not be able to correct your own. This is what understanding the concept is. Now understood now? I did it just like you. For a new programmer, what I will do? I am trying to add something. List I am not able to add. Then I realized I can add only a series. But when I am adding series also, when you are adding a new series to an existing data frame, the indexes should match. Otherwise, it will not know how to add those values. Right? The other way is reset the index and then create a new index. That's what we are trying to understand now. Clear? Now I have this data frame which has 6 records now. Okay. Now I am doing a reset index. Now all the indexes become 0, 1, 2, 3, 4. Now I want to give a name to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many I have? Only 9 I have. So I created a new index now. Okay. Now will it work now? Now what has happened? Now this is added as a new thing. Even with the list also you can add, as long as the list also will list. What is the index of list? 0, 1, 2, 3, 4 only. Now you can add it. Okay. Now I have it. Now I want to reset one of the country as my index instead of B. Didn't I reset it? Yeah, this is the old value. Okay. I understand. This is the old value. Now that country became the index. Instead of B, C, D, now country became index. Clear? Yes. Again, simple. This is again not changing the actual data. It is creating a new data frame. So what should I do? In place is equal to true. Then actual data frame will change. So what are all things that we learned till now? In Pandas, this is very similar to what we have learned with NumPy. Selection, additions, and then basic operations. So other thing that you normally do with Pandas is missing value treatment. So in this data, how many missing values are there? These are all missing values only, no? You look at this data frame. These are all missing values. Since you know this data frame, you know by this. But if somebody has read the data from a text, from a file, you will not know what are the missing values are there. So simply you can say drop NA. That means what will happen now? It will drop all the records that has even one single value is there in the entire row. It will drop that entire row. Okay. So if you want drop columns which has missing values, you don't want to drop the entire row, then what you can do? Access is equal to 1. Okay. Now because only this particular thing doesn't have anything, these 2 columns have. So these 2 columns have been dropped. Again, in place is equal to true. It's not true. That's why its original data set remains as is. So original data set remained as is. I'm only creating a new data frames here. Okay. So drop NA, by default access is equal to 0. That means it will drop all the rows. Now access is equal to 1 means it will drop the columns. There is a thing called threshold. That means don't drop even if there is only one single value, don't drop it. Minimum should be 2. The threshold value is 2. If there is more than 2, then only you drop. That also I can say. Okay. then it is dropping only, which one it is dropping now here? It didn't drop it because this record didn't have, for example, if you look at this data, this record has 2 NANs. That means it dropped only this record, other records remain, this one and this one remain in the data set. Understood threshold now? Usually you will not drop. What you will do, you will fill the value. Correct? If you drop, you are losing data, correct? What you do, you will fill the values. You will ask business, hey, this value is missing. What should I do now? Business say, okay, sorry, I have given incorrect to you. Just you fill this with some X value. So if you want to fill with some value, I can say fill.na is equal to 0. Then what it did, wherever missing values are there, it has updated with 0. So the other way is, normally you don't put a constant. There should be some logic. For example, age is missing in the group. We are all one data set. For example, one person's age is missing. Okay? But I have experience in another column. What I will do? Rather than keeping 0 or an average age of all the people in this room, what I will do is, but what is the average experience of, this guy is having 10 years experience. What is the average age of 10 years experienced people in the room? Then I will use that as that is much more intelligent than randomly putting a constant or a average of the entire data set, correct? So here also that's what I am doing. What I am doing is, some value is missing for baseball, some score is missing for baseball. Should I put 0 for everything? No, what I am doing is, what is the average score of baseball, and I am putting that value in that particular thing. That is a much more intelligent way of, this is called missing value treatment. How do you treat a missing value? There are different techniques in it. This is one of the technique. One of the technique is, find a relevant group close to that particular missing value and put a mean or median or a mode of it. And who will take this call? With the help of some business knowledge. How do I know experience the right field here? I would taken some other field, no? The experience will give you close to the average age. This is again domain knowledge. In this case, general knowledge. But in business, you will not be able to do this. Correct? You need some domain knowledge. So this is all part of in the data life cycle project, which stage we are in? We are in preparing, organizing the data. We are understanding the data. Still we got into understanding data. But we realized there are some missing values. So immediately the moment you realize missing values, what did you do? Either you delete those missing value records or you treat them. Now let's get into small activities. Or the other activity is, what activities you do on a data set? Groups. Now we'll try to understand the data by using group by. Let's assume I have a data like this, data frame like this. So this is what is this? This is a dictionary, right? Now can I convert dictionary into a data frame? If I convert dictionary into a data frame, what happens? All my keys becomes my indexes, right? That's the case here. Here, what has happened here? Tell me. These keys became my columns here, correct? If it is a series, keys becomes your row indexes. But if it is a data frame, your keys will become your columns. Earlier we remember when the first example we did, converted a dictionary into a series. Then all values become values. All the keys become row indexes. But when you have multiple records, then all your keys will become your column names. Logically correct, right? This is how it should work. Okay. Now there is a function called group by. So how many customers are there for you here? Same customers are repeating. Now you want to group by a new object got created for you. So you have to store that group result into an object. Now on that group, what you do? There is an object which has only group by each customer. Now on that group, what do you do now? That's why always you do an average operation or some numerical operations on it, correct? Now what you do is on this particular thing I'm trying to, if you try to display it, it's an object. See, it's a group and it's an internally created as an object for us. So on this group, what you do? You do some operation. Have you seen select start from grouping also? If you will not get anything. After that you say group customer ID comma sum of or average of or whatever something. Correct? That's exactly this happens in even SQL also. Okay. So what do you do on a group operation? You say mean. Instead of writing multiple lines of code, what I can do is group by dot median I can say. I'll get here itself. Okay. So on this group I can do standard deviation, I can do minimum, maximum, count. I can describe this group. If I want, I can describe the group. There's a beautiful function called describe. Now if you look at this describe, what it is doing now? So 1001 is one customer you have, one group you have, 02 is another group, 03 is another group, and it is giving me some important statistics for me. What is that? What is the count? How many customers are there in this group? What is the mean of this group? What is the standard deviation of this group? What is the minimum value of this group? What is the 25th percentile of this group? What is the 50th percentile of this group? 75th percentile of this? What is the maximum of this group? Like this I can get all these values. So what will happen if I transpose this is, I'll get like this. What is the difference between this and this? Just only transpose of it. But my readability has increased now. So if you are good in reading like this, you can use this transpose. If you are good in reading like this, you can remain as is. Instead of entire transpose, I can also say simply T also. Same thing. Okay. If I want to apply a filter on it, this is also a simple data frame kind of a thing. I can only get for one particular record now. I want only one particular column. Then I can get only that particular column as a list. Okay. Are we clear on grouping now? So simple only, no? Group by dot whatever operation that you want to do. So another function that we learned in this particular thing is describe function. So describe function only works on numeric. But if you want to work on even with this thing, I'll show you now. For example, actually if you look at this group has customer name and also profit links. It can be something else also. Correct? So, okay, I'm creating a data frame here. I have one more data frame. I have 3 data frames now. Data frame 1 is some customer data. Data frame 2 has some other customer data. Data frame 3 has some other customer data. Okay. Now let's see one more. Escape B. Now let's analyze this data. DAFA1.info is one function I can run. It will tell me what is the data type of each of these information about this data frame. Hey, in this data frame, I have 4 entries. That means there are 4 records. And index is starting from 0 to 3. And these are my data columns. Total 4 columns. First column, this has 4 values. This has 4 values like this, and it is a non-null object. That means everything is filled. There is no null objects. And what is the data type of it? It's an object, like this. It is telling me. Okay. Now, I say DAF A1 dot describe. See what it has. It is describing the entire data set, but it is taking only the sales data only, because it knows they are all objects. I will not be able to describe them, so I am not describing it. I am only describing numeric data type. There is a function called include. There is a parameter called include. Include is equal to all. Now you get all the things. Now it has including the categorical and numeric. It has both categorical and numeric. Now customer ID is also getting. In the categorical, obviously there will not be mean, median, mode and all, top and all. So whatever that is applicable, it will bring. Now have you noticed this has brought some other new things like count, unique, how many unique are there, right? Frequency. Because if for a categorical variable, what all things you do? How many unique products are there? How many unique customers are there? What is the frequency of the repetition? What is the total count? Whatever that is applicable, that value will come here. Got it now? This is how you can do this. Okay. Now let's assume I have 3 data frames. One data frame like this. Okay. Data frame 2 and data frame 3. I have 3 data frames. 3 different sources I got data from, 3 different sources. Now what operations I do? I'll join, merge, kind of operations only I'll do now. Okay. First concatenation. Concatenation, what happens? Concatenation is nothing but just add. Right? By default, what it does is, it will add horizontally. It will add horizontally. Right? And complete a new data frame got created. Wherever that particular thing is, it has not done on based on. Example, see the data frame like this. It is like this, right? So what it does, it created, and the different columns are there in every data frame. So all combined together, wherever it is able to match the specific columns based on columns, it is able to match them. But if it is not finding that column, for example, payback is not there in the first data frame, it has filled nulls there. Are you getting the point? So this is so simple concatenation. But if you want concatenation to happen on columns, that means the things should come next to next, not horizontally, but you want vertically concatenation, then you can say access is equal to 1. Now instead of bringing them row by row, now it has done column by column. So in this of column by column, now this is a separate record, and this is a separate record, and this is a separate record. Normally you don't do concatenation. What you do? You do a merging based on a column name, correct? This column, wherever they matches, you try to go and get the things. This exactly is the concept called merging is. Now I have 2 data tables. Okay, this is quarter 1 and quarter 2 data, and this is quarter 3 and quarter 4 data. What should I do now? If I concatenate, what will happen? It will come very horizontally, correct? That means Q3, here there is no null value for Q3 and Q4. It will not come, and it will come here. So I want to merge them now. I don't want to concatenate them. I want to merge them. So you can do outer merging and inner merging also. Okay. So you do merging based on which column? Customer ID. So what has happened in the second record, there is no row for customer ID 2, but still it is able to manage and get it, and whenever it is not able to get it, it has placed NINs. But if you said inner join, what would have happened? Only those customers who has a matching only will be matched. You all understand what is inner join and outer join? What are we trying here? Based on a common column name, the value in that column, I'm trying to find the corresponding this thing. This is called merging. Now this is where the concept of joining comes into picture now for us. So how does joining works is, joining is also similar to merge only, very, very similar. What is the only difference is, merge uses the common columns to combine two records, whereas join uses the two row indexes to join the data frames. Based on column name it will join, the join will do on the row index. Remember, rows also can have names now. We can do based on rows also. For example, if you look at the data like this, you have table 1 like this, right? I0, I1, I2. And table 2 is like this. Now you want to join them. So table 1 dot join. This is a pure inner join, right? Now if you want outer join, you can do this also, so that you will get all the other records which are not. So by default it is doing the left outer join here, left join here. Whenever that is matching, it is getting it. This is a simple left join here. This is a left join. But if you want right join, instead of table 2, table 1 you place table 2 and join, you will get a right outer join.
Matplotlib provides an easy visual approach to present our findings. There are a number of visualizations which we can choose from to present our results. From histograms to scat plots, Matplotlib lays down an array of colors, themes, palettes, and other options to customize and personalize our plots. Matplotlib is useful whether you're performing data exploration for a machine learning project or simply want to create dazzling and eye-catching charts. Understanding this, we have come for this tutorial on Matplotlib. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be NumPy, because we would want to create our data with this NumPy library. Then we would import this pyplot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import pyplot as PLT, and the alias which I'm giving for pyplot is PLT. Then I'll create two NumPy arrays over here. The first NumPy array will be X, and I'm creating this NumPy array with the help of this np.arange method, and the range will be from 1 to 10. And then I'll create the next NumPy array, which is basically 2 times of X. So all I have to do is multiply X with 2, and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6, and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this pyplot module. So this takes in two parameters, which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as plt. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have x, and this I'll be creating with np.arange, and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out x for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create y will just be 2 times of x. So here I'll have 2 into x, and then let me print out y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in x. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in 2 parameters which are x and y. So this data would be plotted onto the x-axis, this data would be plotted onto the y-axis, and I'll just show this as a result. So as you guys see, we have this object x mapped on the x-axis, this object y mapped on the y-axis, and this is the corresponding line plot. Now that we have created this, we can also add the title x label and y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add x label and y label by using these two methods, and as you guys see, we have added these two labels over here. So let me add the title x label and y label, plt. So I'll copy this entire code over here and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have x label. So here I'll have plt.x label, and here I'll give the x label as x-axis. Then I would have the y label, so plt.y label, and inside this I'll give the y label as y-axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the x and y-axis labels. Now with the help of these three methods, we have added the title, the x-axis label, and the y-axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color, and as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot, and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here. And I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line, and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10. But I'll have two y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make two plots because I want two line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which you are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2. And the color of this line will be red. And this will be a dashed line. And we are setting the line width to be equal to 3. Then again, we have the title, x label and y label. And we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here. But when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dashed line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all of the numbers which are present in x. Now y1, I'll set it as 2 times of x, and then I'll have y2, which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this, I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis, I'll obviously have x. Then onto the y-axis, I'll have y1. And the color for the first line, I'll have green. And let's say the line width, I'll set this to be equal to 2. Then I'll have the next line, which will be between x and y2. So here I'll just write down x, y2. And for this line, I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it will be plt.show, and I would also want a grid over here. So before this, I'll set plt.grid, and I will set this to be equal to true. Let's hit run. And as you guys see, I have two lines in the same plot. Now in the earlier example, we had two lines in the same plot. But if we actually want two subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have two plots over here, and those two plots would be present in this way. So I'll have one row, two columns. As you guys see, I have one row and two columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between x and y1. Color will be green. Line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between x and y1. Then we'll have plt.subplot, which is our next subplot, and the first two parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between x and y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have x, y1 and y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and here I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between x and y1, and I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot, and the first two parameters will be 1 and 2 because I'd want these two plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2, and over here I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between x and y1, and the color of this line is yellow. The next subplot is between x and y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56 and Sam 27. Now we'll go ahead and extract the names and values individually. The names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys, and I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values. I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values. The second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it will be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. Now, the plot which we had created earlier was very bland, and we can go ahead and add the title, x label and y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the x label and the y label, we'll be using plt.xlabel and plt.y label, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names and the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it will be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar, and we are adding a color as well. So by default we had the blue color, and if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis we'll have names. Let me change this to names. And as you guys see, we have successfully created this horizontal bar plot. Next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities. And these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show up the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in x, I'll just have 1, 2, 3, 4, 5, 6, 7, 8 and 9, and then I'll have y, and in y I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x comma y, and I would have to show out the result. plt.show, And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same x and a. These are the same list which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star. And I'll change the color. Color will be, let's say, I'll have orange again. And I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot where we had two lines in the same graph, we can perform a similar sort of thing over here where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have x and a. Then we'll create a new list called as b. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B. And these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between x and y1. Then I'll go ahead and create the second scatter plot, which will be between x and y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these three lists, then I'll have plt.subplot, then we'll have the same three parameters, and since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between x and a. So this is the scatter plot between x and a. Then I'll go ahead and create the next subplot, and the next subplot will be between x and b. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1, and the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. When it comes to histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show. And this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv since this is a CSV file. So inside read_csv, I am passing in the name of the file and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column and I'll set the number of bins, and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv method. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal length, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small. It'll be petal length. And I'll set the number of bins to be equal to, let's say, 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Right, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3. As a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list. The minimum value will be 4. The maximum value will be 9. So it's time to create a box plot. I'll add this comment over here. box plot. And after this, I'd have to create 3 lists. So I'll have L1, and inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly give in 9 numbers. And again, I'll have L3, and also in L3, I'll just randomly give in some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these 3 box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. One another geometry which is analogous to the box plot is the while-in plot. So the only difference is to create a while-in plot, we'll be using while-in plot method instead of box plot method. And this is the difference between how these boxes and while-ins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.while-in-plot, and I'm printing out the same data. And as you guys see, I have created this while-in plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the while-in plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have 2 lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie. And here, first, I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create 2 lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. The third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples. I've got 43 mangoes, I've got only 12 oranges, and I've got 97 lychees. So I've got these 2 ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to given the categorical object, so I'm mapping fruit onto the labels. Then I would just have to show out this pie chart, so plt.show, As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here, for this auto PCT attribute, I am using 0.1f. Now, what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here, I'll have to use %0.1f. Let me add %%. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entities. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5. It is all the same. It's just that keep the color as W, because since a donut, this basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4. The radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually. And let me keep this as 1. And this is the resultant donut chart. This brings us to the end of this tutorial on Matplotlib in Python. So thank you very much, folks, and have a great learning ahead. Data visualization is an essential component of a data scientist skill set, and Seaborn is one of the most popular packages in Python to implement data visualization. Keeping the importance of Seaborn in mind, we have come up with this Seaborn Python tutorial. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset, and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset, that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need pyplot. So I'll have from Matplotlib import pyplot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have sns.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI, and let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. sns.line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20 and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2, and when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of the stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as pd. Now, once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this, I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in Pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this is legendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this is legendary column and then the speed column. So I'll be using sns.barplot, and onto the x-axis, I would have to map is legendary, and then onto the y-axis I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out, and when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between is legendary column and weight in kg column. So is legendary column is again mapped onto the x-axis. It's just that here for the y-axis we are mapping weight kg column. And this time it is very obvious that legendary Pokemons, their weight is much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column. And we already know to do that, we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary. This denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plotter is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette, and we can directly use different predefined palettes. So first we have the Blues D palette with a capital B. This is how it looks like. Then we have the Rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is Blues D. And as you guys see, this is the Blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the Rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG. And this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between two numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up. Then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add 2 more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. and this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column. And you would see that we have three different styles. For setosa, this is setosa, you have solid circles. For versicolor, you have crosses, and for virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head. And these are the different columns which are present. So I've got caret, which obviously tells us about the caret of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot, and since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.dist plot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt.show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created. And to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now, if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10. And I'm just setting the color to be equal to green. I'll select this over here. I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now, if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here, and here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center, and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we have just used scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now I'll have to use sns.jointplot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'll have to map something. So onto the y-axis I'll be mapping petal.length, and that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, So seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company, and on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, and then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column which would go on the y-axis and this churn column which would go on the x-axis. SNS.boxplot, and onto the x-axis I'd have to map obviously the tenure column. Onto the y-axis I am mapping the churn column. Then I'd have to use the data which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go onto the y-axis and churn will go onto the x-axis. Now if we get this box plot, and we've already seen the inference, it seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these 3 different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these two boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here, but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service, and this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have three different types of contracts: month-to-month contract, 1 year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here, I'll remove the line width, and instead of line width, I'll use this attribute called as order. And first, I'll have 2 year. After that, I'll have month to month. Then finally, I'll have the last box, which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here, I'll add this attribute called as hue. And I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories. This brings us to the end of this Seaborn Python tutorial. These columns over here. So this name which you see is the name of the battle. So we have around maybe 40 odd different battles which have occurred through the 7 books. So you have Battle of the Golden Tooth, you have Battle at the Mama's Ford, you have Battle of River Run, you have Battle of the Green Fork, and so on. This column tells us in which year the battle occurred in. So Game of Thrones was mostly based throughout the 298, 299 and 300 AC years. Then you have the this column which would tell you who is the attacker king. So here for this battle, which is Battle of Golden Tooth, the attacker king was Joffrey and Tommen Baratheon, and the defender king was Robb Stark. So here attacker 1 basically tells you who is the primary attacker. So primary attackers are Lannisters over here. I mean, we already know that the Lannisters have started most of these wars, so this is not really, not really new information. Then we have this major death column. This major death column tells us if any major death has occurred in this war. So let's say if someone such as maybe Jaime Lannister has died or Robb Stark has died. So if there's any major death involved in this battle, then we'll have the value 1. On the other hand, if there's no major death, then we'll have 0. Similarly, we have this major capture column. So if the value is 0, it would mean no major captures have occurred in this battle. Similarly, if we have the value 1, that would mean some major captures, someone really powerful has been captured. Then we have attacker size over here. Attacker size would tell you the number of people who have fought on the attacker side. Then you have who's the commander who is leading the army of the attacking side. Similarly, you have this column which would tell you who is the commander who is leading the defender side. Then you have the different regions in which all of these battles occurred. So let's say if we take this particular battle, which is Battle of the Golden Tooth. So this battle has occurred in Westerlands. So this is some basic information about our data frame. So before we do EDA, it's actually important to understand what is the data about. Now, if I want to know the number of rows and number of columns which are present in this data frame, I'll just have battle.shape. And you would see that we have this value 3825, which would basically mean there are 38 records present in this data frame and 25 columns present in this data frame. Now, some of these columns are not very intuitive. So let's say I have attacker 1 over here. Now, instead of attacker 1, I'd want this to be more intuitive. So I'd want to rename this column from attacker 1 to primary attacker. So for that purpose, I have this method called as rename. I'll use this rename method. I'm using this rename method on top of this battle object. And inside this, I have this parameter called as columns, which would help me to rename this column. So for this columns, I'll pass in a dictionary. Key would be the column which I'd want to rename. Value is to which particular value would I want to rename this column. So I am renaming this column attacker 1 to primary attacker. And when I set in place is equal to true, this would mean that the change directly happens in the data frame itself. Now, once I make that change, I'll just go ahead and have a glance at the change data frame. So you would see that initially the name of the column over here was attacker 1. But after using this particular method, we have changed the name of the column from attacker 1 to primary attacker. Similarly, we have the defender 1 column over here. Defender 1 means who is the primary defender. So here I'll use the same method, which is battle.rename. So rename is the method, and I'm using this method on top of the battle object, and I'll have this parameter columns, and you would see that I'm passing in this key value pair. Key is this particular column, value is to which value I'd want to change this name to. So I am renaming defender1 to primary defender, and when I set in place is equal to true, the changes automatically are saved in this data frame. Then I'll have a glance at this modified data frame. So you would see that I have changed the name over here. So this was some basic pre-processing for this data frame. Now, if I'd want to know how many times a king has attacked. So I have this attacker king column. So let's say if I'd want to know the number of times Robb Stark has attacked someone, the number of times Joffrey and Tommen Baratheon have attacked someone, then I can use the value counts method, which would give me the frequency of a categorical column. So this is a categorical column, as you see. So all I'll do is I'll have battle, and inside this I'll give in the name of the column, which is attacker king. And when I use the value counts method on top of this column, this will give me the frequency of values. So here it would seem that Joffrey and Tommen Baratheon have attacked 14 times. So it seems like Joffrey and Tommen are mostly the starters of all of these wars which have happened in Game of Thrones. And over here when we see Stannis Baratheon, so Stannis Baratheon has only attacked 5 times. Then similarly we have Robb Stark over here. So Robb Stark has started an attack 10 times. Then we have the Greyjoys. So the Greyjoys have started the attack 7 times. So this is a simple information which you can find out about attacker king. And if I want to know how many battles have occurred in different locations, so we have the location column. Now, let's say if I want to know how many battles have occurred at Golden Tooth, how many battles have occurred at River Run, then I'll just use value counts again for this particular column. And you would see that Winterfell and River Run have the most number of battles. So at Winterfell 3 battles have occurred. Similarly at River Run 3 battles have occurred. But from over here to here you would see that only 1 battle has occurred at these different locations. And we have, let's say, we have Storm's End over here. Storm's End again has only 2 battles which have occurred. So that was understanding about those categorical columns. Now that is done, what we'll do is we'll do some basic visualization to understand this data frame better. So to do visualization, we have already imported the Seaborn and Matplotlib earlier. So these are the 2 important libraries for visualization. I'll go ahead and load these 2 up. Now that these 2 are loaded, I'd want to understand, how many, so over here we had looked at the frequency of attacker king. So now I'd want to know so here what I'm doing is, let's say if a king has attacked, then I'd want to know what is the size of his army. So that is why I'll have attacker king mapped onto the x-axis, attacker size mapped onto the y-axis, and I am creating this bar plot on top of the battle data frame, obviously. So here this sns.set, I'm just setting the figure size over here because there are a lot of things which are present in this visualization. So here we have 4 attackers. We have Joffrey and Tommen Baratheon, then we've got Robb Stark, then we've got the Greyjoys, and then we've got Stannis Baratheon. So here, it seems that whenever Stannis Baratheon attacks, he has a huge army size. So if you look at Stannis Baratheon's army size to other Baratheons, or to even Robb Stark, or to even Greyjoy, so if we look at this, so Stannis Baratheon, he would have a size of around 30,000 in general. Similarly, if we look at Greyjoys would have the size of their army would be somewhere maybe close to around 1,000 or 2,000, not more than that. Similarly, Joffrey and Tommen Baratheon, their army size would be around close to 10,000. So this is an interesting observation. So, it seems that Stannis Baratheon had a huge army along with him when compared to other attackers. Now, similarly, if I'd want to know the army size of the defender, so this time, what I'm doing is I am mapping the defender king onto the x-axis and I'm mapping the defender size onto the y-axis. Now, when I run this, so these are all of the defenders. So this time we see that whenever, so out of all of these kings, whenever Renly Baratheon was attacked, he had the maximum army size. So maybe in some battle, Renly Baratheon would have been attacked, and in that particular battle, he had an army size of 20,000. Then followed by Joffrey and Tommen Baratheon over here. So it seems that whenever Joffrey and Tommen Baratheon are attacked, their army size is around 8,000 to 9,000. Then we've got Stannis Baratheon. Now compare this to this over here. So whenever Stannis Baratheon is attacking, it seems that he'll have a larger army. But on the contrary, whenever it's Stannis Baratheon who is being attacked, in that particular point, it seems that he'll have a very small army. So this is very interesting, isn't it? So that was about attacker size, and defender size. And now if I want to know what are the different battle types that these attackers have engaged in. So this time I'll be using this method called as count plot, and I am mapping the attacker king column onto the x-axis, and hue basically determines the color of these bars. So the color of these bars is being determined by the battle type. Now when I hit on run, so you would see that again we have the same attackers who are Joffrey, Tommen Baratheon, Robb Stark. So we've got the Greyjoys, then we've got only Stannis Baratheon. So it would seem that when it comes to Joffrey and Tommen Baratheon, they mostly engage in a pitched battle, and it's they have ambushed someone very few times, right? So Joffrey and Tommen Baratheon, they have been in a pitched battle 6 times, but they have only ambushed someone 3 times. But when you talk about Robb Stark, so it seems that Robb Stark mostly ambushes his enemies or ambushes against someone else. So Robb Stark has ambushed the opponent 5 times. And then you have the Greyjoys. So it seems that it's only the Greyjoys who have engaged in this raising type of battle. Then you have Stannis Baratheon. So here, if you look at this, you have no orange color bar, which would mean that Stannis Baratheon has never ambushed anyone. So either Stannis Baratheon was part of a pitched battle or he was part of a siege battle. So quite interesting observations over here. Now there is another data set. So till now we were looking at the battles data set. Now we have another data set called as character deaths, which would tell me about the different deaths which have occurred over here. So I have this character death CSV file. I am storing it in this new object called as death, and then I'll have a glance at the first few records. So these are the names of all of the characters who have died in the series. So, and this is in alphabetical order over here. So you have Adam Marbrand, who was, whose allegiance is Lannister. You've got Adric Humble, who belongs to the Greyjoy clan. Then you have the death year over here. So death year, obviously, it has occurred either at the year 298, 299, or 300. Then you have the book of death. So in which book has this character died? So when you have 3.0, this would mean that this character has died in the 3rd book. When you have 5.0, this would mean that this character has died in the 5th book. Then you have the death chapter, which would mean, so in the 5th book, Adric Humble has died in the 20th chapter. Similarly, Aegon Frey has died in the 3rd book in the 51st chapter. So interesting observation again. Then you have the gender over here. So if the gender value is 1, that would mean this guy is male, and if the gender value is 0, that would mean this character is female. And then you have nobility, which would tell you if this person is is actually noble or not. Then you got, then you basically have all of these names of different books over here. So this is the first book, this is the second book, and so on, which will tell you if this person has appeared in this particular book or not. So that is pretty much it about this. Now, what we'll do is we will look at the shape of this. So we have 9, 17, and 13, which would mean that there are 917 records which are present in this data frame and 13 columns present. So overall, we have 1917 deaths. Now, if I want to do a gender comparison with respect to the number of deaths over here, so I will just pass in this gender column and I'll use the value counts method. And here you would see that out of these 917 characters who have died, 760 of them are male characters. So 760 male characters have died, and it's only 157 female characters who have died. Similarly, if I'd want to know how many people who have died belong to nobility and how many of them do not belong to nobility. So this is sort of even. So out of all of the people who have died, 487 are not nobility, and 430 of them do belong to nobility. Then similarly, what I'm going to do is, so this was with respect to the character categorical columns. Now, if I want to understand about the death year, which basically means in which year, how many number of deaths have occurred, I'll use count plot over here, and inside count plot, I am passing in the death year column. So you have this death year. This is the column which I'm passing over here. And when I hit on run, you would see that. So you have all of these years. So these books basically depict this particular decade or this particular time zone from 297 AC to 300 AC. So it would seem that most number of deaths have occurred in the year in the year 299. So you have close to 160 deaths. So that's huge, isn't it? So you have close to 160 deaths which have occurred in the year 299 AC. Similarly, in the year 300 AC, you have around 100 deaths occurring. Then in the year 298 AC, you have around 42 deaths occurring. So it seemed that there was a lot of peace in year 297. There were maybe a lot of battles did not occur in that year, or maybe people were just more, more peaceful. So maybe you would have around only 5 to 6 deaths occurring in this year. So interesting plot again over here. So after this, now I'd want to know, out of these characters who have died, to which allegiance do these people belong to? Allegiance is basically to which clan have they, do they fight from? So again, for this, I'm using a count plot. Let me zoom this for you guys so that the text over here is clear. This is too much of zoom, so let me reduce this a bit. So if we look at this, so this is none. So you basically, so basically these are people who have died, but the allegiance is not stated. So it would seem that most of the deaths belong to the Night's Watch. So you have around maybe 110 or 115 deaths from the Night's Watch side. Then you have some allegiance over here who have around close to 100 deaths. Then you have the Greyjoys. So the Greyjoys seem to have around 50 deaths. Then we have the let's say House of Stark. The House of Stark has around maybe 30 odd deaths over here. But if you compare the other houses, so let's say if you talk about House of Baratheon, seems like very few people have died from the House of Baratheon. And similarly, if you look at the House Tyrell or maybe even House Martell, very few deaths have occurred from their side. All of this is the exploratory data analysis which I have done with respect to the different columns which are present in this data frame.
So let's understand now what is Plotly. So as I told you, Plotly is a free and open source library, and it is mainly used for the interactive plots. Now, you can also use Plotly to visualize the data, and along with that, Plotly supports several plots such as scatter plot, histogram, line chart, pie chart, area chart, and then it permits boundless customization. So that means, let's suppose that if you are using Plotly, so whatever the output you are getting it, you can zoom in, you can zoom out the plot, and along with that, you can pan it. So these customization you will not get in other libraries such as Seaborn or Matplotlib. So this is the basic idea about Plotly. So now after understanding what Plotly is, now let's see its installation. So basically you can install Plotly using pip in Jupyter Notebook. So you have to write just !pip install Plotly, or the another way you can install it through Anaconda prompt. So the code that you will be using here, conda install -c Anaconda Plotly. So these are two ways I will be installing through pip. So I will be using Jupyter Notebook. So I will go and click on this new, and then I will click on Python 3. And here you can see that I am getting as Untitled 22. So let me change the name here, and I will write here Plotly. So this is the name of my file. So now I have to install the Plotly. So let me write here Plotly, and I will comment it down with hash. Now after this, so if I want to install Plotly, so I will use here ! and then I will write here pip, and then I will write here install Plotly. Now let me execute this. So on execution, you can see that I am getting my output as requirement already satisfied. So this shows that my Plotly has been installed. So now let's see Plotly packages. So we are having plotly.tools, we are having plotly.graphObjects, we are having plotly.plotly. So let's start with plotly.tools. So basically this module contains useful functions that will ease and increases the Plotly experience. So the next package that we are having is plotly.graphObject. So basically this module gives us the graph object, and this is used to represent figures. So now coming to the plotly.plotly module, this module holds functions which requires a response from Plotly server. So this is the basic idea. Let's understand in coding so that we can understand these packages in a better way. So let's understand the Plotly packages with coding example. So once again I will write here from plotly.offline, and then I will import here iplot. So basically iplot means interactive plot. So what I will do here now, I will write here iplot, and inside this I will give argument. So let me write here x, and then let me give the values here. I will write here, let's suppose 1, 2, 3, 2, 1, and let me give the y values also. So I will give here 5, 10, 5, and let's suppose 0 and 5. Now let me execute this. So on executing, you can see that I am getting the graph like this. So basically in this graph, if you want to zoom in any point, you can do it. Let me show you. So basically you can see that at this point we are having the x-axis value as 2 and y as 10. Now so here you can see that I am also having the option of pan. So if you are clicking on this pan button, then I can drag it like this. So basically these are the features that you can get into Plotly, but you can't get in Matplotlib, right? And along with that, let's suppose if you want to download this output image, then you just click on this, and now here you can see that I can download this image in PNG, right? So these are the features in Plotly, right? Now after getting the idea about this iplot, now let's see the graph object package. So let me write here import. I'll write here plotly dot graph objects, and then I can give the name as geo. So basically geo means graph object. So I don't want to write large name, so that's why I'm writing here geo. Now what I will do here, I will create here a variable, and I will give the name as figure1, and then I will write here go dot figure, and inside this I will write data is equal to go dot bar, and inside this let me create a variable y, and I will give the values, let's suppose 5, 7, 2, and if I want to display it, then I will write here figure1 dot show. So let me execute this. So on execution, you can see that I am getting an error. So module object is not callable because I have to write here capital B. Now if I'm executing it, then you can see that I am getting my bar chart here. So here you can see that y value is 5, 7, 2. So this is y is equal to 5, this is y is equal to 7, and this is y is equal to 2. So this is basically a bar chart. And now if you want to zoom in, then this button zoom in, you can zoom in, and then for zoom out you can click on this minus button, and if you want to pan this thing, just click on this pan button and just drag it. And if you want to download this plot, then click on this button. So basically this is the basic idea about Plotly. Make sure that you must know the Python and then libraries like NumPy, Pandas, Seaborn, Matplotlib, so that you can understand everything easily while going further. So the next topic that we are having is various types of charts. So basically Plotly is used to make interactive graphs. So as I told you that with the help of Plotly library, we can make interactive graphs. So we can make graph like bar chart, we can make histogram, we can make line chart, box plot, heat maps, 3D scatter plot, as well as 3D surface plot. So we will implement each one of the graph in Jupyter Notebook. So the next topic that we are having is Plotly with cufflinks. So before understanding cufflinks, let's understand what is Pandas. So as we know that Panda is a very useful library that is used for the data analysis, right? But the problem is that Pandas plot doesn't provide interactivity in visualization. So here comes the cufflinks. So what happens here? Cufflink is a library which is used to connect Plotly with Pandas data frame, and it will generate chart and graph from the data frame. So now you have to install the cufflinks because by default it's not available. So you can write exclamation mark pip install cufflinks. You can install it, or either you can go on Anaconda prompt and then you can write there conda install -c conda -forge cufflinks -py. So this is basically a installation of cufflinks. Now after that you will import cufflinks. So I will import here import cufflinks as cf. So here I've written cf because I don't write the big name, and then after that I will write here cf.go and then underscore offline because I will be implementing cufflink offline. So now after understanding what is cufflinks, let's see it into the Jupyter Notebook. So I will be going on Jupyter Notebook and then I will click on this new button on Python 3. And then let me change the name of this. So I will write here Plotly library. So after giving the name, I know that first I have to install Plotly. So I will write here exclamation mark pip install Plotly. Let me execute this. And you can see that my Plotly has been installed. Now I want to install cufflinks also. So I will write here exclamation mark pip install cufflinks. So you can see that my cufflinks has been also installed. Now I'm assuming that you know about NumPy library, Pandas library, Seaborn library. So if you understand about these libraries, then it will be easy. So now let me import NumPy, Pandas, Matplotlib as well as Seaborn library here. So I will write here import NumPy as np. Then I will write here import Pandas as pd. Then I will write here import Seaborn as SNS. Now we know that NumPy, Pandas and Seaborn are the Python libraries. So NumPy is basically used for the scientific as well as numerical computing. Now coming to the Pandas, we know that it is used to visualize the data, and then Seaborn, we can plot the graphs using this Seaborn. So let me correct the spelling of this Seaborn. Now after importing Seaborn, let me import the Matplotlib also. So I will write here import matplotlib dot pyplot as plt, and then I will write here percentage matplotlib inline, right? And now let me execute this. So these libraries has been executed. So after this, what I will do, I will write here from plotly dot offline. I will write here import iplot. So we know that iplot means interactive plot, right? And after that I will write here import plotly as py. Let me execute this. So it has been executed. Now if I want to know the which plotly version I am using, so for that what I will do here, I will write here print and then I will write here py dot and then underscore underscore, I will write here version, and then once again I will write here underscore underscore. Now if I'm executing it, so on execution you can see that I am getting 5.3.1 Plotly version. So let me import cufflinks. So I will write here import cufflinks as cf, and I will execute it, and now I will write here py dot offline dot init underscore notebook underscore mode connected is equal to true. So basically what I'm doing here, I'm using Plotly offline in Jupyter Notebook, and then after that I've already imported cufflinks, right? So I will write here cf dot go underscore offline, and then I will write here open and close parenthesis, and let me execute this. So this has been executed. So now here you can see that I have already imported the libraries such as NumPy, Pandas, Seaborn, Matplotlib along with the cufflinks. So now what will happen here, I can directly use the Pandas data frame to display various kinds of plots without using trace and figures of graph object module. So this is the advantage of using cufflinks. Now let's understand how we can use cufflinks. So what I will do here, first I will create a variable. Let's suppose pd1 I am creating here, and then I'm using this pandas as of now. So I will write here pd dot data frame. So I will write pd dot data frame, and basically it's an empty data frame. And if you want to check it out, then I will print here print, and then I will write here pd1. So here you can see that this is the empty data frame. Now what I will do here, I will write here help, and inside that I will write pd1 dot iplot. So as I told you that we can use cufflinks to connect pandas data frame with Plotly. So now what will happen here, let me execute this. So you can see that here while executing I am getting here help on method underscore iplot in module cufflinks dot plotly tools, and here you can see that inside this iplot I am getting a kind as a scatter, data as none, and here you can have different kinds of charts such as scatter, bar, box, spread, ratio, heat map, surface, histogram, bubble, bubble 3D, scatter 3D. So we'll see all this. So moving ahead, let me write a variable df1 once again, and this time, so let me write here pd dot data frame, and inside this data frame I will be using a NumPy. So you can see that here I've already imported a NumPy library. So I've written here import NumPy as np, right? So here I will write np dot random dot random, and inside this let me write here 100 comma 4, and then once again I will give comma, and then I will write here columns is equal to, and let me write here a comma, and then I will write here b, c, and then d. So here you can see that here 100 is the row and 4 is my column, right? So that's why I've given the column name as a b c d. Now if I want to print this data frame, so let me write here print df1, and here you can see that on execution I'm getting my output. So as I told you that I am having 100 rows and 4 columns, right? So I'm getting a b c d. Now instead of that I will use here df1 dot head. So when I'm using df1 dot head function here, so basically head function give me first 5 records. So let me execute this. So on execution you can see that I am getting first 5 records from 0 to 4, right? So let's suppose that if I want first 10 records, then I will put here 10 inside this head. So you can see that I'm getting first 10 records from 0 to 9, right? So this is the basic idea. So after this, let's suppose I want to plot this data frame. So how can I do? So what I will do here, I will just write here df1 dot iplot, and on execution you can see that I am getting graph, right? So here you can see that at 0 these are the values, right, of a b c d. At 1 these are the values. So here you can see that we have plot this graph. Now if I am clicking on this iplot function, and if I am pressing the button shift and double tap, then here you can see that I am getting a kind as a scatter, right? So by default I am having a scatter kind, right? So if I am pressing here double tap, then you can see that the data is none, layout is none. So you will get all the information, right? So you have to just press shift and double tap. Now moving ahead, as I already told you about the features of Plotly, so you can zoom in, you can zoom out also this thing. Then if you want to suppose visualize at this particular point, then you can just click like this and you can see, right? Now, if you want to pan it, then you can click on this pan button and then you can pan it, this graph also. So basically this is a graph that you can see that we have made using Plotly. So now instead of Plotly, I will use now Matplotlib. So here you can see that here I've imported matplotlib.pyplot.splt. So now what I will do now, I will just write here simple plt.plot, and inside that I will write df1. This is my variable which contains here data frame, right? So now if I'm executing it, then you can see that even I am getting the graph here, but the features that are present in Plotly, like you can zoom in and then zoom out, then you can also do the pan, right? But here in Matplotlib, here you can see that we are unable to visualize the data properly as compared to Plotly. So the Plotly provides extra features that we are unable to find in Matplotlib. So now after this, now let's see some more interactive graphs. So now what I will do here, once again I will write here df1 dot, and then I will write here iplot, and inside this I will write here x is equal to, let's suppose I'm assigning c here, and then I will write here y, and I will assign here d, and let me execute this. So you can see that this is the type of graph that we are getting. So using this Plotly, we can have different types of interactive graphs. Now after this, so let's see some more graphs. So I will write here df1 dot, and then I will write here iplot, and let me write here once again x is equal to c, and then I will write here y is equal to, let's suppose d. Now what I will do here, I will set here mode. So I will set here mode as markers, and now if I'm executing it, then on execution you can see that I am getting a graph like this, right? So in this graph, let's suppose if I want to increase the size, so what can I do? I will simply write here df1 dot iplot, and then I will write here x is equal to here c, and then y is equal to d, and then I will write here mode is equal to markers. So I will write here markers, and then I will write size. So let's say I want to assign size as 50, so I will just write here 50, and on execution you can see that size has been increased, right? Let me change the size to 30 so that it can look better. So now if I'm executing, then you can see it, right? So now let's see some more graphs. So what I will do now, I will write here df1 dot iplot. So here you can see that inside this iplot, let me just click shift and double tap. You can see that by default my kind was scatter, right? So I was getting a scatter graph earlier. Now I have showed you that we are having different kinds of charts. So here you can see that if you go here, then you can see that we are having bar chart, we are having box, we are having spread, we are having heat map. Okay, so let me change the kind here. So I will just write here kind is equal to, and then I will write here bar. So if I'm executing it, so this is the bar chart, right? So let's see some other kind of chart in Plotly. So once again I will write here df1 dot iplot, and inside this once again I click shift and double tap. So you can see that what are the kind of charts are available here. We can have here box, we can have spread, ratio, heat map, surface, even histogram. So let's write here histogram, right? So if I'm writing here histogram kind is equal to histogram, and if I'm executing it, you can see that I'm getting a histogram, right? Now once again if I'm writing here df1 dot iplot, and then I'm writing here kind, and inside this I will write box. So let me execute this. So you can see that I'm getting a box chart, right? So this is basically a maximum value of A, right? This is the minimum value of A. Similarly, this is the maximum value of B. This is the minimum value of B. Similarly for C and D, right? So this is the box chart. So you can see that we can make several types of interactive graphs using Plotly. Now, after plotting box graph, let's see, this was my bar graph, right? Let's suppose if I want a gap in between. So what I will do here, let me create a new shell. So I will write here df1 dot iplot, and then I'll write here kind is equal to bar, and I will give here comma, and then I will write here bar gap, and let's suppose I am giving a bar gap as 0.75, and if I'm executing it, then you can see that I'm getting a gap, right? Let me zoom it. So you can just click this particular portion to visualize, right? So this is the best thing and the best feature about the Plotly, right? We can visualize the data very easily here. So if I want to see my previous image, so let me zoom out. So this is my bar graph which is having bar gap. Now, so after this, let me see what we are having more in iplot. So once again, I will just click inside this iplot function, and then I will just click on shift and double tap, and here you can see that we are having a lot of things here. So if you see here, we are having a bar mode, right? And we can have the bar mode as group, stack, and overlay, right? So let me show you. So let me create a cell after this. So if I'm creating a cell, and if I'm writing here df1 dot iplot, and then I will write here kind is equal to, let's suppose, bar, right? And then after that, so I will write here bar mode as, let's suppose, stack, and then I will write here bar gap as previous one 0.75. So if I'm executing it, you can see that, right? So as the name itself suggests, stack, right? So here you can see that A, B, C, D are here overlapping, right? Now let me create one more cell after this, and once again I will write here df1 dot iplot, and inside this I will write here kind is equal to bar, and then I will write here bar mode as, let's suppose, overlay. And then after writing overlay, what I will do, I will just write here bar gap 0.75, same as previous one. Now if I'm executing it, then you can see that I'm getting the graph like this, right? So after this, we are having one more bar mode. So let me copy and paste this thing, Control C, and once again I will copy and paste. So now here, instead of overlay, I will write here group. So let me write here group, and now if I'm executing it, then you can see that I'm getting a graph like this, right? So you can see that we can make a lot of interactive graphs using Plotly. Let's see some more. So after this, let me use couplings. So I will write here cf dot get themes, and if I'm executing it, then you can see that these are the themes that coupling is providing. Now what I will do here, let me implement this. How can I implement this? So I will write here cf dot set underscore config underscore file, and let me set the theme here. So I will write here theme, let's suppose I'm writing here solar. Now how can I implement it? Let me take the example here itself. Let's take example of this. So let me copy and paste this, Control C, and I will just paste here, and if I'm executing it, you can see that I am getting a background as solar. Now instead of solar, let's suppose that I want to change it. So let me copy and paste. If I'm writing here, let's suppose polar, on execution you can see that this is the color that I'm getting. Let me change with some another. So let me copy and paste, and this time I will just use ggplot, Control C, and then Control V. On execution, you can see that I'm getting my graph like this, right? So you can use several themes like ggplot, Perl, solar, space, white, and polar. So now after this, let's suppose if you want to draw the 3D plot, then how can you do? So let me write here, once again I will write here df1, but before that let me change it to the white. I'm just changing it to the white, or else it's fine also, but white looks cool. So I will just write here white, and here you can see that I am getting in my normal color. Now for 3D plotting, I will just simply write here df1 dot, and the same thing iplot, and I will write here kind, and inside this kind, earlier I was writing bar, scatter, histogram. Now I will write here simply surface, and now if I'm running it, then you can see that, right, this is a 3D plotting, and the best thing that I can drag it, right? So basically you can see that Plotly is used to give us interactive graphs. And then let me pan it. I can pan it also. Let me rotate it. So here you can see that we are getting really cool graphs, right? So I just click on this reset camera to default. So it's my default now, and if I want to zoom in and zoom out, I can do it. So let's see some more interactive graphs. So I will write once again here df1 dot iplot, and instead of surface, let me change the kind. So here instead of surface I will use here spread. So let me write here spread, and if I'm executing it, then you can see that I'm getting a graph like this. So you can draw beautiful graphs using this Plotly library. So after seeing this many graphs, now let's see about the couplings module. So we are having a coupling.datagen module. So what is it? Let's look into this. So I will write here help, and here we have imported couplings as CF, right? So I will write here CF dot datagen, and if I'm executing it, then you can see that help on module couplings dot datagen in couplings, right? Here you can see that we are having n is equal to 3. So here n is int and it's a number of points for each trace. Next we are having categories, so it must be also in integer, and it's basically a number of categories for each point, right? Next we are having a prefix which will be a string, and then columns. So in columns we are having a list of column names, and then again we are having the mode as a string, right? You can use this module for bars, you can use this module for box, bubble 3D, and even for heat map, and then scatter 3D you can use for histogram also, lines, right, and many more. And you can also use this module for sine wave, and then surface, violin. So now after having little bit idea, now let's implement this. So now let's draw a graph using this coupling datagen. So what I will do, let me create a new shell, and which graph shall I create? So let me first start with the sine wave, right? So here you can see that I'm having a sine wave, and here n is the integer, and it ranges for x and y axis from minus n to n. So what I will do here, I will just write here cf dot datagen, and I will write here dot sine wave, and inside that let me write here n is equal to, let's suppose I'm having 17, and then I will write here the size of increment along the axis. Let's suppose I'm having here 0.50, right? And let's draw this sine wave into the 3D plot. So what I will do here, I will just write here dot iplot, and inside that I will just write kind is equal to surface. So if I'm executing it now, you can see that I'm getting a sine wave graph, right? Let me zoom it here, right? So now after seeing sine wave graph, now let's plot some more graphs. So let's see in datagen what we are having. We are having scatter 3D also, right? So let's plot scatter 3D. How to plot scatter 3D? So once again I will write here cf dot datagen, and after that I will write here dot. You can see that we can plot here scatter 3D. So I will write here scatter 3D, and then n categories, right? Number of categories are there, and the number of points for each trace. So let me write here scatter 3D, and then I will write here, let's suppose 5, and then comma, let's suppose 50. So after this what I will do here, if you see here, then we are having prefix is equal to category, and then mode is equal to none, right? So instead of mode I will write here stock. So I will write here stock, and then I will write here dot iplot, and let's draw this graph into a scatter 3D. So I will write here kind is equal to, and then I will write here scatter 3D. Then I will assign here x equal to x, and then y is equal to y, and then z is equal to z. So if I'm executing it now, so if you can see that I'm getting here, it's showing unknown mode stock because it will be stocks. So now if I'm executing it, you can see that I'm getting a scatter 3D graph, right? It's a very interactive graph. You can see it in all directions. So now after plotting scatter 3D, so now I will plot a graph of bubble 3D. So once again I will write here cf dot datagen dot bubble 3D, and then let me write here 5,7, and then mode once again I will give stocks, and then I will write here dot iplot, and after that I will give here the kind as bubble 3D. So I will write here bubble 3D, and then I will write once again x is equal to x, and then y is equal to y, and then z is equal to z, and then I will write here size is equal to size. And on execution, you can see that I am getting a bubble 3D graph, right? So here you can see that we have drawn the graph of bubble 3D using couplings.datagen module. So this is the basic idea about Plotly library. So now let's see plotting in line with Jupyter Notebook. So the best thing about Plotly is that you can generate the graph in online as well as offline mode. So if you want to plot the graph offline inside a Jupyter Notebook, then we have to initiate Plotly notebook as from plotly.offline import init underscore notebook underscore mode. Then we will write init underscore notebook underscore mode, and then we'll write connected is equal to true inside the parenthesis. So this thing we have to write in order to work with Jupyter Notebook. So let me write here, I will write here from plotly.offline import init notebook, and then I will write here mode. And then once again I will write here init underscore notebook underscore mode, and then I will write here connected is equal to true. Now let me execute this. So you can see that this code has been executed. So now we can work on Plotly in Jupyter Notebook.
Alright guys, so to come to the first point on the agenda, what is Scikit Learn? Well, the name seems to be pretty fancy, right? Scikit Learn. I mean, why is it called Scikit Learn, or what is it in fact, or how is it associated with Python? I'm sure your head is, you're wondering about a lot of these questions. Let me answer them. First of all, let us understand what it is, right? Scikit Learn is a library in Python. Now, when I say a library in Python, it basically brings its own set of functions. It brings its own syntax. When I say syntax, it basically brings into its own picture a lot of these helpers, a lot of these things that not only shorten the code but give us immense amount of power and flexibility for a small amount of code, again, to have a large impact, as I previously mentioned, right? Not just Scikit-learn, Python is known, Python is popular, and I popularly say it in all of my talks and all of my seminars and all of that, that Python is popular because of the fact that, one, it is written amazingly well. You can write Python beautifully. Syntax is amazing. The second thing that makes Python so great and makes it want everyone around the world to go mad about it is for a fact that it has these libraries which are taking extremely complex tasks and eventually simplifying it to the maximum extent so that you and I can work on it with ease, right? We have an entire community to thank. Of course, the Python community and the Scikit-learn community, you have to understand, but all of these are like open source. So at the end of the day, for you, it is completely free to use. So if you're wondering about starting machine learning in Python, you really don't have to pay anyone anything to actually maybe buy the tools to use it, because Python is free. Scikit-learn as a library is free. You have multiple IDEs, integrated development environments, that you can use to work with Python for free. Well, at the end of the day, you really don't have to pay a penny to actually get your hands dirty out there, right? So what is it about Scikit-learn? Scikit-learn, is, people usually call it the father of machine learning in Python, as in a library, right? It's a way of explaining and understanding the importance of the library. Scikit-learn as a library itself is considered to be a core library in Python. Now, when I say a core library, what I basically mean is that it has extreme importance, because without the library Scikit-learn, it would actually make it very, very difficult for us to manually implement machine learning. Now, what I mean, just keep this in your mind until the end of the course, because when I actually practically show you how simple it is to work with this, then you'll realize saying, okay, so if it weren't for this library, that task would have been absolutely horrendous to do, right? So you're going to be understanding all of that firsthand. And again, as I just told you, right, it's a library that is considered super important, not just for machine learning, but at the end of the day, when you think about Python's library, set of libraries that make Python popular, Scikit-learn is sitting way high up in that chart. And as you can see, it's also say that it's used alongside other beautiful libraries like NumPy, Pandas, or even Matplotlib. We're going to be using all of those libraries in the demo that I just spoke about. But yes, NumPy stands for numerical Python. Pandas is a beautiful library which will give you more data structures to play with. Matplotlib is a beautiful library that will help you with data visualization. So overall, when you're trying to devise a machine learning solution, you're going to be using all of these in conjunction, right? It's not just you using Scikit-learn. Scikit-learn gets the machine learning part of it done. But to convey the machine learning part of it to a generic audience, or to even explain it in a fashion that it would be understandable by a wide wide audiences where you would require something like Matplotlib. But to make your own machine learning algorithm understand the data, you have to feed it in a very structured manner. For that, you're going to require Pandas. If you're performing any numerical operations, you're going to require NumPy. So in this one sentence that I just told you about, I basically condensed the entire process of handling a machine learning project, and you'll understand that even though Scikit Learn is the center of the project, it actually fits in a way bigger picture which is leading to the overall solution, right? That's a really fun part to understand. Now, coming to machine learning is a domain of its own. It's a league of its own. So Scikit Learn is basically a library. It's like a doorway. It's like a path that almost, I want to say everyone, almost all the learners, take to get towards the domain, right? As you might already understand, right now, wherever and whatever form you're watching this content, there is a bit of machine learning going on in the video player that's maybe using it, or the website that you're watching this on, or whatever it is, right? Right from your phone, your mobile phone, even my watch basically is smart these days. It uses machine learning to continuously analyze and assess what I do so that it can help me better. How fantastic is that, right? Now, if it can help me like that on a personal basis, be it fitness or whatever it is, think about what it can do around the world where we have so much requirement, right? So literally, it has millions of applications and millions of developers who are working day in and day out to make machine learning more accessible to all of you all, first of all. And at the end of the day, it's not just accessibility, it's the way of simplifying a complex domain such as machine learning to make sure you understand it easily, right? Because without Scikit Learn, again, to reinforce on the same, it would have been very difficult to implement some very simple machine learning solution, because you have to manually just think about the process of machine learning. You're getting your computer to learn a lot of things which it has probably not learned before, it has not seen before, right? Now, you and me, we are cognitive species. We can go about learning really rapidly. When it comes to your computer, when it comes to your laptop, mobile phone, anything digital, in its most fundamental sense, in its most basic sense, the more in depth you dive into your computer, you will understand that you will reach an end point where your machine only understands zeros and ones. Everything in your computer's world is just zeros and ones. Now, you would probably be reinforced for a fact that you might think humans are the most intelligent species out there, and now you probably figure out saying why probably you're faster than your computer or something like that, right? But yes, once it becomes that simple, you have to teach your computer to learn, right? You have to make sure it understands what it is seeing. That process in itself is extremely complex, but thanks to the world of statistics, mathematics, and programming, we have basically dumbed down a very complex process to make sure that, even not just researchers, but even freshers, beginners, students, whoever wants to get into the domain can beautifully work with it. And Scikit-learn, again, is a very, very big reason for all of this, is definitely in my belief as well. Now, whenever you think about machine learning, whenever you think about using a library such as Scikit-learn for machine learning, your library must be able to do three things with ease, right? With any machine learning algorithm, you're going to require some sort of representation, you're going to require some sort of evaluation, and you're going to require some sort of optimization. Now, what do I mean by this? Let's take a look at representation for a second. Now, representation basically is talking about the capability of Python, the capability of your working environment to actually you using tools and techniques to make sure that your data is configured in a way wherein your machine learning algorithm can sort of ingest it, can understand it, can work with it, can import it. All of these words that I just said, right? Yes, that is representation. Finding a way to getting your machine learning algorithm to realize that, hey, here's the data, here's how best I can use them. Scikit-learn works beautifully there. I'm going to show you how. And then talk about evaluation. Evaluation is where, I think is the most human dependent concept, because you will be wondering about a hypothesis you might have in mind. You might think that a solution might work, or you might have a problem statement in mind and a solution. And when you start implementing it and you start making assumptions based on which either your solution will work or not, to support this exact thought in the world of programming, it's you thinking is very different from you writing a program to get your computer to think. Scikit-learn will help you with respect to evaluation as well. Of course, it will help you with evaluation, because evaluation is the heart of machine learning. After it learns something, you evaluate it to see if it has learned anything or not, right? That's how probably the entire world's education system is. You're probably given a couple of textbooks, a couple of notes or whatever it is, reference material to study. You study all of that. Eventually you go back to your school, college, university, whatever it is, and you write an examination to showcase that you have learned something. You're proving that you have learned something from your memory, right? You're recalling it. You're showcasing what it is that you have learned. We want our machine learning algorithm to have that capability, and it is very well done. Now, the third thing that the library should help you do is optimization. Now, when I say optimization, think of a situation where you have created a machine learning solution. It is working well maybe to the level of 75% accuracy, right? Now, in the general machine learning world, anything above 80 and all the way to 90-95% is considered to be really, really good accuracy in terms of a machine learning model. Now, it's not just you write a program once, you execute it, the solution is working well, boom, you're done. That never, ever happens in a real world situation. In a real world situation, you'll be the happiest guy when your solution actually starts working towards the goal. But it is also a starting point to make sure you can tune your model to perform better. Think about a very simple example, right? Let's just say you just want to start running. You really like running marathons. You love people whenever they post stories of running like 10 kilometers, 5 kilometers, 15 kilometers and all of that. You want to do it. Day one, you would probably not be able to run 10 kilometers or 15 kilometers at a stretch. Maybe with 6 months of everyday training, you can do it with ease, right? First day, you try it out. Maybe 1 kilometer, you run really well and then you're tired and you're like, there's no way I can run 10 more. But maybe 6 months later, that starting 1 kilometer becomes like the easiest warm up ever. And you can maybe run 20 more at your best performance ever, right? So what happened over those months? You learned, your muscles are trained better. Everything in your body is working towards you becoming faster and having more endurance. Similarly here, we find ways to ensure we can train machine learning algorithm not just to solve a problem, but we are continuously changing something in the way it learns to make sure that at the end of the day, you have the maximum accuracy possible. So you're tweaking, you're tuning, you're making some changes to get your machine learning algorithm to understand better, and if it understands better, what happens? It gives you a better result that you can take away, right? So it becomes very important in this part of our discussion. Now, coming to the origin of Scikit Learn, you might have seen machine learning's popularity like rapidly increase all around the world, maybe like what, in 2012, 2014, right? A couple of years back, less than 10 years back. So it is, whenever again I go to seminars and I address an audience, they always ask me saying, hey, this is a brand new library which beginners might have not heard of. Well, to your surprise, Scikit Learn is actually over 10 years old. It was basically developed as a summer project, Google Summer of Code project in the year 2007 by this person, a really talented person called David. And originally it was called as Scikit Learn with a S at the end. And of course, we don't have that S anymore. And what started as a project, a brainstorm of one very talented individual, the project actually went public in the year 2010, after having some sort of research application development. And right since 2010, where are we right now? 21, 22, right? So when you think about it, 10 years back, a library which was made open source, popular, and everyone in the community are not just working to use the library, but there are thousands of developers and millions of intelligent people who are making the library better, as in they're working on the library to make sure you and me can have a more easier way to work with it, right? So Scikit Learn started out as a research project. It went public. It is open source. It is free. It has millions of collaborators who are working to improve. In fact, there are developers right now as you're watching this course, who are working on improving and bringing a better version of Scikit Learn, right? And all of that is being done for free, mind you. And at the end of the day, Scikit Learn is used commercially everywhere around the world. So that should really tell you about not just the power of machine learning, but really the brains. And my kudos to all the contributors who have made sure that we have a very good library such as this, right? Now, you might be asking a question saying, wow, this sounds really fancy, but what are some of the things that I should know about when I begin working with Scikit Learn? Well, I can tell you one important thing. There are definitely certain prerequisites when you have to think about working with Scikit Learn. And mostly, as I told you at the start of the course itself, it is the dependency with other libraries, because Scikit Learn fits as a puzzle piece on a very big scale to make sure you get towards a solution. It is not the only puzzle piece, but it is just one among a lot of other things that you're going to require, right? So what are these other things that you're going to require? First of all, we're discussing Python. So you definitely require the understanding of Python syntax. You need to know how Python syntax is written, and you must have the capability to, take something in your head, a thought in your head, and maybe put that down as code. That is going to be a skill that's going to help you a lot in machine learning. Then working with libraries such as NumPy and Pandas and Matplotlib and even SciPy, it stands for Scientific Python. All these libraries that you're seeing on your screen right now, NumPy, SciPy, Pandas, and Matplotlib, they are 90% used together with Scikit-Learn in all of these solutions. So as and when you're learning Scikit-Learn, if you're brand new to Python, brand new to machine learning, watching this course, I highly suggest you spend some time learning Scikit-Learn, at the same time ensuring that you're up to speed with NumPy, SciPy, all the other libraries which are sometimes direct dependencies, right? Now, in the demo that I'm going to be showing you guys, you will realize that it's not just Scikit-Learn that I'm using. For example, the way we ingest data, the way we bring in data, we primarily require Pandas for that. And once you work with it, maybe at the end of the solution, you want to create beautiful looking charts and graphs to showcase the solution. You're going to require Matplotlib for that. Maybe you want to do some array computations and you want to change some values and make sure your data is fed into your model in the right way. You might require a bit of NumPy as well, right? And if you're performing all these statistical operations, data analysis, you're hunting for a lot of insight in your data, you're going to require SciPy. So all in all, a bit of everything is required. But my goal here is to tell you guys, if you do not know, either of these or any of these at this moment of time for this course, it is completely all right, because I promise you, you can follow to the end of it and you can definitely take away a ton of insights from the course, right? Fantastic. Now that we are done with that section, ladies and gentlemen, now we know what Scikit-Learn is, we know its importance, we know its origins, we know the prerequisites, we know what it does, we know that it is a fantastic library, right? So to get you guys started, here is a section where we can discuss about how you guys can install Scikit-Learn. Now, installing Scikit-Learn is very, very simple, because at the end of the day, you never have a hassle to say, oh, my operating system is not supported, right? It is a very common issue that happens. You guys are Mac OS users. There is always a situation where there is an app which is maybe not built or not ready for Mac. In this case, never. Python is widely available in any operating system that you can think of. And if Python is available, there's a very good chance that the libraries that are associated with Python work in multiple operating systems, right? So regardless of the operating system that you actually use, be it Windows, Linux, or Mac OS, I'm sure you guys watching this course are using all three of these, right? So I'll actually help you to install this library in all three of these operating systems. It's really a piece of cake, and we're going to be done with this section, I bet, in the next 5 minutes, right? So firstly, let's just talk about Windows and Linux, because it's very straightforward here. Now, to install a library for Python in Windows or Linux, you have something called as pip. Pip basically stands for, it's a package manager. It stands for pip installs packages, right? So whenever you have to install a package, such as Scikit-Learn, libraries are also called packages. When you have to install it, you basically use the help of another application which is built to install the library of your choice. So it is a standard package manager. It comes built in with almost all the operating systems that we have today. And to actually install the library of Scikit-Learn, you have to run one line of command, pip install Scikit-Learn. As you can probably see here, of course, we have 1 or 2 tabs, which is adding a little bit more of functionality about how it installs. But at the end of the day, if you're on Windows or Linux, all you have to do is open up your command prompt, you open up your terminals, and if you install it via Anaconda or something like that, open up the navigator, open up a command line interface, type in pip install Scikit-Learn, and it works. Now, in Anaconda is basically a distribution that will help you install all of these at ease. It not only installs Python, but it installs all these libraries which we are actually discussing these days. It will install it automatically for you. There again, if you, for some reason, if it is not installed, and if you want to manually install it, all you have to do is open up the prompt, Anaconda prompt, type in another command, conda install Scikit-Learn. So we went from pip install Scikit-Learn all the way to conda install Scikit-Learn, and this works for Windows. I think most of the version of Windows and most of the Linux flavors, Ubuntu, whatever it is that you guys are using, right? So how simple is this? You have to open a terminal, run a command, done, right? 3-4 steps, you good to go. So it's pretty simple installing it on Windows and Linux. And similarly, if you've been waiting for the section where I say, oh, it's a bit difficult to install on Mac, not really. It's actually as straightforward as us installing it on Windows or Linux, because here again, Mac OS provides you with Homebrew, right? Homebrew is beautiful, and Homebrew is not the only way of how you can install Mac OS. You can actually install Anaconda here as well. Anaconda is supported for Mac OS. You can install Anaconda, through which you can run the same conda command that we discussed, and you are good to go. Now, let's just say you want to install it via Homebrew. Installing via Homebrew is very simple. First of all, you're going to have to install Python itself. Brew install Python will get you to get Python set up on your machine. And after Python is installed, again, it's another simple pip command. Pip install Scikit Learn, and boom. Now you have Python set up. Now you have Scikit Learn set up, right? So again, just quickly pause in whichever section that you wish. Maybe you're a Windows or a Linux user. Pause in those sections. You're a Mac user. Pause in this section. Get it all set up. And I promise you, it's gonna probably take you maximum of 10 minutes to get everything set up for you guys to start using Scikit-Learn, right? So as you can take a look at it, it's very, very simple and straightforward. But you might be asking your question saying, okay, so now I installed it, what next? What do I get after I finish the installation? What is Scikit-Learn giving me after installation, right? Well, first of all, we have to discuss about how it is used completely in the world of machine learning. And in machine learning, supervised learning algorithms are really, really popular, right? Everywhere around the world, but a majority of the solutions are definitely supervised learning algorithms which are put into use to get the solution done. Scikit-Learn supports many supervised learning algorithms that are out there, and whenever you have to find a way to train your machine learning algorithm better, or find a way to use a certain set of data to make sure that it runs through the same data multiple times and learns better, it's a technique called as cross-validation. And here as well, it's not just one technique that is given to you. You have multiple methodologies that you can use with respect to cross-validation as well. And not just supervised learning algorithm. I'm sure you read the first point and you're like, okay, where is unsupervised learning? Well, of course, it's the core library for machine learning. So you have to have a lot of unsupervised algorithms, and yes, there's a lot of support for that as well. Now, it's not just that you get the functionality of supervised learning algorithms or unsupervised learning algorithms or anything around that. When you have these algorithms, what do you require to start learning and using them? You're going to require data sets, right? So we actually have multiple data sets that come built in with Scikit-Learn. Think about the Iris data set. Think about the Boston housing data set. All these data sets are, if you're a learner, these are like the pathways that you have to take. And once you've started working with these, right? So whenever a machine learning enthusiast actually comes onto the picture and wants to learn machine learning, I am very, very sure they go through all of these data sets to actually learn the basics of machine learning. And I promise you that you might have heard of it, right? So what Scikit-Learn people have done is they realize that these are the data sets that are being popularly used by people to learn. So they just built it inside Scikit-Learn. So if you have to ever use Boston housing dataset, if you use Iris dataset or anything as such, you can actually do two ways. One, you can manually import it if you have the dataset ready in hand. Many cases you might not have the dataset in hand. That's when you quickly actually run a couple of commands in Python and it automatically imports it because the library already has it for you, right? Fantastic. Look at the last point. It says support for feature extraction like bag of words or more. Now, bag of words and all these concepts are super popular in the domain of natural language processing. It has its own library called NLTK, which is super popular for that. But then again, in collaboration with NLTK, in collaboration with natural language processing, you would see that machine learning has a large role there to play, right? So there again, there are multiple support for features which are dependent not just for that subdomain of natural language processing, but it brings together again another piece of the puzzle, which is you using machine learning to solve it. There again, support is provided, right? So it's, as I just told you, this is probably one of the best slides to tell you that it is an all-in-all solution for machine learning in Python. And this is everything that you get after running two simple commands. Now think about how easy it must be to actually go about using these libraries, right? Now, coming to a section where we can discuss what are some of the algorithms that are supported, by this library Scikit-Learn, right? As I just told you, since it's the core library, it has to support a ton of these supervised and unsupervised learning algorithms, and it does. So whenever you have any supervised learning tasks which uses regression or classification, it can be worked with ease. Now, when I say regression, think about maybe performing predictions in the future. Think about weather prediction. Weather prediction is a beautiful example of regression. Then if you want an example for classification, think about me giving you a couple of fruits and saying, can you keep all the apples to the left side, oranges to the right side, and maybe keep all the bananas somewhere else? Could you not do that? Yes, if you can do that, you teach your machine how to do that, and that's called classification and supervised learning, right? And then comes unsupervised learning. Of course, unsupervised learning is broken down into two types. It's clustering and association. And Scikit-Learn works really good for both of these applications. Now, when you say clustering, you're basically trying to find the common entities. You're trying to find the common characteristics in your data points, group all of these common entities, and eventually try to make assumptions out of it, try to have data-driven decisions out of it, or at the end of the day, use your own clusters to make sure that you are finding maybe better ways of analyzing something, or eventually you are dividing it into clusters to help you further down the line. Either way works really great, right? Clustering is sort of similar to classification, but here the way it works, the way your algorithm itself works is different because it's not supervised, it's unsupervised, right? There's no labels for learning here. And then association. I promise you have used association. Every time you go on to Amazon or any other e-commerce site to actually buy something, let's just say maybe you bought a brand new phone, there's a sale happening, you bought a new phone. As soon as you add the new phone to the cart, have you ever seen that Amazon or any other site, it recommends a lot of other stuff that people have bought. It says, hey, people who have bought the mobile phone also have bought two other things. It's very common. One is a tempered glass, the other one is maybe like a protective case for the phone. We know that majority part of the world, we love putting cases on our phones. In fact, I have a case on my phone right now, putting tempered glasses as well. So Amazon is like sort of telling you, hey, people who have bought that, they've also bought this. So they're making more sales and they're probably making it more convenient for you. You maybe require a tempered glass in a case and they're giving it to you at your fingertips, right? So that is association. It happens in Netflix. Maybe if you watch like 10 continuous crime detective stories, the 11th one Netflix is going to recommend to you is going to be a crime detective story. It's not going to be a comedy TV show they'll recommend to you, right? Because they know what it is that you want to learn or what it is that your tastes are and eventually cater to that. And all of that is happening by making use of machine learning, right? So guys, in terms of support for algorithms, there's amazing support for algorithms. If you want to quickly take a look at the supervised learning algorithms that are supported, of course, there's more algorithms that are supported, but as you can see, you have naive bias, you have decision trees, you have KNNs, K nearest neighbors, support vector machines, random forest algorithm, RFA as it's called, or SVM as support vector machines are called. These are like the really popular algorithms. And one side of your thought may be saying, hey, these are like 5 algorithms. How are they solving the entire world's problems? But you'll be surprised to understand how powerful they can get if you provide good quality and quantity of data to perform analysis, right? And in this particular demo, actually, we are going to be taking a look at a KNN implementation. We're going to be understanding how easy it is, how fun it is to work with KNN algorithm. And I'm going to be using the KNN algorithm as a demo in the practical section that I'm going to be showing, right? It's a really interesting demo. Don't worry, before I get into the practical aspect of the demo, at that section, I'm going to make sure that I'm going to explain to you, theoretically how the algorithm works and give you ample amount of examples so you understand it, and then take you guys to the code to help you understand it in the form of code, right? So supervised learning algorithms are great. What about unsupervised algorithms? Well, of course, think about clustering, think about Gaussian mixture models, neural networks, bi-clustering, density estimation. Now, even if you are slightly older into machine learning, even if you're experienced in machine learning, some of these names might be a surprise to you. And that again is one of the ways of the world, right? As I told you, majority of the machine learning applications out there mostly use supervised learning algorithms. And of course, there are ways in which unsupervised learning, you cannot match unsupervised learning in the way it learns. So of course you need support for it, and you're going to require some really good algorithms to make sure that at the end of the day you can use these to have powerful solutions at the end as well, right? So supervised algorithms, we took a look at it. Unsupervised algorithms, we took a look at it. And with this, I think it's the high time we take a look at the applications of Scikit-Learn. So coming to the next section, applications of Scikit-Learn, one of the most fascinating things about the domain of Scikit-Learn you have to understand is that it's extremely popular. When I say extremely popular, I should have probably put it out in caps, because again, right from Netflix to Amazon to healthcare, everyone around you, there's a very good chance the vegetable vendor around you might be using a bit of machine learning to understand what vegetables sell when and how good they sell in which season. There, I just gave you another solution to a problem statement, right? So you can actually, if you're talking about applications, you have to understand that we'll have to generalize a lot of things in this discussion, because at the end of the day, there is a lot that we can go on to discuss, right? So to actually give you a bit of an idea in terms of applications, look at this. We have everything from product development to neuroimaging. Neuroimaging basically talks about how you can, pick up all these MRI scans and CT scans and all of that, right? Pictures of your brain. And probably if you've ever seen a CT scan or an MRI of your brain, to an untrained eye, you have absolutely no clue what's going on. But to a trained eye, to a doctor, to a neurologist, or even to a very highly trained machine learning algorithm, it can make a ton of sense, which probably me and you cannot, because we are not experts, we're not doctors there, right? And then again, medical modeling, financial risk analytics, price predictions, everywhere. Medical modeling is really, really important, because even in the creation of vaccines, right, understanding how you can fight viruses and bacteria, you can have thousands of scenarios be trained by a machine learning algorithm to say what happens when this drug is maybe provided and is maybe pushed onto that virus, pushed onto that bacteria or whatever, right? So there's a ton of things in medical modeling that are using machine learning actively. Now, it might come to a surprise to you that I'm highlighting healthcare so much, but please do understand that healthcare has been one of these domains which is extremely important for the humankind, but at the same time, this is a domain that is willing to go beyond anything to explore the power of machine learning, because there's a million things like DNA sequencing and whatnot that takes a ton of time, a ton of efforts, almost inhuman, and that to your machine learning algorithm will be a piece of cake, because at the end of the day, it can constantly do a task maybe 100 times, million times faster than what we could do, without getting bogged down, without getting bored, without getting tired, right? So that is what gives power to ML as a whole, and that is what it gives the biggest advantage to us as users. And then look at financial risk analytics. I bet that your banks are using this at the moment, right? So how does your bank know the amount of loan that it should give to someone, right? Of course, there are these scores, CIBIL scores and all of that will tell you how good your credit score is and everything. But at the end of the day, it's a certain risk that is associated with the bank giving out a loan, because they only give you a loan if they're sure that you're going to pay it back, right? They don't want to lose money. But sometimes it so happens that there are defaulters, people who could not pay back. So they're going to use all those situations to learn and understand why people default loans, or why people are not able to pay loans. So they use that learning. To understand if they should provide a loan to someone, if they should provide an X amount of loan to someone having a Y amount of salary, right? So it's popularly used, it's being used as we speak right now. And price predictions are absolutely fantastic, be it in the stock market or be it in the vegetable market, because whenever someone tries to predict something that will happen, they're going to require a lot of data from the past and a lot of current data to see, analyze. And prediction is basically you trying to see if any pattern will repeat, you trying to understand if there's any new trends that might be created, or you understanding if there are other outcomes which will affect your current situations, right? Now, again, we might see the increase in petrol prices as maybe a spark for the electric vehicle revolution around India, especially right now, right? So maybe one of that is leading to something else, and you want to analyze what is causing what happens if something else happens. All of that is easily possible with the use of Scikit Learn, with the use of all of these. The applications are endless, right? Again, I have more for you. Think on the lines of weather prediction. Now, this is a very, very fascinating topic wherein you'll be surprised you have machine learning that is so well integrated into your life that you don't know it's there. Open up your mobile phones right now. I'm sure you might have it in your hand anyway. So open it up, be it on whatever phone you have. Say, hey Google, hey Siri, hey Alexa, hey to whichever voice assistant out there, which is first of all working on the basis of machine learning. Open it up and just ask the chatbot about what the weather is like tomorrow. Just say, hey Google, what is the weather like tomorrow morning? It will tell you what the weather is like tomorrow morning, and I am confident that it's going to be very, very, very accurate, right? It's not like it's randomly trying to guess tomorrow's weather. It's not saying, hey, tomorrow it'll rain. No, it's giving you a probability, a percentage. All those are data-driven answers that it is giving you, right? And then another really nice application of Scikit Learn, which I absolutely am a huge fan of, is in emergency services. Now, think about what causes floods, right? An underwater earthquake in the middle of an ocean is where two tectonic plates move and it brings in a lot of water rapidly inside and it pushes all of that out. So when it pushes a ton of water out, you know what happens, right? After an earthquake, it's usually a flood, and that's the entire process of it basically. But what you should know is that it will only take a couple of seconds or a maximum a couple of minutes for a huge flood or a huge wave. Probably the wave is like 10 stories tall, 10 buildings tall. It'll take a couple of minutes to reach from the center of the ocean all the way to the coast or something like that, right? So in those emergency services, we cannot rely on human speed. Of course, we are great at a lot of things, but when it comes to certain things like this, if you have a computer there, it's great. Machine learning algorithms is constantly analyzing and assessing what the seismic activity is like. As soon as it sees a huge earthquake or anything that is alarming, it will automatically go on to do a lot of tasks it's supposed to do. Maybe it'll start raising some gates to ensure that flood water doesn't come in. It starts sounding alarms everywhere around the coast to make sure that people are moving away to safety and all of that, right? It will automatically do it the second it realizes there is a threat. There is no way that it can be done manually that fast, right? Someone is reading a seismograph, they see that something is wrong, they say, oh, okay, this is wrong, now let me call someone else, and that call goes to like 10 other people before starting the alarms. Every second here is a matter of life and death, and when that happens, machine learning will come to your rescue like a million times faster than a human. Maximum respect to all the emergency services personnel out there, because without them, none of this is possible. But just the fact that you can use machine learning as a helper there to make it even fast, I am a huge fan of that, right? And then think about text classification, audio processing, and all of that. You'll be surprised by the amount of feedback you can get just from the reviews of products. If you go to Amazon or any other place where you've seen a lot of reviews about people talking about a product, the owners can actually sit and analyze it in depth. They can get their machine learning algorithm to figure out the sentiment of your customers. Are they happy with your product? Are they sad about your product? Are they angry about your product? Or are they just neutral? Are they just saying that, it's a boring product, right? You can figure each and everything out, and you don't have to sit and read through a 1 lakh, 2 lakh, couple of million reviews to figure that out. Your machine learning algorithm will do it in a couple of seconds to tell you what is going on. That is the magic of machine learning, right? And then, of course, predictive models, as I just told you, be it weather predictions or be it trying to use some sort of regression, trying to analyze, having current data about how that data will forecast something into the future. I don't think not a lot of other domains give you this capability to predict the future, right? Think about cloud computing, think about DevOps, think about all the other beautiful domains that are out there. I rarely find a domain that will give you the capability to predict what happens in the future like how machine learning does, right? That is the magic, that is the essence of machine learning. Well guys, now that we have understood all the applications of Scikit Learn, I think it's high time we take a look at the advantages and some disadvantages of Scikit Learn. Now, ladies and gentlemen, as I just told you, right, there are a lot of advantages and there is a small amount of disadvantages which you're supposed to know. So first, let's get away with the advantages, since we are, of course, building a lot of hype in terms of how powerful Scikit Learn is. The first advantage, in my opinion, is that this library is extremely versatile in helping you solve multiple challenges, problems, not just in the technical domain, not just in the IT world, but be it any other non-technical domain out there. If you're creative and intelligent enough, you will find a way of how machine learning can be used to maybe better an already existing process. Again, I don't see a lot of other domains which are doing that. I don't have anything against the other domains, but this is a fantastic advantage which has to be like a heading when you're discussing advantages, right? And then, as I told you, Scikit-Learn is a library which is backed by an extremely talented community. A lot of talented and hardworking people and open source contributors are making sure that we can work with the library at ease. So it's a huge advantage for us because they put in their own efforts to simplify something really complex for us. And I think that is an advantage because it's these extremely talented and hardworking contributors that is making the library so amazing for us, right? So again, a lot of contribution from their side, and of course a lot of heartfelt thanks from my side and your side definitely to these guys, right? And then now I told you, I've been telling you one thing for a while right now. I'm telling you it can already better an existing process. Like it will fit into machine learning will fit into any domain out there. You must be asking a question when I said anything and all of that, because at the end of the day, you might say, hey, if there's something which is already existing and working and you suddenly bring machine learning, don't you think it becomes extremely difficult to make your machine learning model work with an already set up and beautifully working infrastructure? Well, with respect to Scikit Learn, it provides a lot of elaborate API documentation to ensure that you get machine learning to talk really quick to your already existing solution out there, right? So it is not like I have a product, I want to throw that product out and start from the scratch because I cannot use ML with it. There are cases where that might happen, but at the end of the day, in the majority of the cases, you have to understand that many already existing platforms can integrate machine learning into it with ease due to the availability, due to the possibility of these API documentations that are available and made available to us by this beautiful community there, right? So, of course, I had to stop myself with the number of advantages there because I can go on and on and on and tell you about more and more advantages. Let's quickly talk about the disadvantages for a second. Now, in terms of disadvantages, ladies and gentlemen, there are one or two disadvantages, unfortunately. Let's just get into the discussion of them. The first point is Scikit-Learn ML models don't scale very well linearly. See, learning is usually a linear process when it comes to, right? You build up generally and you go on and you go on and you go on and work with that. But small machine learning algorithms are very easily built and worked with Scikit-Learn. But as and when the complexity of your solution goes large, that's where they really don't scale well linearly. You might think that you might require X amount of effort for a small problem, 3x the amount of effort for a large problem. But at the end of the day, it might have come to a fact that it would have probably taken you 10x of the effort to actually get it to be extremely well optimized and extremely working really well. That is not a disadvantage to a majority of the audience, or definitely for you guys as learners, because you'll not be getting into that extreme depths of having a production ready application built right away. But yeah, this is something you have to think about in the long term as well. It's not a bad thing, but it's a small step in the way that will probably get to you at a later stage. The second point is tedious hyperparameter tuning and optimization. As I just told you, it's never a situation where you start writing a machine learning algorithm and boom, you are done with it and you close it. No, the first time your machine learning model gives you a successful output, you're going to be the happiest guy, and you're going to be this person. If you're like me, you're going to be wondering, how can I make it better? How can I make it faster? How can I get its accuracy to be even better? So you will be wondering about what are the different things that you can do to get your algorithm to learn better. In fact, I'm going to be showing you hyperparameter tuning in the demo that we're about to discuss as well. I'll show you practically about how you can find out if your machine learning models can work better and eventually get it to work better, right? And of course, the last point says it needs better model performance reporting capabilities. Yes, I definitely agree with this because I've been using Scikit-Learn for a lot of years right now. And at the end of the day, after you've created your model, after you have had your output at hand, the way that you would report your output, right? There's a lot of things. There's something called classification report. There's an accuracy score. There's a couple of measures of accuracy where you have a matrix that will give you a lot of answers. A lot of ways are there, but is it the best that can be done? I'll say no to that, definitely. I think the community is also working towards that. At the end of the day, we want better ways to denote that our model performance is better. We want better ways to track how the model performance, why the model is behaving the way it does, and we want to do it intuitively, we want to do it easily, and at the end when we're reporting it, we want to make sure that it's not just us doing all the tedious manual tasks, but wherever possible, Scikit-Learn can help us do it better, right? That is at the end of the day the goal of Scikit-Learn, the goal of machine learning here as well. That's what we're after, right? Fantastic, guys. So these are some of the advantages and important disadvantages you definitely need to know about. And with that, I think we can come to the next section, which you guys are really excited for, I can already tell. So guys, coming to the next section, practical demonstration in Python. Now we had a chance to take a look at so many things over the last 45 minutes in terms of theory, right? What does Scikit-Learn? A bit about machine learning. What does Scikit-Learn help us? How is it helping us in terms of machine learning? Why is it so popular? How old is it? What about the community? Is it free? Is it paid? How does it work? What are its popular applications? What are its advantages and disadvantages? We had a chance to take in a ton of valuable information theoretically, but I think it's high time we take a look at understanding maybe one algorithm practically, right? So as I already told you, I didn't want to keep you guys like completely, in the dark and mysterious until the end. So I told you we're going to be using KNN algorithm. So KNN basically stands for K nearest neighbor algorithm. It's a beautiful algorithm. I am absolutely a huge fan of it and it works really well. First, let me take up one or two examples to explain what the algorithm does, and later let me take you to code to showcase how it works, right? To give you an example of nearest neighbor, basically you understand, if let's just say you are a data point in the algorithm right now, you understand what you would do based on your nearest neighbors, right? As in when I start explaining, it's going to make a lot of sense, but you're basically giving data certain meaning based on everything that is around that. Now, if you know clustering, if you know association, this is where, of course, it's a supervised learning algorithm, but those concepts are very similar to how this algorithm works. Now, I'll give you an example. Maybe let's just say you want to walk to your nearest ice cream store. The ice cream store, let's just say I can see it from my apartment. Maybe it's just 100 meters away. Now, there are a lot of ways I can reach that ice cream shop, right? Some meaningful ways, some meaningless ways. You might laugh at this, but this is a possibility and a probability. First way is I just get down, I walk directly to the ice cream shop, I buy a beautiful ice cream, I come home, done deal. The second way, the way that you will never do is probably you booking a flight to Delhi from Bangalore, going all the way to Delhi, not doing anything there, flying back from Delhi, going directly to the ice cream store, buying ice cream, coming back to your home. Yeah, I know you're surprised, but that is a possibility as well, right? So you can use one of these two concepts as an explanation to say there are probabilities you have to explore before giving your data some meaning, and that can never be better told than in the KNN algorithm that we are going to be discussing, right? So let's just talk about a very simple classification example in KNN. What I want to do is I want to have a certain data set at hand. I want to have the height and weight of a lot of people, male and female population in our hypothetical data set. And I want to try to predict if based on the height and just the height and the weight. So as I just told you, right, we're just trying to predict the height and the weight of a person regardless of their gender at the moment. And here is the data that we have at hand. Now look at this. Right now I know the male and the female population because I want to just plot it on a chart to show you guys. Here's all the height details. Here's all the weight details of a certain population, right? Let's just consider that all of this is hypothetical at the moment, but you can see a certain pattern when you actually plot it on a graph. Now what I have done is, as you can see, I have 7 details, right? Now this is details of 7 different individuals. Now out of those 7 people, 4 of them are male, 3 of them are female, correct? We know that. But if I plot it on a graph, as you can see, there is a common pattern that's appearing here. You can probably see that the females maybe have slightly lesser height and maybe they weigh slightly less than the male population of data. And you can see all of these pink triangles are females, and you can see all of these green circles or green spheres. These are the male population. Now we have 7 people's worth of data, and what I'm going to do is I'm going to add one more person. Now this person, all I know is that their height is 190, their weight is 100 kilos. That is it. I have no idea if this person is male or if this person is female. So let me plot it on the graph. Now as you can see, this new blue color square, this cute blue color square that I have here is this new population, right? This is the new data that I just plotted there. Now, even if you do not perform machine learning, even if you are not extremely well versed with machine learning, as soon as you look at that blue dot, in which area that it is placed, looking at its nearest neighbors, do you think that that person is a male or that person is a female? I bet at this moment that you guys are saying that's a male. How did you know that that's a male? I've just given you height and weight. What you would have probably done is you would have looked at all the points around that to say, hey, so this person weighs almost similar to weighs and has the same height as the other guys. Good chance the person is a guy. Exactly. This is how your machine learning algorithm is going to learn in KNN as well. Now, what I'm going to do is to give it some sort of meaning while learning. I'm going to say, hey, if you want to understand if you're a male or a female, just look at 3 or 4 people around you to figure out who they are. Now, if I say KNN, K is basically a value there from 1 to infinity. And now I'm going to tell, hey, take a look at the 3 nearest neighbors there. When I say k equal to 3, I'm telling my algorithm, take a look at 3 nearest neighbors around you to see if they're male or female. And based on that, you can learn if you're male or female. And it looks at 3 people around it. It says, hey, everyone here is a male. Good chance even I am a male as well. Now you might say, hey, why did you take k equal to 3? Now take k equal to 5. Even if I take k equal to 5, you can realize that 4 of its nearest neighbors are male people, and 1 of its nearest entity is a female. Now you might say, oh, now all are not male, 1 female is also there. What are you going to do? What you're going to do basically is to figure out the majority is what again? Majority of your nearest neighbors are who? Male or female? You have your answer there, right? Now, why we go on to pick up k values to be odd, 3, 5, 7 and all of that is because it works really, really well when we have two classes that we are actually comparing. In this case, two classes, all we have is male, female for our hypothetical example. That is it. We're not considering anything else, right? So for that situation, k odd values work really well. You'll see that they do work well when we go on to actually take a look at practical discussion here, right? Now, I told you about the Boston housing dataset comes built in. Now, I have the dataset at hand, so I can manually go on to import it and start working with it as well. So what we are going to be doing with this dataset is we're going to be using the KNN algorithm to see if it can predict the price of the house in the area somewhere around in Boston, right? That's the dataset we have in hand. So all we are trying to say is get the machine learning algorithm to figure out why your house can be expensive. Now, you know a lot of reasons why your house might be expensive. It depends on the age of the house. It depends on how many people can stay in the house, how many cars you can park in the house, what locality is your house a part of, how far away is your house from the airport, how far away is it from the school, what is the crime rate in your neighborhood, right? Because even if it is the most posh house, if you're building a castle, if it's in a neighborhood which is very shady and very bad, it's not going to be worth a lot of money, right? So what is it that gives the meaning? What is it that has the most oomph, most emphasis when it comes to predicting the price of a house is exactly what we're going to be using KNN to work with this, right? Now, ladies and gentlemen, I'm going to be using Google Colab to showcase the code to you guys. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. You can work with this code in any IDE that you want to use. If you're working with PyCharm, you can work with it. If you're using a regular Jupyter notebook, you can work with it. If you're using Colab like me, I love Colab for multiple reasons. You can use that as well, right? So let's quickly go back to Colab and let's get started with the practical discussion. Alright guys, so as you can see, I have Google Colab open. We're going to be understanding Scikit Learn using a small KNN algorithm demonstration. Now, my goal with this demonstration for you guys is not to show how to write Python code and how to ensure that you get to the result, but my goal is to tell you guys and showcase to you guys that it is really, really, really simple and very powerful to use a machine learning algorithm like KNN and get your solution done using the algorithm, right? So let us actually zoom in so all of you all can see the code. The first piece of code, while working on any sort of solution, my way and the most common way is to basically import all the libraries that you're going to be using. As I told you, NumPy and Pandas we're going to be requiring because as you can see right here, right, this line is talking about us importing our entire housing data set. This uses Pandas and we have multiple use for NumPy, Pandas and all of that, and this is the library we are after. Now, if you're wondering why it does not return Scikit Learn, well, sklearn, whenever you see it in Python code, understand it's the same as Scikit Learn. Now, in fact, as soon as I run this demo, it's going to give me a small error. It's going to say, hey, I have no clue where your data set is. You're asking me to execute a data set that I don't know where it is. Now, that is because it's sitting in the Google Cloud platform and the data set is in my laptop. Now, what I have to do is I have to import it into my working environment. I run this piece of code again and boom, it works like magic, right? Now it knows where the data set is. Look at that. So what are we trying to look at it here? Now, every single column here is basically, it's basically a data point associated with respect to house. Every row is a house worth of data. You can see the crime rate in the area where this house is. You can see the age of the house, the amount of tax that has to be paid. You can see like so many different things about a house that will eventually give it a lot of meaning. These are the reasons why a house might cost so much. You and me know this. Our machine learning model might not. So the first step, one thing you have to really be careful about when you're working with machine learning is your data has to be pre-processed really, really well. If you provide bad data, if you provide incorrect data to your machine learning algorithm, it will learn things incorrectly and it will not know what is right or wrong. Now, if I show you a cat and if I tell you guys this is not a cat, this is a dog and it says meow. Have you ever seen a dog which goes meow? Not really. You'll be like, hey, what the hell? But if I show that to my machine learning algorithm, while it is learning and say, hey, this is a cat, if I show you a dog and says it goes meow, machine learning algorithm will not know a difference. It's going to be like, oh, okay, so this is what a cat does, let me learn this. Or this is what a dog does, let me learn this. You know that a cat cannot go bow bow, or you know that a dog cannot go meow, right? So that's the thing, you have to provide high quality and good quantity of data. And in this step that you can see one line of code, all I'm trying to figure out if there are any NaN values. NaN stands for not a number. Now, for example, when this data set was created, when people were writing the age of the house, it is a number, right? You can see all of these are numbers. None of this is textual data. Someone might have entered a textual data by mistake. Instead of the age of the house, they might have written their name or or the name of the house. That is incorrect, and your machine learning algorithm will flip when it's learning at that point, because it doesn't know why it's different, and your accuracy can fail really, really bad. So with this, we try to figure out if there are any such weird values which are not used, which in fact hurt the algorithm, and we have to remove it. Thankfully, my data set is already clean, so we don't have to do all of that. And we come to the next step, which is really, really important, because here is where we take the entire data set. Now, I showed you first 5 rows. We have hundreds of thousands of rows there. We take that entire data set, we split it into 2 pieces. One piece consists of 70% of data. Now, this is the data that my machine learning algorithm is going to use to learn. Similar to like a textbook in your college. Now, you're going to use that textbook to learn, and later you're going to see new questions or some similar questions asked in the examinations, right? So I'm going to hold 30% of the data away from it. It's never going to see it until the end after it learns. That is when I say, hey, now that you've learned something, let me give you a little examination. Let me give you a little test to see what you've figured out. So on an average, we usually send somewhere around anything above 50%, 50, 60, 70, 80, 90% of data for training. The rest is going to be for testing, right? So all we're doing right now is we are just basically splitting the data into 2 pieces. Now, I said 70% for training. How do you know that? Well, I have a attribute here which says test size equal to 0.3. Well, what I'm saying is take the entire data set, cut 30% out of it, keep it for testing, everything else, which is 70%, goes for training, right? And this is where the magic starts happening. You can see that we're using Scikit Learn. We're importing the algorithm that we want to use, and basically we are loading that we want to. I'm saying to Python right now, saying, hey, I want to work with KNN, and I want a value of K to be 3. Right? This is what you see in the bracket. Wherever it says 3 here, it basically means that you're using K equal to 3 to work with this machine learning algorithm. I hit play, it executes it, and right now we are telling the Python model that, hey, we are using this algorithm. The next part is model fitting. Model fitting, for all of you all who are new to machine learning, here is where all the magic happens, and this is where you might have a really bright smile on your face right now, is me telling you that, hey guys, this is the step where your machine learning algorithm finishes learning one line of code, one simple line of code, and as soon as I run this, it basically told me that it has used a couple of metrics to go on to learn. Don't worry if you know what any of these means, it's okay at this moment of time. But as soon as I ran that piece of code, my machine learning model has now learned everything it has to know about that data set. Well, great, it has learned something, but I want to figure out what it has learned. So I'm going to pass it the testing data right now instead of the training data. If I provide training data again, it's going to give me 100% result. Think of it like you being in your examination hall, and I come in and say, here's a textbook, write your examination. You don't have to learn anything. You can copy paste, right? To avoid that, here is a genuine examination that I give. The process is called model prediction. And as soon as I run that, now basically the model has also proved its worth to me. But how will I know that the K equal to 3 value that I used here, that is the best value that I can use for the machine learning algorithm? How will I know that there is nothing better than that? This is where hyperparameter comes into the picture. Now, what I am going to be doing is basically I'm going to take the K value from 1 to 50, and I'm going to train the machine learning algorithm 50 different times, and to see where the error rate is the lowest. Wherever the error rate is the lowest, it means that there the model is working really, really well. Now, as soon as I hit play there, look at this. This is all the error rate that's obtained for various values from K1 to K value to be 49. Now, you can see that it's already put out in a sort of a numerical alphabetical order here, ascending order, not exactly, but you can take a look at this. K equal to 1, there's a very high error of 7.97, 7.1. The lowest that I can see right now is 7.004. This is the lowest error rate, and this is, we are obtaining this error rate when K equal to 4. Well, initially what we did, we thought that K equal to 3 will be the best accuracy for our machine learning algorithm. Now, when we are tweaking and tuning the algorithm, you can see that no, at K equal to 4, you have even better accuracy. This is how you perform this process called hyperparameter tuning. Now, all of this is happening again. Think about it. 1, 2, 3 lines of code. That's it, right? Well, what is the last step then? The last step is for us to tell you guys what is the accuracy of your machine learning model, or even the error rate. And as you can see, the error rate when K equal to 3, this was because we use K equal to 3 for training, you can already see that this is the error rate for the machine learning algorithm, right? So let me actually go on to remove all the outputs. I'll clear the outputs. I'm going to zoom out. You might not be able to see any code right now because it's going to become very tiny, but look at this. Here's where we started our demo, and we've done this in what? Everything is done maybe in 20-25 lines. 25 lines right from us importing libraries all the way to us actually finding out the error, getting the machine learning algorithm to learn, predict, give us an output that we can use. Did this look like we used thousands of lines? Absolutely not. Did it look like we used hundreds of lines? Absolutely not. We used 20-25 lines. Yes, this is a very basic demonstration, but at the end of the day, even when you try to implement really complex situations, your Python code is still going to remain same. It's really going to be simple. The way you would implement it would change. That's it, right? So this simplicity that is Scikit Learn, everything, all these individual lines that I just showed you, all of these are part of Scikit Learn. Without these, probably for model fitting, if you have to manually do it, maybe you have to write another 100 lines of code just here in that one slot that I've highlighted. Now you replace 100 by 1. This, ladies and gentlemen, as you can see in the demo, is the power of Scikit Learn. And I'm sure as soon as we complete this demo, as soon as you're done with the demo, you would have figured out on your own that this is a very, very powerful algorithm and a very powerful library, in fact, in Python, right? So coming to understanding SciPy as a library itself, right? One thing that I should tell you at this moment right now is the fact that SciPy is an extremely popular library in Python. There's thousands and thousands of users. And, when you say it's a library that is really popular, definitely you have to give reasons of why it is popular, right? Now, the entire scientific community, they required a library through which, you can perform certain tasks which you had to do manually otherwise, right? Think about working with algorithms. Think about already having functions which definitely will do the task for you, right? So sometimes what is a function, right? When you think about a function, it's basically having an equation, solving a lot of things, and eventually getting a result after you provide a certain input. That entire process from input to output will be automated if you have readily built functions that can take up the task, right? So that is possible here as well. And when you think about working with the interactive Python sessions that are out there, right? So what SciPy does, the biggest advantage is that it provides us with high-level commands and classes which we can use to not only just visualize data, but also manipulate it and work with it in real time. Now I'm going to be showing you all the demonstrations, practical demonstrations through which you can see for yourself that, hey, yes, SciPy is a library which is very powerful, and it definitely sees its fit in multiple domains out there, right? So whenever the world talks about scientific computing, whenever the world talks about technical computing where there is a requirement of Python, you can be rest assured that SciPy will be the library that's going to be popular there. Now, after you've understood this about SciPy, here's a very interesting fact you may or may not know about the library. SciPy is basically built, on top of NumPy, and therefore, whenever you have a situation where you have to use SciPy and NumPy as well, right? If you just import SciPy, you're good enough. You can work with all the functionality that NumPy brings to the table, right? In the data visualization scene, if you know that Seaborn is built on top of Matplotlib, right? Similarly, here SciPy is built on top of NumPy, so it brings all the functionality of NumPy and then some, and that definitely is making it's adding more efficiency into the pipeline, and at the end of the day, it's simplifying not just the way you work with Python code, but the syntax through which you write, right? That is becoming more simple as well. So guys, with that introduction to SciPy, let us quickly come to a section where we can discuss how you can go about installing SciPy. Now, there are many ways about installing SciPy, and the biggest advantage is that just like Python, SciPy is supported across multiple operating systems that we have today. And of course, you can have a list of operating systems, but I'm going to be picking up the top 3 operating systems that we have today. One is Microsoft Windows. We have all the Linux flavors and distributions, and then we have Apple's Macintosh, right? Mac operating system. So, if you're using either one of these, I'm sure, you guys viewing this, you'll be using all 3 of these, or, you have definitely used either 3 of these, right? So it's going to be a real simple process to install it. We're going to be dividing the installation into 2 steps. One place, where we'll be discussing for Windows and Linux, and the other one is slightly separate because, Mac and Apple has their own architecture to play with, right? So coming to Windows and Linux. Now, one very good thing about Windows and Linux, and of course, whenever you're working with the Python command line here, is that you have this ability, you have something called pip. Pip basically stands for package installer, right? Pip, in fact, it's a recursive acronym which stands for pip installs packages, PIP. Pip installs packages. So it is basically a package installer, a package manager, which will help us install all of these libraries at ease, right? The advantage that pip brings to the table is that it's a standard package manager, as in it can be installed very easily on Windows, on Linux, and more, right? So to basically, to install SciPy using pip, all you have to do is run one simple command that you can see on your screen right now. Look at the last line, which is in bold. It says pip installs SciPy. It's literally these three words, and with these you can definitely clear up. And I'm sure if you've if you're watching this course, you might have had some experience with pip and installing packages. So again, it's a very, very simple and a very straightforward process of how you can install it on Windows and Linux. But there isn't, there's more advantages to Windows and Linux. The fact that we have Anaconda distribution, right? Anaconda is an absolutely fantastic distribution, which will not just give you everything you require in Python, but it will also give you other libraries, other helpers, other tools, other frameworks, and it brings a lot to the picture through which you can start, creating applications. And eventually with Anaconda, right? When you start working with Anaconda's distribution, it's a fact where it'll already come built with multiple libraries that you don't have to work with. Now, installing SciPy in Anaconda is very, very simple. All you have to do is go to Anaconda's website. You have to download something called as the Anaconda Navigator, and once you open it, start installing. You will have something called as the Anaconda prompt. Anaconda prompt is very similar to the command prompt or the Python GUI that you would have seen. Again, once you do all these steps, it's a very simple step of running one single command, conda install Anaconda SciPy. And that is it. As soon as you run this conda command or either the pip command, regardless of both ways, you will have SciPy installed and set up on your Windows. And it is the exact same steps that you'll be following for Linux as well. Now, if you're wondering, yes, Anaconda is available for both. It's available for all these Mac users. It's available for Linux. It's available for Windows and a lot of other operating systems as well. So again, you have one more way of doing something which is already simple, right? That, it's fun when you think about how simplified the process of setting everything up is these days, right? So, Windows and Linux aside, let's talk about Mac OS for a second. I'm sure you viewers are, probably watching this on your Mac right now. So, the slight disadvantage with Mac is that it doesn't come pre-installed with any package manager out there. So, what you can do to sort of work around the small disadvantage is that you can install your own package managers there, right? So you can see two commands. You can see a couple of commands on your screen right now. If you actually head to the terminal and run these commands, guess what? With just these one command, right, the sudo port install command, you can go about, installing 3 libraries, 4 libraries, SciPy, Matplotlib, Pandas, and the NumPy library as well, right? Again, it's not a step where you have to break your head. You have to do like 100 different things to install the library. You just have to open up the terminal. You just have to copy paste what you see and eventually hit paste, and you're done, right? How simple is that? And doing that will set everything up in SciPy that you will require, to follow along with all the demonstrations that we'll go about doing it, right? And one advantage with Mac, I wouldn't say advantage, it's a slight helper is for a fact that just like Windows and Linux, where we had multiple ways of installing, here also you have multiple ways of installing. You can use Homebrew to install all these packages, right? But one thing, again, a small disadvantage here by using Homebrew is that whenever you try to install SciPy through Homebrew, it'll not bring the entire library, right? Now, SciPy is a huge library, as you're going to see through the rest of the course. Of course, we're not going to be covering every single thing in detail, but we are going to be covering all the really important stuff that you guys have to know. And to get to that point, if you're using Mac, again, we have one command, brew install NumPy, SciPy, IPython, Jupyter, right? Now, this will install a lot of things. It's going to install NumPy, which is the library. It's going to install SciPy, again, which is the library under discussion. IPython stands for interactive Python, and we have Jupyter, basically a Jupyter notebook server client architecture there, right? So all of this is installed to you, again, using one command, and you really don't have to put a lot of effort in setting it up. right? Now that we have some clarity on knowing what SciPy is, knowing where it is used, what it can do, and a bit of how we can go about installing it as well, and hoping that all of you all have SciPy installed at this moment, we can jump right into the next section where we'll be discussing all of these sub packages in SciPy, which is literally at the heart of the concept, right? Without knowing these, there is no understanding SciPy at all. So talking about the sub-packages in SciPy, one advantage is that SciPy supports multiple sub-packages that are out there. Now, there are many dedicated software tools which become necessary whenever you're working with scientific computing, right? Just the term scientific computing seems very complex to think about it, but when you have to implement it in Python, of course, you cannot just have one library, you cannot just have one single entity, tool, or technique that will always work for all the solutions. It doesn't happen, right? So what SciPy does is it is considered as a very important tool. It is considered as a library which is not only just providing one single aspect of it. It's not saying, hey, just use statistics, just use image processing, just use this, right? It's offering multiple Python modules that you can use, and you can use all of these at once if you choose to tackle everything that's required to perform scientific computing or any sort of technical analysis that's required as well. This is a very popular tool to be used, right? Now, look at your screen. You have multiple sub-packages out there. Of course, we're going to be discussing a couple of these in a small bit of detail, but you have to understand that each of these are used in their own specific purposes, right? Now, you have clustering algorithms. Clustering is a very important part of machine learning, right? You've used clustering again. Just think of a simple example where you're given a couple of fruits and people say, hey, can you put all the oranges on the left side? Can you put all the apples on the right side? Can you keep all the bananas at a different place? You can do that, right? If you can do that, you basically know what clustering can be. There's various types of clustering. There's hierarchical clustering, divisive clustering, agglomerative clustering. There's a lot of types of clustering, but what you should know is that SciPy is going to be giving you a lot of functions and a lot of easier ways to go about doing everything that I said, right? And since we're talking about scientific computing, of course, there's going to be a good amount of physics involved as well. So wherever people are using Python for physics solutions, guess what? SciPy is also providing certain mathematical constants that you can use, right? Now, we all know the most famous constant out there, pi, right? Pi is 3.1418. So on and so on. Now there's there's a lot of constants if you think about it. There's Boltzmann constant. There's a lot of numbers out there. All of these complex stuff. There's Chandrasekhar limit. There's many concepts. And if you are a astrophysics geek like me, you will definitely be familiar with how complex things can get there, right? So SciPy is providing a way of handling all of that easily. And FFT pack, if you're wondering what FFT stands for, basically it stands for Fourier transforms, right? Fourier transforms are a very important part of handling and working with differential equations. And if you've ever used that, or if you're trying to solve differential equations using Fourier transforms, and you want to apply all of these transforms, Fourier transform, inverse Fourier transforms, and all of that, you have helpers out here that will help you do it easily, right? And Fourier transform is a part of mathematics, but another very important part of mathematics that you might have studied in school or college is integration, right? So for all your integration requirement, there is again another sub-package called SciPy.integrate. And if that wasn't enough, guess what? Look at it, right? We have more. We have one thing to perform interpolation. We have another library, linalg. Again, as I just told you, right? Linalg stands for linear algebra. So for all your linear algebra routines, you have a sub-package ready to go. If you have a requirement where you have to work with a lot of data input and a constant source of data filtering and data outputs, you have SciPy.io as well, right? IO talks all about how you can handle data inputs and outputs. And then you have ND image. ND image basically stands for n-dimensional image, right? So it's, you can work with images in 1 dimension, you can work with images in 2 dimensions, 3 dimensions, and all of that. So whenever you are working with multiple images, I'm going to be showing you all of these practically, but for now, to quickly give you a picture about what it is that you can expect going ahead, right? We're going to be discussing a couple of these libraries. Let's pick up 5 or 6 of these, which are super important for you to know in SciPy, and eventually we can get started with that, right? And if that wasn't enough, there is more. There are more sub packages, right? There's ODR, which basically stands for orthogonal distance regression. You have direct optimization helpers, and look at SciPy.signal, right? I told you it plays a very important role in signal processing. We have a sub package that does just that. We have sparse. Whenever if you have worked in detail with applied mathematics, there's a very good chance you might know what a sparse matrix is, right? So handling all of the operations that it brings can be done easily as well. And whenever you're working with data structures and algorithms, we have a library for that. Any sort of other special functions that you can think, we have libraries for that as well. And stats, of course, talks about statistics. Weaves talk about how well you can perform certain writing tasks by making use of these sub packages as well, right? So let me just quickly go back here, and you can see that each of these sub package can work as a standalone sub package, work in dependency with all the others. So depending on, you might be asking right now saying, so how will I know what sub package I should pick up for my applications? Well, what it is that you're doing in your application will directly influence what sub package you might be using. If you're working with signal processing, it is clear as day that you're going to be using this. If you're working with statistics, you have a package for that. If you're working with image processing and you want to use a bit of SciPy there, again, you know which sub package to go about now, right? So I hope this quick introduction to tell you that these are the sub packages which give power to the library are clear to all of you all. So without further ado, I think it's high time we jump right into understanding each of these, not only just theoretically, but practically at the same time, right? So let's talk about SciPy cluster. Now, ladies and gentlemen, clustering becomes a very, very important part of SciPy, of Python, of all the practical applications we have in today's world. Clustering talks about how you can take one common data set or a heap of data and how you can divide it based on certain data points, based on similarities, based on dissimilarities to other groups as well, right? Now, think about the apple, the orange, and the banana example that I gave you. An apple as a fruit is fundamentally different to an orange. An orange is fundamentally different to a banana, right? So when you bring it all together, it's a jumbled pack. But when I say, hey, I want clusters of different fruits, that's when you know you get to pick all the similar characteristics, right? Now, when I say, hey, keep all the bananas aside, it can be raw bananas, it can be ripe bananas, everything. Now, I'm asking you to filter it and cluster it based on the type of fruit, not based on the type if the fruit is either raw or if it's ripe or anything like that. And if that were the case, guess what? You can have more clusters to go about doing this, right? So whenever you do these, whenever you take this entire basket of fruits or anything for that matter, put it out into separate entities, each of these separate entities that we have in discussion right now, as you already know, they are called as clusters, right? So working with clusters, handling clusters becomes very, very simple in SciPy. And at this moment, you might be asking a question saying, okay, so clusters is a very wide term of how you can go about using SciPy. Is there any further modularity that will help you understand? Well, yes, there are two types of clusters that are out there. We have central clusters and we have hierarchical clustering as well, right? Now, let me give you a small example to tell you what we're going to be doing. Now, we'll be talking about a demo where we'll be using NumPy to generate set of random points. What we are going to be using is, after creating two sets of random points, we're going to be joining all of these and eventually we whiten the data. What basically whitening the data means is that whenever you take a look at a lot of data points, right, it usually has a way of distributing itself. Think about normal distribution, think about other distributions, right? So each of these distributions bring its own characteristic, and that characteristic is what gives Python, is what gives library the understanding, the fundamental understanding about what is going on with the data, right? Now, you look at data, you understand it. I look at data, I understand, because we have trained as humans. Your machine isn't, right? So to get to a point where it can figure out certain patterns, we require whitening the data. Now, whitening, as I just told you, it takes like a lot of data, it groups it, crunches it into a certain workable range. And this workable range becomes very critical for us, be it in binary operations, be it in non-binary multiple categorical variable based solutions as well. Now, K-means clustering is a very popular way of how you can go about clustering. And what we'll do is we're going to take all the data that we just took together and we eventually brought it together. We whiten the data. Now what we'll do is we're going to be using the K-means functions and just pass all of the data to it and eventually give it the number of clusters that we want. And those many clusters will be created at the end of the day. So what are we doing? We generated a couple of random data. We eventually brought it together. We ran it through K-means clustering. And after that, we ran it through a function where, we can go about talking about how divisive and, to what level of modularity that you require with the SciPy clusters that we're talking about, right? So guys, it's not just theory. Everything that we're going to be discussing from now on is going to be practical as well. So let me quickly open up Google Colab. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform, right? So it's basically your regular Jupyter notebook, but it has many advantages and it works on the Google Cloud platform. So you don't require extremely powerful CPUs, GPUs or anything to work with efficiently as well. To a certain extent, to 95 or 90% of the users, to all the applications that they are going to be devising using Google Colab, it is free. But of course, there's pro plans and all of that. But for now, for everything that we're going to discuss, the free version of Colab, and it's majorly free, right? Only a small chunk of people who require high amount of processing RAM and storage, they prefer the paid version of Colab, but for the rest of us, this should be fine. So let me quickly open up Google Colab and we can discuss this exact, example that we have in consideration. Alright guys, so as you can see, I just quickly opened up Colab. Colab, you can just follow through the same URL, colab.research.google.com, or just go to Google and type Google Colab, COLAB, and it will bring you here, right? So as you can see, we're going to be discussing a lot of these sub packages practically as well. But to quickly talk about clusters that we have, right? Now we discussed what we're going to be doing already. And whenever you're working with any sort of solution, the first step that you have to do is import all the libraries that you're going to require, right? Importing SciPy, importing NumPy, Matplotlib, Seaborn, and all of these libraries which we require to work with. As I told you, we're going to be creating two clusters A and B filled with 50 random data points, right? 50 each. Overall, we'll have 100 points. 100 is being divided into two, and each of these is getting into one cluster A, and each of these is getting to one cluster B. And after that, we're going to be normalizing the data. Once we go about normalizing the data, now we have to understand, okay, so how can we go about creating clusters, right? So you have two very different data points which are random, but there has to be certain patterns and there has to be certain ways you can go about performing clustering using K-means, which will eventually create the clusters that we require, right? Now we're going to be using these two clusters to find data, find similarity, create clusters, and all we're doing is we're creating a plot to showcase to you guys how we can go about doing, right? Look at the logic, right? The logic basically is 1, 2, 3, 4, 5 lines. When you think about the entire thing, less than 10 lines is the heart of your logic, where you can create random data, create clusters, run it through K-means, eventually even provide a data visualization. Now, my goal here is not to walk you through each and every single line of code of what it means, because I'm sure if you are here at this moment of time, if you're looking forward to learning Python, you might know a bit about reading Python syntax and understanding Python's syntax, right? Now look at this. We had two very different data points, and here you can see that it has created two clusters for us, right? This is a graph that is showcasing what each of these points were mapped, and once the points got mapped, where were these clusters? So you can see these two red dots, which is basically plotting the center of these two clusters at hand. And again, 5-6 lines, and we can do a lot of these things, right? Now imagine you had to get to this result, but you had to do all of it manually. That would have been a pain, right? Because at the end of the day, you have to write a lot of code to not get a lot of output. But here it's the reverse. We are writing a small amount of code to have a very large output, right? So guys, this is SciPy clusters, a very simple demo to showcase to you guys about how you can go about working with that. Now, the next thing that we're going to be doing after understanding SciPy clusters is we're going to be taking a look at SciPy constant. As I told you, whenever there's a requirement of you working with multiple constants, mathematical constants, constants in physics and all that, at the end of the day, everything is a mathematical constant. But, these values which have a certain significance and they don't change, there, as I told you, there's hundreds of constants, and it becomes inhuman. It becomes impossible for someone to memorize what each of these constants are, right? They're very complex decimal numbers when you look at it, 3.141 8, or it just keeps going and going in many cases, right? So what is the way of how you can simplify this? One way of simplifying is you don't have to remember what the constant is. If you know what constant you require to be used in your application, in your solution, which of course you will know, it's as easy as importing it, finding its value, grabbing the value, using it for your applications. How simple is this? Right? So it's not just one or two constants that's actually provided in Python. There's various types of constants. SciPy.constant subpackage itself is a very, very popular subpackage. And whenever anyone is talking about the use in the case of general scientific purposes, this library, this subpackage is very popular there, right? So let's quickly take a look at how we can work with these constant variables, how we can import it, and how we can go about using it. But just before that, I want to also tell you that these are some of the constants that you can work with and you can take a look at as well. We know C, E is equal to mc square, Einstein's relativity. The C talks about the speed of light. You can have various physical constants that talk about it. G is basically the Newton constant for gravity. E talks about elementary charge, molar gas constants, Avogadro constant, Boltzmann constant, electron mass, neutron mass, Planck's constant. Look at this, right? It is absolutely a treat. If you're a person who's into physics, if you're a person who wants to use the world of computing, the world of IT to simplify something in an already complex world of physics, you have all of these constants right at the grab of your hands to go about working with them in an easy fashion, right? So let me quickly open up these cells here and we can go about working with it. Now, one constant that you would have seen in the world is something called as the golden ratio, right? The golden ratio is basically like a spiral which talks about having, it talks about almost everything in the universe having a certain pattern that you can trace and come about, right? It's called as the golden ratio. Now, the golden ratio is a very simple number actually. At the end of the day, it's 1.6 something. Yes. So it's 1.6180. And this is a number which again talks about, many cases where you're trying to, this number is very important. If you're trying to design a room for a home theater, for say, it has to be some specific dimensions. Whenever you go to a theater, it's not just randomly built. There's a very good chance someone, if it is designed properly to the utmost care, they would have used something called as the golden ratio there as well, right? So now I am a huge fan of theaters and all of that. So I just thought this is a good example to show you guys. Now for all you physics buffs out there who are saying, hey, show me a physics example, well, guess what? The Boltzmann constant that we just discussed, right? Look at this. It's just one line. And this command find is basically telling us what all it has, anything which has the name Boltzmann in it. And as you can see, right, you have Boltzmann constant and you have it in multiple SI units out here. SI unit is something that you would remember, right? Whenever we talk about temperature, it's degrees Celsius. Whenever you say EV, I think it's electron volts, and K stands for Kelvin. Hertz is a measure of frequency and all of that, right? So what it is basically saying is, hey, when I say, hey, tell me all the Boltzmann constant types that are out there. So the constant is going to be the same, but the value of the constant is going to change with respect to various SI units that you're going to be using, right? Various situations that it's going to be used. So it is telling me these are all the list of constants that you can use in terms of Boltzmann. I say, hey, okay, so now I know what constant I require it. I want it in Hertz per Kelvin. And as soon as I hit, play here, it's giving me the constant value that's out there right now. How simple do you think this is, right? At the end of the day, you don't have to break your head about remembering, a very complex number such as this. And that itself is a small advantage. And as you can see, with another advantage with Google Colab is all you have to do is move your mouse to the code and it will basically tell you how many physical constants that are out there. It'll tell you it's 444 physical constants that it has, right? Just like Boltzmann, you can pick up all the constants that I just showed you, speed of light and all of that, and you can have some fun with it. Right now, I want you guys to get your hands slightly dirty, and since it's just 2-3 lines of code, right? Overall, the entire thing is 3 lines of code. 1, 2, 3. That's it, right? Now, I want you guys to go about doing this for other constants that we just discussed. So quickly rewind back to the part of the video where I showed you the other constants. Try to figure out for yourself how you can go about doing it. It's very simple. You have to change 1 or 2 tiny things, and I am confident that all of you all watching this will get about how you can go about doing that, right? Fantastic. Next, let's quickly talk about Fourier transforms, right? Fourier transforms basically FFT pack, as we already told you. FFT. If you're wondering why we have two F's, the first F stands for fast Fourier transformation. So whenever you're working with these algorithms, whenever you're working with generic computing and specific scientific applications, you're going to be using multiple mathematical techniques to go about doing it. DFT is a mathematical technique where you take all these spatial data around you and you take the spatial data, convert it into frequency data. Now, I'm not going to be going into the depth of telling you, why they'll be doing this or how it is done in a detailed way, but a very simple example to show you how you can go about calculating the Fourier transformation is very simple. Now, let me quickly take you back to your school days or your college days where you might have read about these trigonomic functions, right? You have sine, cos, tan and all of that, right? So here what we'll be doing is we'll take a periodic function of sine. You know what a sine wave looks like, right? It's the AC power that you're getting at your home. It's a sine wave at the end of the day. So we're going to be using a simple periodic function and we'll see how we can use Fourier transform to transform that sine wave that we're going to be seeing into something else. Now, do not worry if you do not pick up on the nitty-gritty details out here. This is a very niche application of it, but at the end of the day, this is very important to know for you guys as learners, right? Now, let me quickly open up FFT pack here, and in FFT pack, we have one or two demos, right? Let me zoom out a little so we can see the entire demo at one point of time. As you can see, starting, it's all just us importing libraries. And then as I told you, right, we're going to be converting spatial data into frequency data. So you're going to have some frequency. And what is the unit for frequency? Hertz, right? The power in your house, the sine wave power that you get in your house is either 50 Hertz or 60 Hertz, depending on where you live. Right? And then the sampling rate. Sampling is again a fantastic part of, working with these analog and digital electronics if you have studied about it in college. And all we're trying to do is we're trying to take spatial data, convert it into simple frequency data, right? And look at this. This is what it might look like. Now, if you do not know what amplitude and all of that means, do not worry. Just look at the graph and understand that this is sort of something similar to what it would look like if you could see the power coming in through the wires to your house, right? It's a simple sine wave that all you're trying to do is, and we've just plotted the amplitude, we've just plotted the time out there, and it's simple, right? Now, the important part here is this is great. We have the sine wave, everything is good. Now, what we need to do, you have to understand is that we have to take this data. This is spatial data. We're talking about how the wave varies with respect to time and with respect to how much it moves and the power it gets. That's amplitude, right? So what we do here is we basically say, okay, so this is what you have as an input, a processed input. Now, what's going to happen if you do have to convert it into frequency data, right? Look at this. As soon as you say, hey, here is the magnitude in terms of all the spectrum that this is generating, and here is the frequency in hertz. Again, we just took this, we use FFT pack, and all you have to do is Fourier transforms is converted spatial data to frequency data, and it did it in what? The logic is basically 2 lines out here, and the logic here is basically again another 1 or 2 lines, right? See, 4 lines at the end of the day. Now you might say, hey, it's not 4 lines, we have 20 lines totally. But all the 20 lines out there, these are like boilerplate code, which again, once you start learning it and once you start doing it, your brain will not have to put any effort to understanding how that's gone about doing, right? So it's very simple. You take spatial data, you convert it into frequency. And if you're wondering about, why would someone do this? How is this done? What application in physics? You'll have to do a bit of reading on that yourself, right? Now, I'm a data science guy and I'm definitely not a physics guy, but I love astrophysics if you want to know. All right, cool. Now that we're done with FFT pack, let's quickly take a look at the next thing wherein we are going to be discussing a little bit about interpolation. Now, interpolation is one of these concepts which is again super popular because when you have 2 values, right? Whenever you have 2 known values, let's just say 0 and let's just say 10. When you have 2 values, there are a lot of other values, right? There's infinite values between 0 and 10. But what if you had to estimate unknown values that are present in this range itself? That is where interpolation comes into the picture. And again, as always, since we're discussing it in SciPy, there is a sub-package that will help you do this easily. So you can perform one-dimensional or any sort of univariate interpolation. Univariate basically talks about one variable, right? So one variable interpolation is possible, and even multivariate interpolation is possible, as in you can use 2 or more variables to perform interpolation. Now, when you say multivariate interpolation, it basically is also called a spatial interpolation. It is one of a kind where, you can run functions, and in these functions, you will have multiple unknowns, multiple known variables through which you can process all of them easily, right? So let's quickly head over to Python again, and let's take a look at how we can go about understanding interpolation in a very simple manner. Now, what we're doing here, as you can already see, is let me actually print it out so you have a better idea about what we're doing. We are creating a couple of plots here, and all of these are like functions, right? You can see that we've used the cosine function here. We've run this entire thing becomes a function when you take a look at it, right? A mathematical function to be very precise. And as you can see, we have certain data that we have just plotted it out, right? Now, if these two lines weren't there, the data would still have been there, but it would have not been plotted. The convenience of data visualization is all you have to do is like plot it out, and here's a scatter plot that will give you all the details that you're going to need. Now, one thing that you have to do is wherever we have a situation where we have to create a function based on certain fixed data points. Think about the example that I just told you, 0 to 10, right? Here's where interpolation comes into the picture. Now, if you want to understand what is the difference, what happens after interpolation, again, there's multiple types of interpolation, linear, cubic, and all of that. So all I'm going to do is I'm going to run this tiny piece of code here, and you can see this, right? Your actual data, look at this. This is the data that we have in hand when we ran this cosine function, and all those blue dots that you see is exactly that graph. But over that graph, when you perform interpolation, we have linear interpolation on the solid yellow line, and of course on the dotted green line we have cubic interpolation, right? Now, the way of us finding out how we can go about printing and knowing all these values. Now, you might be saying, okay, so why did we do this? Why do we have a graph there? Guess what? Between this blue point and this blue point, right? Two data entities. If you want something in the middle, if you want something in between these 2 points, guess what? You can have it now. But right now here, if you just look at the graph, you can still sort of get it. But unless you draw the shortest path, unless you start drawing straight lines from each of these entities, you will not get to know that, right? If I just gave you this and say, hey, now my mouse is pointed here, where is this? You can only guess, but you can't be specific. But if I say, hey, where is this point? Right now where my mouse is, you can quickly map the x-axis, map the y-axis, give me a very accurate number of how you can do this. Again, all of this is done with the 2 lines of logic out here and a couple of lines, right? Again, 2, 3, 4 lines. So all in all, 10, 15 lines, you're done with understanding a simple interpolation. So we have created 2 functions here, function 1, function 2, and all the sample points and variables that are associated with it, you can see here, right? You can see x, y, and the way of how you're supposed to go about interpolation, doing interpolation. There's multiple ways. Linear and cubic are the popular ones that you can go about seeing. So we took something that looks as plain, as boring, as uninformative as this, to having understanding every single point that lies in between these 2 entities that we have in discussion, right? So at the moment, you understanding that you can go about doing this in a very easy way is the goal here, and I'm sure you can know the fact that if this simple small example can give you this much insight, think about actually using this in a scientific computing environment, right? There, you're gonna have a lot more fun working with that. Right? Super. Now, as I told you, interpolation is basically a process of estimating unknowns that fall between 2 values. As we already saw, we have a library to go about doing it. We took a look at that practically as well. Right now, we discussed all of these multivariate interpolation, spatial interpolation, and all of that. So I'm going to run through the next type of sub-package that we have to discuss, which is linalg. Linalg, as you already know, stands for linear algebra. And whenever you have a requirement that says, hey, I want fast linear algebra capabilities, guess the sub package that you're going to be using, right? Now, this sub package is actually built using something called Atlas. Atlas is absolutely fantastic. It stands for Automated Tuned Linear Algebra Software, and LAPACK. LAPACK basically stands for Linear Algebra Package, and BLAS, or BLAS as it's called, it stands for Basic Linear Algebra Subprograms. Now, these libraries, this is one library that is built using all 3 of these other optimized libraries out there. And if you can already think, just look at the naming. It seems like this is extremely complex, right? It is. And when you bring 3 extremely complex libraries and give the power to it to one single library, you must expect that, hey, this becomes way more complex than we started out initially. That's not the case. It actually becomes very, very simple of how you can work with all these algebraic routines. You can operate on multiple objects, convert it into two-dimensional arrays. If you want an output to be a two-dimensional array, guess what? That is also possible here as well, right? Now, if you are wondering at this moment of time saying, hey, so, this sub package that we have, it also provides us with functions to solve algebraic equations. So should you use, if you use NumPy, here will be your confusion. Should you use NumPy.linear algebra or should you use SciPy.linear algebra? Well, SciPy.linear algebra contains everything that NumPy.linear algebra brings. And apart from that, what did I tell you previously? That SciPy is built on top of NumPy. So with all the functionality of NumPy and then some is what you will get when you use SciPy.linalg, right? So if there is ever a confusion in your head at any point of time in your learning which says, I don't know which to use, now you know which to use, right? And it's not just that. There's another advantage here. The other advantage of using SciPy.linalg over NumPy.linalg is the fact that it will always be compiled ready with BLAS or LPACK support. While for NumPy, it still is supported, but it is optional. It doesn't come as a standard entity that you can go about using. So the speed at which your equations will get solved is way faster with SciPy.linalg rather than NumPy.linalg, right? I know it sounds a little bit complex, but trust me, this simple slide will give you all the information you need to know about quick comparison, what can do what better, which should be used when, what is the advantage of SciPy.linalg over NumPy.linalg, right? Again, as always, let me quickly show you one or two demos on this and, we can go about doing it. Now, I'm going to take you back to your college days. I'm going to take you back to your school days because look at this. This is a linear algebraic solution, right? Now, when you take a look at the various equations that we have here, all we're trying to do is we're trying to solve these three equations and we're trying to find the value of x, y, and z for whenever these equations become 0, and you can eventually find out, right? So all we have to do is we have to move a couple of things around. We have to multiply certain equations with certain entities, and then you can get to solve. You start eliminating your variables. You solve for one. Once you start finding x, you can find out y. Once you start finding out y, you have the value of x and y. Use it to find z. That is how we solve it. Now, I definitely can do this manually because I remember how we can go about doing it. But to get our linear algebra system to work with, we're going to be using all the inputs as arrays. Now, as you can see, right, it's 1x, 2y, minus 3z. Look at this, 1x, 2y minus 3z. The second equation is 2x minus 5y plus 4z. And then you have 5x, 4y minus z. Minus z is nothing but minus 1, right? So this is the input array that we have, and here is the solution array that we require. And guess what? You have you have the input, you have the solution. All you have to do is solve it, right? Get from that to this. Look at the line which talks about the logic of how you can go about doing it. One line of code, and as soon as I hit play, it's very easy, right? Look at this. One thing you have to understand is x is 2, y is minus 1, z is 1, right? It's 2 minus 1, 1. If you substitute 2 minus 1 and 1, your answer should be 0 in all three of these equations. This is what we're being told here. This is the value of x, y, z. And once you attach the value of x, y, z, or everything must be 0. If you get these values and these are not zeros, it means that your equation is not completely balanced out there and there's something that went wrong, right? Again, look at how, I know you would have thought this would have been very complex as we started out, but this was the equation. All we had to do is we had to move the equation, and we already know the solutions from the right side, minus 3, 13, and 5. All we had to do is create two arrays, run one command, print the result, done. Very simple, right? So this, again, at the end of the day is very, very simple of how you can go about working with linear algebra. Let me give you one more example. If you guys have worked on matrices, matrix as it's called, there are a lot of types of matrix, diagonal matrix, square matrix, finding the determinant of a matrix. It's a very important concept in applied mathematics, right? So all we're trying to do here again is we're trying to create this matrix that we're talking about. To find the determinant of that matrix is again one simple function dot det of a, where a is the values that you're going to be providing. Input, perform the operation, output. 3 lines of code and you're done finding the determinant of a square matrix. Now, to do this manually will take a lot of time because you have to go about processing it and work with it. I'm very sure if you have taken up probably engineering for your bachelor's, you might have worked on these in your first 1 or 2 years of engineering, right? Understanding what a matrix is, operations, determinant, all of that. Now you can take a look at, this is the matrix that we have in hand, the square matrix that we are discussing. It's a 3x3 matrix, and this is the determinant that goes with that matrix, right? It's very simple. At the end of the day, it just takes a very complex solution, simplifies it by a lot, as I told you at the start of the video, and I'm sure you are convinced of that by now, right? So let's quickly take a look at another last sub package that we have in hand, which is ND-image. ND-image stands for N-dimensional images. It's an image processing library which you can use to perform multiple processing tasks, and you can perform various analysis out there as well, right? So the first question you must be asking right now is, hey, we have OpenCV to do this task very easily. Why do we require this? There might be cases where, there are cases where SciPy might trump OpenCV out there. OpenCV is meant for computer vision, meant for images, meant for videos, but SciPy is not lagging in any regard, right? Take a look at the basic manipulations that you can go about doing. You can crop an image, you can flip an image, you can rotate an image. You can do all of these simple tasks by making use of SciPy itself. And if you ever have to perform image segmentations, right? If you have to understand what's going on in your image, what the pixels in a flower looks like, what the pixels in a car looks like in an image, you can go about doing all of that. You can perform classification tasks using your images. If you want to build a dog and a cat classifier, as in you'll provide input images of dogs, input images of cats, you will get your machine learning algorithm to understand what a cat looks like, understand what a dog looks like. So when you surprise it with another image, a random image of either a cat or a dog, it will have the capability to tell you if it's a cat or a dog. How cool is that, right? It's a simple binary classifier, which again, I love working with. And of course, you can do all of that. You can do feature extraction as well. If there is a case where you know this is what the solution is, this is my application, and if you're wondering what variables in your data will let you go towards the solution, the process of feature selections, feature extraction is very, very important, right? There is a very wide term which governs all of these feature concepts. It's called feature engineering, which you might have heard about if you've studied a bit of machine learning, right? Fantastic. Let's quickly go about taking a look at this demonstration. This was going to be nice. We have a couple of images that you guys can take a look at. Now, all I'm trying to do is we're trying to print scipy.miss.face is going to print an image of a raccoon, and this is what a raccoon looks like, right? Looks pretty cute in my opinion. And all I tried to do was we took the image of a raccoon, and all we did is we printed the image using Matplotlib. You can see that plot.imshow stands for image show here, and this is the overall plot that we got. Fantastic. Now we have an image to work with. What are the 1 or 2 tasks that I can show you about how you can do? The first thing that we can go about doing is cropping the image. Cropping, this is the heart of the logic, right? One line of code, you can crop the image. Look at this. Now you have an entire raccoon out here with like a lot of grass on the top right, a lot of, I think palm trees on the bottom left or whatever it is. And now you can crop it. Now, if you're wondering about how you know where to crop and what to do what, you have something here called face.shape, wherein we have X channels, Y channels and all of that. And through which when you run integer of, LX by 4. So we're basically trying to say, pick up everything around the face and just crop it to us and just go about printing it. Right now, what I want you guys to do is, as soon as you see this code and you're trying to type it out, just change these values to see what output you get, right? Of course, changing these will change what and where the cropping happens. And I want you guys to figure this out. Now, don't Google this. This is very simple. You have to change 1 or 2 numbers. I've already told you what to do. Just give it a shot, right? So this is us taking an input image to us cropping an image. The next thing you can do is you can take an image and rotate it at any angle that you want. Now here all I've told is ndImage.rotate face by 180 degrees. Now all I can do is as soon as I hit play, you will see that the entire image will be flipped by 180 degrees. Now this is not the cropped image, right? Because we're still using the original image that we have in discussion. This is the input image. This is the output image. You can see that it just went all the way over to that particular angle, right? So as you can see, working with even basic image operations, working with linear equations, working with interpolation, working with constants and clusters are very, very easy with respect to SciPy, right guys?
Let's move forward with the very first topic. First of all, that what is PyTest? Okay. Now, I just want to guess a small thing here that you must have listened about the name of the PyTest. Either you are not aware of that what respective this particular thing is, or what's the use of this, some cases like that, but you must have heard about this PyTest. So PyTest, what it is, it's a testing framework which is used to perform out the different types of tests. Okay, now that different types of tests, as we know that whenever we are making out any application or whatever you are dealing with, whatever new you are making, so we just try to pass on some test cases onto that, so that whatever the application has been made by us, so before going into the market, that's completely bug free and that's completely available for the users to use that out, right? This is what we do. So how do we do out that test cases? So in that respective case, the PyTest is one of the frameworks which is used to perform out the different test cases, different types of tests for your application, whatever has been made out by you. Okay, so PyTest is a sort of testing framework which is used to do out the test. Okay, test means that test means you will be giving out some test cases regarding your application or regarding your software, whichever has been made out by you. And so why we just do that out? As I mentioned, we just do that out so that whatever the content you are giving or whatever the application you are launching in the market, that's completely bug free, and whatever the applications, whatever things you have added onto that, those are completely running absolutely fine. Okay, so this is the idea for performing up that test. Okay, second, it allows you to easily write the test and perform them. Now PyTest is one of the testing frameworks in which you could write out the test very easily. Okay, it's very convenient, it's very easy to write the test using this PyTest, and it's very as easy and convenient to perform those tests as well. Okay, so as I said that it is very easy to write the test, in that respective case we could say that the PyTest is a very easy tool as well, right? Because if it is basically easy to write up the test and perform them, then in the PyTest it is only the thing which you do with the PyTest library, right? You simply write up the test and you simply perform them out. So when both of these cases are actually covered up, so in that respective case we could very easily say that PyTest is one of the libraries which allows you to easily write the test and perform them as well. Okay, so hope I'm very much clear with this respective thing. Next, we are having that for PyTest could actually be used for building a simple test in a very easy manner. Okay, now let's say you just want to build out a very simple test. So in that respective case, with the help of the PyTest library, you could build up that simple test in a very easy manner actually. Yeah. So actually when I mentioned up above in the above point that it is easy to write the test and perform them, so in that case, it is a correlated sentence which I am right now speaking, that you could simply build up the scalable test in a very easy manner. Okay, and it is a tool which automatically finds the written test by you and runs up the test. So whatever the test has been written out by you, so it automatically finds that out and it run out those respective tests. Okay. So PyTest is a sort of tool which can automatically find out whatever the test case tests are actually written by you, and it simply runs those tests as well. Fine. So this is completely what PyTest is actually used for. It's especially used for performing on the test cases and the test, and why it is actually preferred up. So because it is one of the tool which is very easy to run test and perform the test, and it's the tests are very easy to write there, and it's having a very easy manner for writing up the test, and it can automatically as well find out the tests which are written by you, and it runs out that respective test as well. Fine. So hope I'm very much clear with all of these 4 points mentioned here regarding that what PyTest actually is. Now let's discuss out that what are the features of PyTest. So here we have some 4 features of PyTest which I have listed up here. Let's go through them each line by line. Okay. So first for PyTest includes useful plugins. Okay. So actually PyTest is one of our testing framework, one of our tool which as well includes out the useful plugins. So at the time of using them out, you could simply use those plugins regarding what is the function you have to perform using that. Okay, PyTest does not need any API to use. Okay, Now, in this respective tool, PyTest tool, or you call it as library, you call it as tool, you call it as framework, whatever you could call that out. So PyTest does not need out any API to use. Okay. So it's not the case that every time you need to insert up some sort of API, and after that only you could work with the rest of the things which are in the PyTest, or after that you could run up the test, or you could write the test. It's nothing like that in PyTest. Okay, it's a very simple and a very easy to use tool actually. So in that perspective, you as well do not need out any of the APIs here. Okay. Next, PyTest is used to run the unit and the doc test. Now there are two types of tests. First one, unit test. Maybe you have heard about unit testing as well, right? So PyTest allows you to run out the unit test and the doc test. Okay, these are the two types of tests, two sort functions of tests which you have out here. So yes, PyTest actually allows you that yes, using the PyTest you could write up the respective code, and you could run up the unit test and the doc test as well. Okay. Next, PyTest can be written as a method or a function. Now, PyTest can be written. Okay, let's say you want to perform out a test for any of the cases, right? So now in that case, what you could do, you could simply make up a method, or you could make up a function. Okay, that's with the help of the PyTest only. So it's not that case that PyTest shall only be written using a function, or only shall be written using a method, or any specific thing like that. With a PyTest, you could write up the PyTest in a form of a method or in a form of a function as well. So whatever the type of work you are doing, or whatever you are actually comfortable with, you could write the PyTest in according to that as well. Fine. So these are some features of PyTest which we are having up here. So let me go through them once again at this place. At first, PyTest includes out the useful plugins. Plugins, you could call that as if I say in a very simple manner, so you could call the plugins as an extensions as well. Okay, so that's the idea. Then PyTest does not need any API to use, so you do not need out any API to use up the PyTest. It simply is a very simple tool actually. You have some installation process, you install that out, and after that you could simply go ahead and use out that respective PyTest to write up your code. Okay, you do not further need out any API or any special tool access to write up the PyTest and all those things, right? It's not at all needed in this respective case. So that's why actually it is one more thing said that it's one of the easy tool. Okay, that's why in the previous slide that was what is PyTest, I mentioned up that it is very easy to write up the test and run in the PyTest too, right? That was only the reason in which I mentioned up this statement, that why was it very easy to run and write up the test. This is only the reason for that respective thing. Okay, that it doesn't need out any API. Next, Python is used to run the unit and a doc test that I already mentioned up that there are two types of tests. First one is a unit test and second one is a doc test. So PyTest is used for running out both of those tests. And last but not the least, PyTest can be written as a method or a function. So PyTest is one of the tool, a framework, whatever you say out. So in the PyTest, you could declare a method or you could declare a function as well. No queries or no issues in that case. Okay. So hope I am very much clear. Now we'll be discussing about the advantages of PyTest. That what are the advantages? So the advantages of PyTest are listed here. Let's go through them each line by line. Okay. So the very first advantage of PyTest is that it is free and open source. Yes, that's the first and the foremost very important advantage I would say actually. That it's free and open source. It means that it doesn't ask you regarding any of the money, anything regarding that for the installation actually. Okay, simply you have a very simple command. Simply write out that respective command and you get out your PyTest installed for your device, and then you could go ahead with and perform your test or whatever that you just want to could go ahead with that. Okay, so it is free and open source as well. Open source means that it has its official library as well, official website as well. So you could just go and there you have a huge documentation regarding the PyTest. So you could go and you could go through those documentations and learn about the PyTest as well. Okay, so it is free and open source. Next you have that it allows you to run multiple tests in parallel. Okay. It allows you to run up the multiple tests in parallel. Let's say you want to run one or two tests at one single time. Okay. No, it's not possible for you to run up two single tests at one single place and at one single code. It's not possible for you to run both of those tests, right? So this PyTest is a framework. It's a tool, or you call it as a library, which allows you to run multiple tests in parallel. Okay, it means that you could run 2, 3, 4, 5, 6, n number of tests at a single time. Okay, whatever the number of tests at single time you want to run, you could run all of them at one single go. Okay, so this is one more very important feature which you have up here into the PyTest library. Next, it allows you to run an entire subset of the suite of tools. Okay, if you remember about the suite of tools, we have learned about the Selenium at some sort of time. So Selenium has some suite of tools. It has 4 suite of tools which we have out in the Selenium. So it's WebDriver, it's RC, it's IDE. So we have like these suite of tools here onto the Selenium. So in that way only it is saying that you could run an entire subset of the suite of tools. So this PyTest is one of the library which allows you to run out those sort of tools as well. So you could as well use up and run out the entire subset of those sort of tools. Okay, so hope I'm clear with that. Next we are having, it is having a very simple syntax, thus easy to learn. So the syntax which you have in the PyTest for writing up the test, so that's super easy and very simple syntax actually. So when we are having out a simple syntax, so obviously it is very much easy to learn that perspective for us, right? So it is having out a very simple syntax and that is easy to learn. Further we'll be seeing up some examples as well. Next, it allows you to skip a subset while the execution. Now let's say you have written out some test and you just want to skip out a subset at that respective case. Okay, so if you just want to skip out some sort of code in between or some sort of subset in between, so yes, while the execution is going on, you could skip out that respective subset as well. Okay, so in that as well, it's not gonna result you out any sort of error or anything like that if you're skipping out a subset. Fine. So in that perspective only, it is said that it allows you to skip out a subset while the execution of that respective test. Fine. So these are the advantages of PyTest. Now we'll be understanding that how we will be able to install the PyTest. Okay. So in Python programming language, this PyTest absolutely belongs to the Python only. So in the Python programming language, for installing out any of the libraries, we have out a very simple syntax, and that is only used while the installation of any of the library. Okay. So and the syntax which we have in Python, you write out pip, you write out install, and after that you write out the respective library name which you want to install out. Now in our case, what we are having, our library name is actually PyTest. So into that case, I could simply write pip, then I could write install, then I could write PyTest. But where to write out this respective command? So again here I would let you know that you have no restrictions in writing up this respective command, that where to not write, where not to write. See, if you are using up any of the IDE, so if that IDE is already having some integrated terminal onto that, so you could use that out. Let's say in my case I will be using the PyCharm. So PyCharm already has its own terminal. Okay. So in that respective case, you could write on that command into that respective terminal. You could simply write pip install PyTest. Now let's say you are having any in some sort of IDE which does not have its terminal for the installation. So you could open up the command prompt, and in the command prompt you could write up this command, that is pip install PyTest. Okay. So hope I'm very much clear about the installation of the PyTest, that for installing any of the library in Python, we have a very simple syntax which is mostly used while the installation of the library. So that syntax is pip install, further your library name. So the syntax for the installation of that respective for the PyTest is pip install, and my library name is PyTest. So it completely becomes a pip install PyTest. So I'll be as well showing you up the installation of this respective PyTest when we move on to the PyCharm IDE.
So let's start with graphical user interface. So as I already told you about graphical user interface, it allows the user to communicate with electronic devices through graphical representation. When I'm talking about graphical representations, that means buttons and icons. So the example of GUI is Microsoft Windows as well as Mac OS, and we are having several other examples also. So basically what happens here you can do the communications by interconnecting with the icons. So this is the basic idea about graphical user interface. Now, let's see different types of graphical user interface libraries that are present in Python. So we are having several libraries that are used in Python for the GUI. We are having Tkinter, we are having Kiwi, PyQt5, WXPython, and PyGUI. So now let's get some idea about Tkinter. So Python Tkinter is nothing but a standard GUI library. So basically when Python is used in conjunction with Tkinter, it creates graphical user interface that is quick and simple. Also, it gives the TK GUI toolkit a sophisticated object-oriented interface. So this is the basic idea of Tkinter. You just need to know that it's a Python GUI library, and then we will see how to create a Tkinter programming. So now, if you want to create a simple GUI application with Python Tkinter, so there are some certain steps that has to be followed. First, you have to import the module of Tkinter, right? So you can just simply write from Tkinter import asterisk, and then you can import the Tkinter module. Second step that we have to follow, we have to create a main window. Then how to create a main window? We will basically create an object of Python Tkinter. Next, after creating the main window, now we can add multiple widgets in a main window. And after adding widgets, now we can enter into the main event loop to perform action. So now there are two primary approaches that user has to follow, right? So first, as I already told you, that you have to import the Tkinter module, and the module name is from Tkinter import asterisk. So after importing the Tkinter module, now what we have to do, we have to create a main window. So how to create a main window? I will just simply write here main window, that is nothing but a variable. So for creating an object, I will just write here tk and parenthesis. Make sure that your T is capital. And then in order to run the application, I will just write here main window dot main loop. So basically main loop is nothing but an infinite loop, right? That will run your application. And then it also waits for an event and process it as soon as the window is open. So this is the basic idea about how to create a basic Python application with GUI. Now let's see into the practical example. So what I will do now, I will just write here from Tkinter import asterisk. So this is the basically Tkinter module that I will import here, and then after that I will create a main window. So let me write here variable window, and I will create here the object. So for creating the object, make sure that T is capital, and now I will just simply write window dot main loop. So we know that main loop is infinite loop that will run the application. So if I'm executing it, you can see that we have created a simple GUI application, right? So this is the basic idea about Python Tkinter. So now you have seen that how to create a GUI app. Now let me here change the title. So if you are executing it now, so on execution, you can see that I am getting here TK, right? And if I want to give the title instead of TK Great Learning, so I will just simply write here window dot title, and I will write here welcome to Great Learning. So now let me execute this, and on execution you can see that on top we are getting welcome to Great Learning as a title. So after this, let me change the window size. So I'll just write here window dot min size, and I will just write here, let's suppose width as 100 and height is equal to 200. So if I'm executing it now, you can see that this is the minimum size of this window. And if I'm clicking on this button maximize, then you can see that this is the maximum size. So let me change the maximum size also. So for that, I'll just write here window. So I will just write here window dot max size. And once again, let me give here width is equal to, let's suppose 300, and let's take the height as 800. So on execution, if you see, this is the minimum size of the GUI app, and this is the maximum size, right? So this is the basic idea about Python Tkinter. So after creating first GUI app, now it's time to know about widgets. So what are widgets? So talking about widgets in general, this is basically an element of GUI. And in Tkinter, widgets are considered as a objects which represent buttons, frames, etc. So basically Tkinter offers many controls, and these controls are nothing but known as widgets, which we will be using in GUI applications, right? So as I already told you that it represents buttons, labels and text boxes. So we are having different types of widgets that are available in Tkinter, that is label, button, entry, check button, canvas, frame and many more. So this is the basic idea about widgets. So now let's understand the geometric configuration of widgets. So we have already got the idea about widget, but if you want to organize the widgets, so we need a geometry manager classes. So primarily we are having three types of geometry manager classes, that is pack, grid and place. So after adding widget, I have to organize the widget. So I will be using these three geometric manager classes. So the first one is pack. So when you are using pack functions, so it means that you are placing a widget on a top, right? Coming to the grid, it is used to organize the widget in the table-like structure. So when I'm talking about table-like structure, that means row and column. Next, we are having place. So it is used to organize the widget at specific positions. So I will just write here X and Y. So here, if you are writing, let's suppose X is equal to 20 and Y is equal to 40. So that means from left to right, you are placing a particular widget. And now coming to the Y, that means from top to bottom, you are placing any widget. So this is the basic idea about the geometric configuration of widgets. So now it's time to discuss about the different types of widgets that are present in Python Tkinter. So first widget that we are having is label. So when you are talking about label, basically it is used to represent display box in which image or text is added. So what's the syntax of label? So I will just write here simple label, and in parentheses I will write here master, comma, options is equal to value. Coming to the master, master is nothing but the main window that you have created, and here we can provide several options as an arguments. So we can write in options BG, command, font, image, width and height. When I'm talking about BG, that means it's the background, right? And also we are having FG also. FG means foreground color. So when you are writing FG is equal to blue, so your text will be of blue color, right? So this is the basic idea about the label widget. Now let's see it into the practical example. So what I will do here right now, once again I will just import the Tkinter module. So I will just write here from Tkinter import asterisk. And then after that I have to create my main window. So let me write here the variable name window, and I will create the object as tk. Now I will just simply add widget here. So I have to add here label widget, right? And we know that after creating the main window only we can add widget here. So let me write here Elvin is equal to label. So this is my label widget, right? So in label here I have to write here master. What's my master? Master is nothing but the main window. So I will just write here window. And then in options I can give several options. So let me write here options. Let's suppose I will just write here text, and I will write here great learning. So this is the label, right? And also if I want to organize the widget, then I have to use the geometrical configuration, right? So let me use here first L1.pack. And if you want to run the main application, then I have to write here window dot main loop. So if I'm executing it now, so on execution you can see that great learning has been printed on the top of this window, right? In middle. So this is about the pack geometry class. Now after pack, if I'm just using here, let's suppose grid. So we know that grid contains rows and columns, right? So what I will do here, I will just write here row is equal to 0 and column is equal to, let's suppose 1. Now if I am executing it, so on execution you can see that great learning has been printed here. So as of now we have just started doing the coding. So as soon as you will write more code, then we can change the row and column also. And then we are having one more geometry class, that is place, right? So I'll just write here place. So basically in place, if we want to organize the widget at any particular place so that we can give here X and Y,
And let's suppose if I'm writing here x is equal to 5 and y is equal to 10. So basically this is the position. When I'm writing x is equal to 5, that means from left to right you are placing your widget. Similarly, when I'm writing here y equal to 10, that means from top to bottom you are placing your widget. Let me execute this. So on execution you can see that great learning has been printed. If you want to place at any other position, so you can just write here x is equal to 50 and y is equal to, let's suppose, 100, and if you are executing it you can see that we are getting the output like this. So this is the basic idea about the label widget. So now let's suppose we have already created a label widget of text great learning, right? Let me execute this. So if you see, this is a great learning here. Now if I want to add here the background color along with the foreground color, then how to add it? So I will just simply go on here options and I will just write here, let's suppose background color I want in blue, so I will just write here blue, and for foreground color I will just write here simply red. Let me put this blue under double quotes. So now if I'm executing it, you can see that on execution this great learning, so foreground color will be in red color and the background color is of blue color. Also if you want to increase its width, so you will just write width is equal to, let's suppose, 40, and now if I'm executing it, so on execution you can see that its width has been increased. So this is the basic idea. So in label widget you can add more options in the form of background, foreground, image, font, many more. Yeah. So after knowing label, now if I want to add any image on my GUI app, so what can I do? So let me execute once again this. So if you see here, let's suppose if I want to add any image here, so what shall I do? So first what we'll be doing, let me just remove this. Let me write here the variable name as Ivan, and I will just use here photo image. So you can also see that is showing the photo image option, right? So inside this photo image, what I will do here, I'll just write here file, and if you see here, so let me take a file from the desktop. So if you see here, this is the file basically, and it's an image file, right? So I'll just go on properties, and if you see, this is the location, so I'll just copy this, and the file name is Python, right? So the image file is having the name Python. So what I will do here, I will just simply first put double quotes, and inside that I have just copied it and pasted the location, and the file name is Python, right? So I'll just write here Python dot, and it's in the PNG file. So I'll just write here Python dot PNG. Now instead of this backslash, we have to just replace it with a forward slash. So I will just write here like this. So now after this, what I will do, I will create a label. So I'll just write here L1 is equal to label, and inside this label I have to first put master, right? So my master will be here the main window. So I'll just write here window, and then I will write here option. So in option I will just write here image, and what's the image here? So image is equal to I1. So now if I'm doing execution, so on execution you can see that I am getting nothing. Why? Because I have to use here geometrical classes, right? So for that I will just write here, let's suppose L1 dot pack. So now you can see that in output we are getting the Tkinter image here. So this is the basic idea about the label widget. So the next widget that we're going to discuss is button. So basically button is used to display button in an application, and it's also having a very simple syntax. We have to just write button, make sure that B is in capital, and then instead of master our main window will be there, and in options we can pass several arguments such as BG, command, font, image, width and height. So here we can also use command. So when you are writing command, so basically when we are creating any function, we will just assign that function name into the command. We will understand better while doing the coding part. So now let's see the practical implementation, how to create a button. So for creating button, I will just simply write here, let's suppose B1 is the variable name. I will write here button, and I will write here window. So window is my main window, right? And after that, let me write here text. So if I'm writing here text is equal to enter, and again I have to write here p1 dot. I can use here pack, I can use here place, I can also use here grid, but let me write here pack. Now if I'm executing it, you can see that this is my enter button. So let me give here again the color. So in background, let's suppose if I am taking it as a green color, and for foreground I will just take as yellow. And now in execution, you can see that this enter button is having foreground color as yellow and background as green. So now we have seen that how to create a button widget. Now let's see how to create an entry. So what is entry? So in entry, let's suppose if I have created a widget that is label widget and its name is username, right? And I want to give the entry through the user, right? So that's why I will create an entry where I can write the value in the form of string as well as integer values too. So let's create entry here. So I'll just write here even variable, and for entry I'll just write here entry, and in entry I'll just write here window. And then let me give here the width also. So let's suppose the width of this entry is 20. So I'll just write here even dot back, and now I'm executing it. So you can see that on execution I am getting this entry, right? So here I can write here string value as well as integer also. So how we can use this entry? So let's suppose if you are making any website, right? And for that particular website, if you want to access it, you need username and password. Then we can use entry there, and we have to create button also for that. So let's suppose that if you want to change the font style here, so what I will do here, I just simply write here font is equal to, and let me write here Calibri, and let's suppose that font size I want 20. So I'll just write here 20, and now if I'm executing it, you can see that the size has been increased. So now if I'm writing here Gaurav, it's in Calibri, right? Now, what can I do here? If I'm writing here BD is equal to 5. So what is BD here? So BD is nothing but it is used to represent the size of the border. So when I'm writing here BD is equal to 5, then you can see that we are getting the entry button like this, right? So this is the basic idea about the entry. So let's make a simple GUI app. So what we're gonna do, first we're gonna create a label, and after that entry, and then we will create a button. So in label, I will be taking the name as employee name, and entry I will just give any string values. And when I'm clicking on submit button, so what will happen? Whatever the string value that I have given in entry will be displayed. So basically I will be using two labels here. The first one will be having the name as employee name, and another label will be having the name as nothing. So whatever the string value that I am giving to entry, and if I am clicking on submit, so instead of nothing, that value will be shown to us. So this is the basic idea. So let me create a simple GUI now. I'll just once again write here from Tkinter import asterisk, and now I will just create a main window. Let me give you the title also. So once again I will just write here window.title, and I will just write here welcome to great learning. And then let me just write here window minimum size. So I'll just write here width as, let's suppose, 200, and then height I will just write here 400. So for the maximum size, what I will do here I will give the width as 400. Let's take the double of the minimum size, and then height also I will write 800, and let me write here window.main loop, because if you want to run the application then you have to write it, right? So you can see that this is my output, and this is the minimum size, and the maximum size is this one. And here on the title I'm getting welcome to Create Learning. So these are the things that we already know, right? So let me create a label here. So for label I will just write here L1 is equal to label, and L1 is my variable, right? So inside this label let me write here master. So master will be here my main window. And now in options let me write here text. So in text let me give here, let's suppose, employee name, and then let me also give here foreground as well as background color too. So foreground color, let's take here blue, and background color as, let's suppose, I will take as red. And since this is a label, basically it's a widget, so I have to organize this widget. So for that I will just write here L1 dot, I can use also here back, but let me use this time place. So in place I can place my widget at any specific position. So let me take here x is equal to 0 and then y is equal to 10, and on execution you can see that this is my label which name is employee name, right? Now let me create an entry button here. So for entry button I will just simply write here e1 is equal to entry, where e1 is my variable, and once again I will just write here window, and let me give here the font. So I'll just write here font. So in font I will just change the font style. So let me change the font style to Corbel, and let me give the size as 18, and let's use BD too. So why we are using BD? So as I already told you that BD is used to represent the size of the borders, right, of an entry. So if I'm writing here BD is equal to 5, so let me write here even dot entry. So now what I will do now, I have to place this entry, right? So once again I will write here even dot, let's use here place, and let me use here x is equal to 40 this time, and y is equal to 10. And if I am executing it just now, you can see that I am getting this output, right? So it's not coming perfectly, so let me just adjust the size here. So instead of 40, if I, let's suppose if I'm writing here 80, and now if I'm executing, you can see that I am getting here employee name as label, and this is the entry, right, where I can write any name. Okay, so let's create a button also. So for button I will just simply write here b1 is equal to button, and let me give here the master as window, and in option I will give here once again the text is equal to, let's suppose, enter. Let me give here the colors also for this button. So for foreground I will use yellow, and for background let me use green here. So now we have to organize this button widget also. So for that I will just write here b1 dot place, and let me write here x is equal to, let's take here 100, and y is equal to 40. I'm just taking random values here. Now if I'm executing it, you can see that I'm getting like this one, right? So let me just rearrange it. If I'm writing here x is equal to 120, okay, now it's coming in between, and let's take the y value as 60. Now it's coming perfect, right? Now if I'm writing here, let's suppose Gaurav, and if I'm clicking on this enter, you can see that nothing has been happening, right? So what I will do now, I'll just create another label, and this label will be here, and I will just write here nothing. Now after that, whatever the string values I'm writing here in this entry, and if I am clicking on this enter, then this, instead of nothing, the value must be the same that I've given. So for that, what I will do, let me create another label. So I'll just write here L2 is equal to label, and I will just write here window. And after this, I will just write here text is equal to nothing. And let me give here foreground as, let's suppose, black, and background, let's take background as brown. And let me place this visit. So I think X will be 120 here, I will be taking, and Y, let's take here 90, or let's take 100. And now if I'm executing it, you can see that label is not defined because L has to be capital here. Now it's good to go. So on execution, you can see that I'm having the another label as nothing. Now I have to do something, that if I'm writing here Gaurav and clicking on this enter button, then it should work, right? And instead of nothing, I want here the value as Gaurav. So for that, what I will do here, let me create a variable. So now after this, what I will do here, I will just create a string var. So let me create a variable v is equal to string var. So when I'm writing here string var, so basically that means we are dealing with the string values, right? So after creating here string var, so now what I will do here, inside this entry in options, I will just write here text variable, and it will be equal to v, because we are dealing with the string values, right? Now I want that my button should work. So for that, I will create a function. So whatever the function you are creating, let's suppose the function name is @tech, then I can use the binding functions, and I will write here in button command is equal to @tech. Now how to use this @tech? So I will create a function basically. So I will just write here def @tech. And now after this, I will just simply write, let's suppose my variable is v, right? So if I want to get any value, I will just write here v.get. So let me create another variable, x is equal to v.get, right? And now after this, I'll just simply write here. So now what I will do here, I just want to print this value. So I have to write here print x. Now here, as I told you that I have created two labels. The first label name was employee name, and another label, it was written nothing. So I told you that whatever the value that I am putting into the entry, it should be changed in the label whose name is nothing, right? So I will just write here L2, and I will use here config function. And inside this config, I will just write here text is equal to x. Now, what will be your x value here? So I have written here x is equal to v.get, right? And v.add v is equal to string var. So basically we are dealing with the string values. So now what I will do here, I will just execute this, and let me write here, let's suppose Gaurav. And if I am clicking on this enter button, you can see that I am getting Gaurav here, right? And also if you see the output, I am also getting Gaurav in the output. Why? Because I have written here print x. So now let's make some few more changes. Here the name has been changed from nothing to Gaurav, and let's change the color also. So how you can change the color? So in this config function itself, I will just write here background as, let's suppose, yellow, and then foreground as, let's suppose, blue. Now if I'm executing it, so let me stop and rerun this. And this time once again, if I'm writing here Gaurav, and if I'm clicking on this enter, you can see that the name has been changed along with the background color as yellow and foreground as blue. So this is the basic idea about the label widget, entry, and the button, right? So this is a very simple GUI application. So the next widget that we are having is check button. The check button is used to show a selection of choices as check boxes. Let's take an example. Let's take an example of male and female. We can use them as a check button. Now let's see the syntax. So the syntax is simple. You have to just write the check button, and inside the parenthesis your master will be the main window, and then there are several options that can be passed through as an argument. We can have title, background as well as active background. So this is the basic idea about check button. Now let's see the practical implementation. So now you can see that this is the basic Tkinter programming. Now what I will do here, I will just create a variable here. Let's take CV, and I will just write here check button, and inside this I will just write here window, and then I will just write here text. So as I was explaining about, we can take the example of male and female. So just let me write here male, and then I'll just write here CV dot, let's use here pack. And now if I'm executing it, on execution you can see that I am getting male as check button, right? So this is my check button. So the next widget that we are having is frame. So basically frame serves as a container and it is used to organize the widgets. Now what is the syntax of frame? It's again simple. You have to just write frame and then master and then options. So here as an argument we can pass several options such as BG, BD, cursor, width and height, right? Now let's see the practical implementation of this frame. So now once again I came back to PyCharm. I will just simply write here f1 variable. Let me create here frame, and inside this I didn't pass any master neither options. So I'll just write here f1 dot pack, f2 is equal to frame, and I will just write here f2 dot pack. Now if you are executing this, then nothing will be executed, right? So what I will do now, I will just create here, let's take an L1, that is label I will create here, and inside this I will pass f1 as a master, and then let me take here text. So I'll just write here text is equal to great learning, and if I'm writing here L1 dot pack now, so let me execute this. So on execution you can see that I am getting great learning. Now I will just create another label. Let's take L2 is equal to label. So I will just write once again here f2, and then let me write here text is equal to bottom. And I will just simply write here L2 dot pack. So now on execution you can see that I'm getting bottom. So here you can see that basically I'm having two frame, right? Great learning and bottom, but I want the bottom to be printed on the bottom side. So for that what I will do here, you can see that I have written here f2 dot pack, right? So I'll just write here side is equal to, and I will just write here bottom, and bottom will be in capital. So now if I am doing the execution, so on execution you can see that great learning is on the top of the window, whereas bottom is on the bottom side of the window, right? So the next widget that we are having is list box. So list box is used to give a user with a list of options. So basically in a simple word you can say that list box contains a list of options, and as we know that list can contain different types of data values, so list box will contain a different list of options. So next we are having syntax. So what's the syntax of list box? Once again we will write just list box, and inside that masters and the options that we can pass as an argument. So what are the options that we can pass through an argument? It's like BG, BG is background, BD is used to represent the size of the border. Then we can also use font as an option, image, width as well as height. So now let's see the practical implementation of list box. So in the list box practical example, we will see how to remove the element from the list box and also how to insert any element, or you can say items, in the list box. So now what I will do here, I will just write here LB is equal to, let me create a list box. So this is my list box, and I will just write here window, and let me give the width. So if I'm writing here width is equal to 20, and let me just write here LB dot pack. So here L should be capital. So this is my list box, and if I'm executing it, you can see that I got an empty list box. Now it's time to insert the options in the list box. So for that, I will just create a list. So let me give here the list as L1, and let's insert several values. So how to add several values in a list box? Let me write the name here. So let me write here Tony. I will write here Edwin. Let's take some few more names. Let me write here Kirtika. And let's take one more name as Ipsa. So these are the 4 values, right? And I want to insert in my list box. So for that, what I will be using, we can use loop, right? For loop. So I'll just write here for I in my list name is Elvin, right? So what's the name of my list box? So list box is having a variable name as LB. So I will just write here LB dot, and then I will just write here insert, and let me write here end, and I will just write here I. Now if I'm executing it, so on execution, you can see that I am getting Tony, Edwin, Kirtika, Ipsa. So what can I do now? If I want to remove, let's suppose Ipsa from here. So let me create a button. We have to create the button, right? So for button, I will just write here B1 is equal to button. And I will just write here window, and text is equal to, let's suppose if I want to remove Ipsa, so I'll just write here remove. And let me give the color also. So I'll just write here, let's take the background color as red. Now for button also I have to write here b1 dot back. Now if I'm executing it, so you can see that this is the remove button. But if I'm just clicking on this Ipsa and then clicking on this remove button, so it's not removing. So we know that it will not remove until and unless we are not using a command, right? So what is command? Command is nothing but a binding function. So in button, I will just write here command, and let's take that I will write here edtech. So here you can see that I have assigned edtech in command. So what does it mean? It means that I've created a function whose name is edtech, right? So what I will do here, okay, let me just create a function here, def edtech, and inside this function, what I will do here, so I'll just simply write here LB. So what is my LB? LB is nothing but a list box variable. And if I want to remove the element, then I will use here delete function. And inside this delete, I will just write here anchor. So what do you mean by anchor? So that means if you want to select an item, single item, and if you want to remove one by one, then we can use anchor here. So if I am executing it now, so if I want to remove, let's suppose Kirtika, and if I am clicking on this remove button, then you can see that it has been removed from the list box. Similarly for Ipsa, we can do it, right? So this is the basic idea about the list box. So now after understanding label widget, button widget, and many other widgets, it's time to discuss about some other widgets. So we are having different types of other widgets available in Python Tkinter, starting from menu button, menu, message, radio button, scale, scroll bar, text, top level, spin box, and pan window. We'll see some of the widgets in the practical exam. So let's start. So now let's discuss about the radio button widget first. So for creating radio button, let me write here RB1, and R has to be capital. So this is my radio button, and as a master, I will just write here window. And after this, I will just write here text is equal to yes, and let me write here RB1 dot back. So on execution, you can see that this is the radio button that has been created. Yes, right? Let me create one more radio button. So I will just write here RB2 is equal to radio button. And once again, as a master, I will write here window, and text is equal to no. And obviously we have to place the widget, right? We have to organize the widget. So for that, once again, I have to write here RB2 dot back. So now you can see that I'm having two radio buttons, that is yes or no, but you can see that these both have been selected, right? So for that, what I will do here, I will just write here value is equal to, let's suppose for s I'm giving the value 1, and value is equal to 0. Now if I'm executing it, you can see that only one has been selecting at a time. So now here if you see that these are the radio buttons, right? But let me create a button so that whenever I'm clicking on yes, I want the value to be printed. on my output. So for that I will create a button. So let me create a button. So I just write here b1 is equal to button, and then I will just write here window, and in button I will just give here text is equal to into, and once again just let me write here b1 dot back. Now if I'm executing it, then you can see that I got the button. But if I'm clicking on this enter button, you can see that nothing has been printed in my output. So for that, what can I do here? Let me create here int var. So I'll just write here, let's suppose I'll just write here v is equal to int var. So that means basically we're gonna deal with the integer values, and after this I will just write here variable, and we know that our variable is equal to v here. So I'll just simply write here v variable is equal to v, and inside the button when I'm writing command, so that means we are using a binding function. So command, once again I will give the name here edtech, and I will create the function name as edtech, right? We know that whatever the function we are creating, so let's suppose we are creating a edtech function, so in the command we will assign the edtech here. So let me just write here def edtech, and inside this let me just write here simple print, and v is my variable, so I just write here v dot get. So we know that in yes we have assigned the value as 1, and for no the value is 0. So now if I'm executing it, so on execution if I'm clicking on yes and clicking on this enter, so now this button will work. So on execution you can see that I'm getting the yes value as 1, right? That we have already assigned the yes value as 1. Similarly, if I'm clicking on no and then clicking on this enter button will give you the value 0. So this is the basic idea about radio button. So the next widget that we gonna discuss about is the message box. So now talking about the message box, it is used to display the message box on the Python applications, right? So what I can do here, let's create a message box. So for creating a message box, you have to import message box. So I'll just write here from Tkinter import, I'll just write here message box. Now my message box has been imported. Now what I will do here, I will just simply first let me create an entry. So I'll just write here even is equal to entry, and in this entry I will just write here window, and let me also give here the font. So in font I will just change the font style. So font style let's take as Calibri, and then font size as 18, right? And let me give the width also. So I will just write here width is equal to 20. And after this, let me just organize this widget. So I will be using even.pack. And now if I'm executing, you can see that this is my entry box, right? Now what I will do here, let me create a button also. So I will just write here v1 is equal to button, and inside this button I will just write here window simple, and then in this button I will just write here text is equal to, let's take enter, right? And I will be just writing here v1.pack. Okay, so now what I want to display here in this message box, so let's suppose if I'm not writing anything and if I'm pressing on enter, so then it shows some message box, or you can say some warning message, right, in the form of message box. And let's suppose that if I'm writing any string values, then it shows that yeah, it's successful and it should print that particular value. So for that, what I will do here, I will just create here a int var. So I'll just write here simple v is equal to int var, or instead of int var I'll just create a string var, right? Let me write here string value. So I'll just write here string var, and so here what I have to write, I'll just write here text variable is equal to v, right? Now we know that we have to write here command, which is a binding function basically. So command here, once again I will create a function, so I have to write the function name here and assign it to the command. So what I will do now here, I'll just create a function here def edtech, and let me give the condition here. So let's suppose if I'm writing here if v dot get So we know that v dot get will give me the value is equal to, if I'm writing here empty, so I will just write here message box. Now I will be using the message box here dot. Python provides several functions here for this, so I'll just write here show warning. So I will be using here so warning, and here you can see that we are having the title and message. So in title I will just write here cousin, and after that I will write it's empty. It's simple, right? When you are not writing anything in the entry, and if you are clicking on the enter button or the submit button, then it should show something, right? Please enter something. It's empty. So I've just written here the instruction, it's empty. Next, I will give here the else condition, else message box dot. Now I can use here one more function that has been provided by Python. I just write here show info, and then title I will just give here successful, and then let's suppose display I want to display here v dot get. So I'll just write here v dot get. So whatever the value is there, I'll get here, right? So now if I'm executing it now, so on executing, this is my entry, right? And if I'm not writing anything entry and clicking on this enter, you can see that I'm getting cousin in my title and it's showing it's empty, right? So this is the message box. Similarly, if I'm writing, let's suppose Gaurav here, now you can see that I have given here Gaurav in Calibri 18, right? So this is the Calibri font style, and if I'm clicking on this enter, it's showing successful Gaurav, right? So this is the basic idea about the message box.
Now we should understand how this game works in the introduction. Tic-tac-toe game is also known as X and O game. We have two different players. Either one can choose X or O. If player 1 chooses X, by default player 2 will be having O. If player 1 chooses O, by default player 2 will be having X. These are the only two combinations where the characters can be chosen. Apart from this, we also have a board or a grid that is in 3x3 format. That means 3 rows and 3 columns. So we also call this game as noughts and crosses. So when this person or a player is considered to be a winner, only when either of the characters X or O is being placed consecutively 3 places, either it might form a vertical consecutive place or a horizontal or a diagonal arrangement, that particular person or a player is known to be a winner. So this is basic rules which we have followed, which we have played in our childhood, and this is the game all about. Steps to design this particular game in the Python platform. First, let's understand in normal English language what are the different steps we have to follow. Nothing but a kind of algorithm. So let's quickly hop into the step 1. Designing the tic-tac-toe board. We have to design this particular board in order to place the characters inside. Right? The platform should be made ready. 3x3 is the format, that is 3 rows and 3 columns. The numbering of the cells goes from left top corner. That is 1 starts from left top corner and the 9 ends at right bottom corner. So this is the format we follow. And in step 2, we have to store status of the board and every player's moves using data structure. Right? So status of the board might be either of 3 different status. One would be empty, second would be filled with X, third would be filled with O. What about players' moves? Every player move, either it will be X or O depending upon the choice made by that player at the starting of the game. If player 1 chooses X, then player 2 is obviously have to take O. If it is O at the end of the player 1, obviously it is X at the end of player 2. So we have to keep track of each player's move. In step 3, we should know what is the loop of the game. Every game has its own method of running own method of execution. So until the player will win or the game will be drawn or the player will lose, we also have to execute the iterations every time. Every time we have to check every move that player makes. We have to check whether the status of this or the result of this game is in win or draw or in lost mode, right? So we have to loop the game in step 3. In step 4, we have to handle or players moves how the iteration goes, right? In every iterations or every player's move, we have to check whether the character chosen or the inputted character is X or O only. We should not allow any other characters. So the next condition is whether the grid or the number of the cell chosen by the player is ranging between 1 to 9. Either it should not be 0 or it should not be 10 also, right? So we have to check for that condition. The third condition which we have to check is whether the selected cell is filled or not. Sometimes there might be a repetition of that particular cell where the player might choose by mistake. We have to create exception handling methods for all these. What if all this problem occurs? How the code will self-repair, right? In step 4, we have to form exception handling for all the 3 conditions listed. Step 5, we have to update the grid accordingly. Every iterations, every player move, we have to improve or update the grid, right? The grid update according to the player's move is the step 5. Step 6, we have to check the status of the game result. Every step we have to check whether the game is in win mode, lost mode or a draw mode, right? We write function only for win or draw here. Why? Because if it is not both, then it is obviously the player has lost the game, right? So losing would be by default. Either if it is not, he is not winning, nor the game is in draw mode, obviously he is losing the game. So in step before going to step 7, we have to also consider that we have 2 different conditions here. How do we declare the game is in win mode or in draw mode? Win mode has 8 different combination of the numbers or the grid numbers or the cell numbers where the person can win horizontally, diagonally and vertically. So we have to mention all these cell numbers and we have to make if this particular character consecutively falls in this particular combination of numbers, we have to consider that number or that combination into a win mode. So anything apart from this, these 8 combination, it is a draw mode or a lost mode, right? So condition for draw. What might be a draw condition here? When all the 9 cell spaces are being filled, then that particular game is a draw game, right? So these are the 2 conditions we have to follow and check in step 6, right? In step 7, we have to exchange the player turn every successful iteration. After player 1, it has to be player 2. Again player 1 and player 2. So this should go on until the result has been declared either win mode, draw mode or a lost mode, right? The turns to be given in step 7. In step 8, we have to code for scoreboard. Scoreboard is very necessary. So in order to have a scoreboard, we have to get the names of the players, right? Player 1, what might be the name? We should give them an condition or a printf statement or a print statement where they can accept the input from the user, and we have to store that temporarily, their name, until this particular code is being completely executed, right? So we have to maintain the scoreboard. So we have to get the names of the players who they are playing with, right? So either player 1 name and player 2 name also. So that is step 8. Coming up to the step 9, we have to store information related to the game. What are the different information we have in the game to be stored? Which player chooses X or which player will be choosing O? Obviously, if you know one player's option, another player is by default either it is X or O depending upon the player 1's choice. Player's turn. Who is playing first, who is playing second? and scoreboard updates. Every iterations, what are the different score that particular person has scored. How the scoreboard will update is only when that person wins. That's about it. We are not going in depth of maintaining the scoreboard. We are just having the scoreboard, how many games player 1 won and how many games player 2 won. So that's about it. So in step 10, we have to design scoreboard using dictionary in Python, right? So keys will be the name of the player and the values will be the score, that is win numbers. That's about it. So step 11 is having menu for choosing the symbol. First, when we start the game, we have to give options to the players where they can choose either X or O, right? So in step 12, we have to handle and assign players choice every iteration. So what is the move the player is taking, where the X is being placed, where the O is being placed. So this particular move should be taken into consideration and we have to assign and handle player's choice. So coming up to the 13th step, we have to execute the match. We have to execute the code. Every time from starting to end, we have to make sure every player gets equal opportunities, and as soon as the game has been terminated, we have to close the program. So execution should be taken into consideration. So step 14, update the scoreboard accordingly. Every time we win the match, we have to update and we have to ask the user or the players whether you want to continue or you want to quit the game. So accordingly, the scoreboard gets updated. How many games they play, that many times this win number will be updated in the scoreboard. So this is all about the steps to design this particular game, that is Tic Tac Toe, in Python platform. Let's quickly see how do we implement the steps which we learned in the previous videos into a coding format. Why wait? Let's quickly switch to the IDE where we can put up the codes and try to form tic-tac-toe game. So here I've already put up some code in order to make you people understand what are the different functions we need, what are the different elements we need in order to form this particular game, right? Starting from the first step, here I have written a function in order to create tic-tac-toe board, right? I'm using list with places reserved from 0 to 8 because it starts with 0 by default. Hence, there are totally 9 spaces, 9 boxes in the grid, that is 3 cross 3 grid. It is having 3 rows and 3 columns. So these particular curly braces will always let us to put up the values whatever the player or the user puts up while playing the game, right? So this is about the function which we create in order to form a board, the initial grid, right? So that is the function. And hopping up to the next one, we have a scoreboard. So I'm starting with the functions where we need a basic elements like grid, scoreboard, names of the players, etc. So initially the scoreboard will be 0 because no game has been played yet, right? So this is just the scoreboard which is having the heading scoreboard for tic-tac-toe and player names, and the score default will be 0 until at least one single game is played. So that is the function in order to print scoreboard for the tic-tac-toe game. Next, we have function to check which player won the game, right? So as I've told you, we have to check each and every iteration if any iteration might match with these particular 8 combinations. How does this 8 combination come? I'll explain you how it is, right? We have named the grid from left top corner starting from 1 to right bottom corner ending with 9, right? So we have to know 8 different combinations. How am I taking the combinations? I'll let you know. That is row 1, row 2, row 3, right? Again column 1, column 2, column 3. 3 plus 3 is 6. 2 diagonals we have from left to right bottom corner, from right top corner to left bottom corner, right? So 3 plus 3 plus 2, right? We have three sets, because of having 3 rows and 3 columns, 3 elements we have in each set, and we have 8 different combination of those. So if any of the combination, either of the combination in these 8 sets will match, at least one it will match, then it is always considered the person who is matching this either with X or with 0 consecutively in these any of the one combination out of these, he or she is a winner. So this is a winner condition which we have to follow, right? So that is how it will check for these combination. Either of the one set is matching out of all these, it will try to convey, return back the value to the main program that player position, that is player 1, that is current player, is been winning the game once, right, or twice, depending upon what is the loop of the game, whether the game is third game or fourth game. So it depends upon that, right? So here the current player might be player 1 or player 2 has won the game. If it is true, it will return true. If it is false, it will return false. No, none of the combination is being matched, then it is false always. So once it is false, let's check for the next function what it happens. So we have to see when the user is not a winner, at least next in each and every iteration, it has to try to see whether all the grids are being filled. Say, if all the grid or the boxes is being filled, then it is known to be a draw. It is not matching all the combination of the winning combination also. It is filled up with all the boxes. There is no other way. Then either player 1 is not the winner nor player 2 is not the winner. So nobody is the winner here. The match is in draw. The game is in draw. That is how we conclude. So we have to check two different conditions for each and every move the player makes. One, whether any of the person is a winner, or if the match is been draw. So we have to check for these conditions regularly. That means each and every move, each and every iteration. Hope this is clear. Fine. So next we have function for a single tic-tac-toe game. So every game which it goes, it has to go through with this function. So let's understand what is this function all about, right? So here we have to keep the track which position is occupied by X or which position is occupied by O, right? Player 1 will select X. Obviously, player 2 will have to work with O. And X is being put up in which place of the grid? 1, 2, 3 or 4. You have 9 different combination to put up, right? So we have to have this temporary updation databases where which position is taken by which character and which player. We have to keep all these in lane, right? So after this, we have looping, right? Looping, what happens in game loops, usually we have to have some conditions where the exceptions are handled. There is chance of making errors by knowingly or unknowingly by the user or the player, right? What are the different errors it will occur and how to handle? Why I have put up these things in exception block? Let me just explain you this, right? So here I have try block. So what I'm trying to check here is whether the player has given a proper input or not is the first main concern. So what are the different conditions you have here in order to satisfy, in order to clear, is the first condition whether the person is giving any alphabet except X or O. We have to check that first, because keyboard has so many numbers and the user can type anything intentionally or unintentionally, right? So we have to first check for the character is matching. Either it should be X or it should be 0 or O, right? So first thing is that if that is the case, then we have to return an error message, wrong input, please try again later, or something. You can customize whatever you want to print and communicate to the user. Here I have given wrong input, try again. The next thing you have to understand is here, if you could see in if statement, I have a condition. Move is greater than 1 or move is lesser than 9. That means the number which they choose in order to store their character, irrespectively, it might be X or O, where they are storing that on the grid, right? So it should range between more than 1 and less than 9, right? So we have only 9 boxes in the grid. The person cannot give 10, 11, 12 or 13 as in position. When that happens, we have to throw up an error message to the user conveying, please choose the right number between 1 and 9 or 1 to 9, right? So that is how it goes. Next, we have to check for one more condition. First thing, I repeat, we have to check whether we are having a character which is mentioned, which is under the rules, that is X or O. Second, we have to check whether the grid or the box number is ranging between 1 to 9. Third thing which you have to check here, what I am trying to check here is whether the place which is taken or given as an input, the box number, is being filled already or empty. We have to check that first. In case if that box number is being repeated again and again, it will land up to an error. So all these three conditions has to be inside exception block, because in order to self repair the code rather than ending up with a garbage value or sudden stop of the code, in order to avoid all these things, we have to have these conditions priorly in the exception block. So if this case happen, what would be the solution? If that happens, what would be the solution? So we have to think as a programmer what might be the constraints which will come up, right? So here as the third one, as I explained, whether the place is being occupied or not should be taken into consideration. If it is occupied, if the grid number or the box number given by the player or the user is matching, right? So then we have to give the place you have chosen is already filled, please try again, or anything you can put up in order to communicate, to convey to the user what you are doing is wrong, it is already been taken, please choose any other number. So these are the three things which have to keep in mind for every iteration of the game or every time you play the game, right? So apart from that, you have board status. I mean to say, scoreboard should be updated, right? So every time the board should be updated, where we have to have certain numbers that is going on and on. It started from 0 by default. If one particular iteration is complete, that means one particular complete game has been done, we have to at least choose who is the winner or who is the loser, right? Whether the game has been won or it is in draw mode. We have to keep that status on. Then we have to update the positions of the player. The next thing, why we have to update position of the player? The reason is because if player 1 starts, next should be player 2, again 1, again 2. The iteration should go on. So we have to keep on updating the player's position from 1 to 1, 2. That is how it goes. We are appending it, right? We are moving the number. So after that, we have to check for winner. As I told you, every time, every move, we have to check for the winner. So once you give up this, once you give this particular block function, when the player is being considered to be a winner, that means all the 8 different in the combinations which we have, either of the one will be successful out of this 8. Then we have to consider that particular player as a winner. So that is how it goes, right? We have to check winner, player position we have to see, current player we have to see, and the player number that is player number 1. Player 1 has won the game. So we have to declare the player and send the number to the function. So in order to execute, right? So after that, we have to check whether the game is a draw. Right, as the function is written already, the same function will be called here. What is the draw condition? All the boxes in the grid to be filled. If it is filled and it is not matching any of the combination of the winners, the 8 combination, then the game is draw. So we consider the game is draw and we give that particular print statement out to the users to see. So after that, as I told you, switch player moves. We have to switch the player moves every time, either from X or O, from O or X. It depends upon what is the character chosen by the first player. If the first player chooses O, by default we have to keep the second player X. If the first player chooses X, by default we have to keep the value or the character O to the player 2. So it is vice versa. It depends upon what player 1 chooses. Only 2 combinations we have. Either it can be X or it can be 0. So or O. That is how it works. Then you have a main function. where first we are asking, the function starts from here actually. When I execute, you will get to know. Here, what is happening? Player 1 details has been taken. Why? It is for the scoreboard purpose, right? We are displaying the name against the number of winning they have made, right? How many games they have won, right? So player 1 details is taken and enter the name of the player. It will give the output on the output screen. The player will give the name. It is stored. Again, player 2 details is taken. After that, what is the choice of the player, right? Who will choose what? Player 1 chooses X or player 2 chooses X. It depends upon which character is chosen by which player. We have to store that before starting the game. After that, we have to update the scoreboard details, right? With the name, and the by default it is 0 until unless there is no game played. It is by default 0. That is why it is kept as play 1 0 and play 2 0, right? After that, we are printing the scoreboard. The scoreboard function gets executed, which I have shown in before actually, right? After that, we have game loop for series of tic tac. Why I am telling series? Because if the person chooses to play 10-20 times the same game, it has to go on and on. The loop should be on. So that is why first I showed you single loop, then I am showing you in now how we have to take up the game if they want to play multiple times, right? So here we have turn to choose for which player. It is for you, player 1, whether you want to choose X or O. Then they'll say X, then the game continues. Again, it will ask if once particular iteration is complete, it will ask after declaring the scoreboard, it will ask again this particular block will be represented. If I want to continue the game, it will ask enter 2 if you want to choose O, enter 1 if you want to choose X, right? If you want to quit the game for the first time itself after finishing, then please enter 3 to quit. So these are the conditions which I have put up. So again, you have a try catch block. Why? Because only 3 options are for you. 1, 2, 3. It cannot be 0 nor 4, right? We have to check for the choice of the input what the user has given, right? We are passing that input. If it is having a value error, it will show up wrong input. Please try again later, or try again giving certain values, proper values ranging between 1, 2 and 3, right? After that, you have certain conditions again for choosing what the player will choose, right? So if the player 1 chooses the option 1, what happens? He will get X or he will get O. Depends upon it. If it is 2, again it is O. What I've given here, for 1 it is directly X. Yes, for one choice it is given for X. Again, if it is 2, then it is O. So it depends upon it. Like player 1 chooses 1, this part will execute X part. If player 1 or 2 chooses this particular option 2, this part will get executed, right? After that, you have again option 3. So what are the different final scores we have? So before quitting, it will give you the scoreboard and it will quit. 3 is actually quit. I've given enter 3 to quit, but before quitting, abruptly ending the program, we try to display the final scores and quit, right? Any other choices beyond 1, 2, 3, we put up a default statement here that is wrong choice, try again, right? So that is how it goes. Then in order to store every single program, every single game winner, we will use this particular single game function and we try to store the value who is the winner. And scoreboard will be edited accordingly as soon as the game goes on. If it is one game, it will stop at the one game. If it is 2 or 3 or more, it will be considering all the games that has been won by the respective players, right? So every time we have to choose the scoreboard, I mean winner or the draw game, we have to switch between the players and see who has won how much. So in order to do that, we have to update the scoreboard, which happens in this particular code section, snippet of code, right? So that's about the explanation for this particular tic-tac-toe game where we are implementing using Python language. right? So I'll quickly try to execute in front of you what might be the output. So let's wait. It is trying to connect. So I'm using Google Colab in order to make this program work. I mean, implement this program. So quickly, let's wait for a minute. Yes, we got the output screen. So this is how it will ask. First, it will ask for player details. As I have told you, I'm putting the player name as Ram. Player 2 name, again it is, I'll put second name. So initially it will display the scoreboard as I told you. Ram is at 0, Sham is also at 0. So now Ram is given a chance in order to choose which alphabet or which character they need. Either it is X or O, right? So Ram is choosing 1 for example, right? So it will try to put up. Yes, this is the grid how it looks, right? In which place, which box you want to put this X. Ram says I want to put it in 2. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how it is going. So at the position 2, clicking, what is happening? It will give an option for player turn in order to put up 0, the next player, right? So I'm trying to put that into 3. Okay, again player X turn. So we are taking not the names, by we are taking the character names. Player X means the first person who chose the X as his character. Player O means the second player. We are not choosing their names actually here. We are only recognizing when they are playing with the symbols which they have choose. Don't be confused. Okay, so here player X turn, I have to quickly end this. Now I am just trying to count this particular whether character where it should be placed in order to win the game. So it has to be placed in cell 5. I am trying to make this vertical alignment, right? 1, 2, 3, 4, 5. So I am putting the X in 5th box. So let me check. Yes, it is here now. Now it is the turn for the second player who has chosen 0. I mean O, right? So I'll try to give 1. Fine. So this is the condition. Now there is a chance for the player 1 to win, right? They have to put up their character, that is X, in 8th box. So I'm trying to put 8. So generally we know that we are the generally we know player 1 is winning the game because I'm making them win. So 8. Yes. So immediately what happens? One of the condition will be true. What might be the condition out of 8 different sets? Let me tell you. It will be 2, 5 and 8. Right? If you quickly go back and check the winner condition out of the all the combinations we have, whereas see, this is the particular combination. It is okay out of all these 8, and the player is being considered, the first player is being considered as a winner, right? So 2, 5, 8. Okay, so let's quickly see. Yeah, see, this is 2, 5, 8. It is satisfying. Hence the player 1, that is player who chose the character X, is a winner, right? So the scoreboard will be presented. Ram, that is the first player, won 1 match. Right now the win number is 1 for Ram. So next the cases will be seen whether you have to continue. If you want to continue, it is the turn of Sham now. Sham wishes to play the game further or quit. Depends upon the second player. Say he wants to quit. So we are quitting the game now. But if you still want to try, okay, let me give a Sham with option 2. So what happens again? Where you have to place. I am placing in 1. Okay, next X turn. Player 1's turn actually. Now he is trying to put up in 4. Let me see. Okay, again player 2's turn. I'm trying to put that particular O value in the place 2. I'm trying to end this game soon. So I'm just trying to give a proper input. I'm not playing a proper game here, game kind of thing. I'm just trying to put up the values to show execution for you people, right? So this is 5. Okay, so now it's turn of player 2, remember, right? So I am giving 3. Actually, horizontally, it is clear now. 1, 2, 3. Right. So now the score is equal. Ram won the first game, Sham won the second game. So I'll try to quit selecting option 3. What happens? Let's see. So this is done. Yes, it will stop giving us the inputs further. If you could see here at the end, it will finally give you the scores, final scores before abruptly quitting, right? It's better to show the final scoreboard. Final scoreboard we have is Ram has won 1 game, Sham has won 1 game. So that is how it goes. So that's about the implementation for this particular tic-tac-toe game in Python. Hope this is clear. Now here we are at the last section of the session, that is summary. Let's have a quick recap. What all did we cover in this session? First, we spoke about NumPy, the library which generally used in Python to handle numerical computing like arrays, matrices, and mathematical operations. Later, we spoke about Python Pandas, which is generally used in order to make data manipulation and analysis using data frames and series. Later, we spoke about Matplotlib library of Python, generally which is used to create static, animated and interactive visualizations. Then, we also learnt about Seaborn, which is another library of Python, generally provides statistical data visualization and also advanced plots. Plotly Python, generally it is used to build the interactive dashboards and plots. Scikit Learn always supports machine learning algorithms and model building. SciPy is another Python library which is generally used in scientific computing, programming, optimization and integration. PyTest generally automates testing with Python PyTest framework. When it comes to Tkinter, it is generally used in order to develop the graphical user interface, the front end, which we generally do it in HTML, CSS. That can be done with the help of this library. At last, we saw a demo on how to build a game, that is tic-tac-toe, using Python libraries. Hope this session was informative. We'll meet in the next one. Thank you.